Welcome students. Welcome to this practical zero to hero Java Spring Boot and Spring Data JPA course. In this course, we are going to learn everything by doing hands-on. Throughout the course, we will be building the knowledge needed for a particular topic and then we will implement that topic. So this course we will cover in a project-based approach. We are going to build a property management system in which a user can register and then log in. After login, he or she can create multiple properties that he owns, like apartment, row house, whatever. Then we are going to cover what is Spring Framework, what is Spring Boot, what are RESTful web services, how to create RESTful web services, what is the MVC design pattern, what is singleton pattern, prototype pattern, what is adapter pattern, what is a factory design pattern, what is layered architecture of application development. Then we will also cover different Spring Boot annotation that are required for creating RESTful web services and the different status code that needs to be sent for specific type of methods. Then we are going to talk about what is ORM framework, what is Hibernate, and what is Spring Data JPA. How do we connect to different databases? We are going to then cover about the relationship between the entities like one-to-one, one-to-many. After that, we will be also looking into Git and GitHub, how to commit your code regularly to GitHub. What is the pull request process that you should follow? What is aspect-oriented programming? How to implement error handling and logging in your application using aspect-oriented programming. What do you mean by code quality? How to make sure your code quality is good with Sonar Quality Scan. What is Spring Profiles? How does Spring Profile help us in having the same source code but different configuration? What is Maven? How do we do build management using Maven? Postman as a testing tool. Then we are also going to look at Swagger API documentation, how we can automatically generate documentation of our API using Swagger. Then we will look at monitoring using Actuator. We are also going to do a lot of debugging and troubleshooting. So at the end of this course, you will be a confident developer who can work in any company, in any IT project with Java and Spring Boot. So you can be able to easily grasp the knowledge and apply it in your project with this particular course. So this course is going to be jam-packed with full-on knowledge and hands-on. So if you're ready, then join me in the course. Thank you. I will see you there. Welcome. Let's look at what are the softwares that we will need for this course. So go to Google, type Java 8 download. Go to this link. On this link, scroll down all the way to Java Development Kit. And in the Java Development Kit, you can basically go to the bottom in here. Download this exe file for Windows. If you are running on Mac or Linux, you can download your corresponding file. Once you have downloaded the exe file, just go ahead and double click and follow the normal installation process. After that, we need an editor for writing our Java code. So we will use IntelliJ. So type on Google IntelliJ download. Go to this link. Go with this community version which is always free. So download this exe for Windows. If you are Mac, go with this. If you are Linux, go with this. After you have downloaded the exe file, just run it as normal installation process and it will install the IntelliJ for you. We will also need a tool for testing our API. So on Google type Postman download. Click on this link and in here you can download Postman for Windows. If you have different operating system, you can download them here. Again install Postman and it will be just a straightforward installation. Then we will have to download Maven. Maven is our build tool. So on Google type Maven download. Click on that link and then you have to download this zip file. Once you have downloaded the zip file, extract it and just set it in your environment variable like this. Search for environment variable and then you will get this. In the environment variables, you can go and add another environment variable like new, and you can set Maven. Or what you can also do is in the path, just edit path, add up to the bin folder of your Maven extracted zip, and then apply OK. Then we also need git bash for connecting to GitHub. So type on Google git bash download. Go to this link, download this for your Windows, and run the exe file and follow the normal installation process. If you are a Mac or Linux user, you can follow this. Finally, we will need a database. We will use an H2 database, but also we'll need another database. So we are going to use MySQL. For that, on internet type XAMPP download, XAMPP. Go to this first link and then you can go ahead and download this. Once you have downloaded it, just follow the normal installation process and you will be good to go. And later on, we will see in the course how to use all this software to work together. So this is it for this video. Thank you for watching. I will see you later. Welcome. Let's go ahead and generate our starter project from Spring Initializer. For that, on Google, just type Spring Initializer. Click on the first link. After that, you will land on this screen. And as we are creating a property management system where an owner of a property can manage different properties, so let's go ahead and give some package names. So let's say com.mycompany. That will be our group ID for our project, and artifact ID is property management. We can say description is property management system. Let's keep it as a jar project, and you can choose Java 11 or Java 8. Let me choose Java 8 for now. And from here we can choose Maven and language as Java. And we can decide to choose any of these stable versions. So we can go with either this, or I will just go with this one, 2.5.9. This will be much stable than this version. So let's go ahead and add some dependencies that we will need. So first one, look for web. So take this one, Spring Web. This will help us to build the RESTful endpoints. Then I will take another one called Lombok. This will help us to avoid giving getters and setters always. Instead, we can use some annotations and it will generate the getters and setters for us. And finally, I'm going to also take the Spring Data JPA, that is Data JPA. Along with that, I will also need the H2 database. So I will take that as well for now. So for now, this is good enough. And later on, we can add more dependencies as we need. So just click on generate. It's going to download a zip. Go ahead and extract this zip file in a location where you want to keep your project source code. So in the next video, we are going to further continue by importing this project into our favorite editor, either Eclipse or IntelliJ. So as we are using IntelliJ in this course, so I will show you in the next video how to import this project in our IntelliJ workspace. Thank you. I will see you in the next video. Welcome back. So this is the place where I have extracted our project, and now I'm going to copy this and Go to my IntelliJ and click on open and paste the link here for our project and just go ahead and open that project here. So IntelliJ is going to open our project inside this, and then it is going to resolve all the Maven dependencies because we are using Maven as our build tool. So it's going to look for all the dependencies that we have provided in our pom.xml file. Those dependencies it will automatically try to download. So that's what is happening here at the bottom. So if you click here, you will see that it is downloading many dependencies, and once it has downloaded, it's going to keep them in your computer's C drive users folder, and there it will create a folder called .m2, and that's the folder where it is going to download all these dependencies related to Maven. So we had added H2 database, we had added Spring Boot starter web, we had added other things like, so this all got downloaded and they are now being put into the M2 folder of your C drive users location. Once it has done this, then from here on the right side here we can click on this and start to build the project. If you want to regenerate every sources or refresh your project or do a re-import of all Maven, you can click here as well. It's going to try to download if there are any new dependencies. So if we look into our project here, what we see is it has source main and source test. So a source main, and then in the Java is what is the place where we are going to write our Java classes, and source main resources is the location where we can keep some configuration files, some static HTML CSS files, whatever we want. And in the source test we can write the test like unit test using JUnit or Mockito for our files that we will create here in source main Java. So having said that, these are the folders inside src, which is source, and then we have a .gitignore where it is defined what should not be committed to the GitHub repository. So let's say if you don't want to commit another file which you create, you can give it here. So let's say here it says do not commit target folder slash, anything inside target should not be committed. Similarly, help.md, so don't commit help.md. Similarly, there will be a .git ignore as well to not commit .idea, .mvn. These are all excluded, so it won't uh, commit those. Okay. Then we have this POM XML, which is basically all the dependencies related to Maven, which our project needs. And here you see external libraries. So these are actually the references from your M2 folder where Maven downloaded all the files and kept it. So here is the reference. So you see the H2, and then the other dependencies which are transitive in nature, all are kept here. So now we can build our project in multiple ways. We can go to this location by right clicking and show in Explorer and open command prompt there. In this location I can open a command prompt and do maven clean install, or what I can do is I can directly from here on this maven tab on this side, I can expand this a little bit, maybe minimize this and open this and go to lifecycle, and here you see all the Maven life cycles are present: clean phase, validate phase, compile, test, package, install, verify, those things. So if we want to run more than one lifecycle method, so we can click on it and then keep pressing control and click on the another one. So I want to now have run, clean and install together. So do this and click this button. Don't click here the green button, click here. So click this. So once we do this, it is going to also run other things as well, like it will run automatically validate, compile and test and package. So that's how Maven works. If you run a higher version of the goal, then it is going to run its all previous goals as well. And what it is doing now, it deleted the target folder here if it was existing, and then now it is building all the source files that we had here, .java files. It is building them and compiling them to this .java and the other files to .class files, and then those .class files will be stored here in .target. Plus, what it also did is it created a jar file for our project itself, and what it did, it gave the name of the jar file as property management, and then the version it assigned it to this one, and it created this jar file because while downloading we asked it to prepare it as a jar file, and then it created the target folder and kept the jar file here. So if you see, this is the jar file which it created, and also it created other folders where it kept the .classes file. So if you want to deploy now anywhere, you can take this jar file and deploy it, and you can run it by running java space minus jar and then this jar file name. Then it will run as a standalone program, because every Spring Boot application has its own server inside it, like the embedded Tomcat server. But those things we will look at it later, how to deploy any Spring Boot application. For now, Maven clean install, compiled all the classes, and then created a jar file. Put the jar file and the compiled classes in the target folder here, and also took this jar file and kept it inside our computer C drive M2 folder. It kept there as well, this jar file. So this is what has happened, and our build is successful now. That is great. So you can see our build was successful, and while building it did a lot of things. It was building our jar, and as I said, it created a name of the jar like this and kept it in the target. It also ran some tests, and there were no failures and no errors. Perfect. Now if we want to run our project, because this was just the build that we did from here, so you can minimize that one. Just double click this one, and this is a main method class we are seeing. And this main method class, this is the main method, public static void main, like any Java main method project. We have this main method, but this has a special thing inside it. It has Spring Boot, Spring application dot run, and it has the name of our application, which is property management application dot Java as its class, and the argument is being passed. So what this line does is it starts a embedded Tomcat server for us when we run this class. And the Spring Boot application annotation, what it does, it is basically making this class as a Spring Boot configuration class, plus it is also making this as component scan class. So it is going to scan all the components plus also treat it as a configuration class as well. So this is what this annotation would do for us. And also it will enable auto configuration. That's what it does. So if you see, this Spring Boot application class annotation has three things: Spring Boot configuration, so it is making our class as a configuration class of Spring. It is enabling auto configurations, which means if anything, let's say if the database configuration Spring security configuration is present as a dependency here, then it is going to automatically invoke that functionality and bring into action, which means if I put a Spring security dependency here, our application will now become secure and Spring security will kick in and it will start asking us lots of things that why don't you provide user name credentials. So if you put another dependency, it is automatically going to kick in its action because of enable auto configuration. Then we have another dependency and another annotation is component scan, which means it keeps on scanning our whole application folders to find out where are at the rate REST controllers, at the rate service, at the rate component, at the rate repository. All these annotations are defined in which all classes are defined with these annotations, and then it is going to tell Spring container to take care of their memory management lifecycle. So in very short, Spring Boot application annotation comprises of three things. One is makes our class as configuration class, enables auto configuration, and does component scan. And now we can basically right click on this and run this or also debug this. If you see here, we don't have anything, but as soon as we will run once, it will come, this class name will come here. So from next time onwards, we don't have to right click and run from here. Rather, we can run from here with this green button. So let's see. So now we see our application is starting because as mentioned, this line is creating an embedded Tomcat server for us. And that's what is happening now. So if you see here it says Tomcat initialized with port 8080. So make sure on nothing is running on your port 8080. If something is running on your port 8080, you can try to choose to run your application on another port by providing configuration here stating server.port is equal to let's say 98 8089 or something, then your application will start on 8089. But as I have nothing running here, so my application is running smoothly on my 8080 port under Tomcat server, embedded Tomcat server. Perfect. And if you see, we had added Spring Data JPA, hence, and also the H2 database. So the ORM capability of Spring Boot automatically kicked in because of this. You remember enable auto configuration we have added. So this was the thing. We had added an enable auto configuration via this, and that is what it means. It found that there is a Spring Data JPA in the class path, so it enabled the Spring Data JPA or Hibernate related ORM capabilities. If it would have find Spring Security, then it would enable Spring Security capability. That's what this enable auto configuration means. All right. So this is also this one what that you are seeing is a banner. It says Spring. We could provide our own banner as well. We could override this configuration and provide our own banner whenever we want. All right. So this is sufficient information for this video. Let's conclude this video and continue in the next video. Thank you. Welcome. Let's talk about Spring Framework. First, let's talk about what is a framework. A framework is nothing but a platform or a foundation that is used to develop software applications. For example, a framework provides us a lot of things like classes, libraries, functions. Using all these things, we can work together and build a complete end-to-end application. So in the framework in a broader sense helps us to structure our code of our application and build the technical solutions very easily. Hence, Spring is one of a framework which was developed by Rod Johnson in 2003. And what is the purpose of Spring Framework? It helps to do easy development of Java enterprise applications. So with Spring Framework, Java enterprise application development is becoming much easier. So Spring Framework is a lightweight framework and it can be thought of frameworks. Why? Because Spring supports multiple other frameworks like Struts, Hibernate. Hence, Spring is also called as frameworks of framework. If you look into the core of Spring Framework, it comprises of many components, many modules like IOC, AOP. IOC is inversion of control, AOP is aspect oriented programming, DAO, data access object, ORM, object relation mapping, web, and MVC. So if we look at this picture, these are all the modules of Spring Framework. So this part deals with the data access and interaction with the database. This part deals with the interaction with the front-end web interface or UI part. This part is more from the cross-cutting concerns, aspect-oriented programming. And this part deals with mostly the bean dependency injections, those kind of things like creation of a Java class, its object, and management of that object lifecycle and its destruction. This part covers that. And of course, we have something called as the test. This module of Spring Framework deals with the testing capability. So let's look at what is inversion of control. So of control is a design pattern that is used to remove the dependency from programming code. So what I mean by that is, let's say there is a class called employee. In that we have a member reference of address. So the creation of the employee object here is now dependent on creation of address object. So only if the address object will be successfully created, only then the employee object can be created, because creation of the address object is inside the constructor of employee object. Hence, if the address object creation fails, which means the object creation for employee will also fail. That is not good. Hence, this is kind of a tight coupling. But what inversion of control does is it makes things easier. So instead of having the creation of the employee object inside the constructor, we will not keep that. Instead, we will create the employee address objects outside. And when we are trying to create the object of employee, we will pass the address object as the parameter to the constructor. And this reference is now getting assigned. So now, if we are not able to pass anything of the address, then our employee object is not dependent on it. So our employee object creation will happen properly without the dependency of address. So this is called inversion of control, which makes it easy and decoupled to handle objects and their life cycle. So IOC makes the code loosely coupled, and in such case there is no need to modify the code logic if our environment is moved to a new environment. So in Spring Framework, the IOC container is responsible to do dependency injection. That's what we saw here. The whole thing about bean creation and dependency injection is controlled by inversion of control design pattern. So let's understand what is a Spring Bean. So Bean is just another Java class whose object creation and destruction will be managed by Spring Framework. So any Java class whose object creation and destruction of that object, releasing of the memory, is managed by Spring Framework, then we will call that Java class as a bean. So Spring Bean has many scopes. Every scope decide how many instances of the class or the bean instance will be created and used. So what it means is the same class can have multiple scope. And how does it depend which scope is what? Based upon how many instances of that class will get created or the bean will get created. So to start with, let's say singleton scope. So in this scope, for a particular bean or for a particular class, only one instance of the object will get created and that will be reused. And this is also the default bean scope of Spring IOC container. Next bean scope is prototype. Here what happens, multiple instances of the one class gets created. So here we will have one bean with many number of objects. After that we have request scope. In this scope, the the bean life cycle or the scope of the bean object will depend upon the HTTP request. Until the time HTTP request is valid, the bean memory is valid. Then we have HTTP session. This is a bean whose scope will be valid for a complete HTTP session, which means it will be valid between multiple requests. Then we have global session. This scope of the bean definition is tied to a global session. So even this is tied to the user session and this is tied to the global session. Now let's talk about what is Spring Boot. So Spring Boot is an open source Java based framework used to create microservices. So Spring Boot is nothing different than Spring, but it is a nice way and fast way to start developing microservices or RESTful APIs. So Spring Boot is built up of Spring framework for faster development of microservices, and it was developed by a pivotal team and is used to build standalone production ready application based on Spring framework. So there are some Spring Boot annotation. Let's try to understand. At the rate bean, if we create a method with a name and create a new object from that method and declare this at the top of this as a at the top of this method, then now this will return a singleton bean whose scope will be managed by Spring. Similarly, auto-add. Auto-add is a way to pass one instance of one object to another class instance. So here in the employee, the instance of person P object will be passed from outside and assigned to this P. This is called object auto-wiring. We are going to look at all this with examples in upcoming videos. Configuration. Configuration is an annotation used on the classes on which we will define the beans. So the class where we want to do this kind of methods, it should be defined as @configuration class. Also, we can define configuration class on top of any class which we want to make it as a singleton bean. Then we have component scan. Whenever we put a component scan, we define a package. Whichever package we define, now Spring will start to look inside that package for all the singleton beans. And then Spring is going to take care of the memory management for those particular beans. So this is it for this video. I will see you in the next lecture. Thank you. Welcome back. Now that we know on a high level what is Spring Framework and what is Spring Boot, let's try to understand what do you mean by RESTful web services and how Spring Boot helps us to build RESTful web services. So if we see, this is a server which can be hosting any application like with Java, Servlet or Spring, and this is internet. There can be many clients like laptop, mobile and a television. They can call to this server and talk to this server by the help of JSON request. JSON is the format in which the data will be exchanged between the client and server. It stands for JavaScript Object Notation. So we are building once the server API in a format which the clients can understand and any kind of clients can understand through the help of internet. So what is a web service? A web service is a collection of open protocols and standards used for exchanging data between applications or systems. So software applications can be written in various programming languages and run on various platforms. over the computer network like internet in a manner similar to inter-process communication. So there can be program written on any technology here, and this can be client built on any technology, but they can interact with each other with the help of this RESTful web services and certain protocols. So REST stands for representational state transfer. REST means representational state transfer, which means REST uses various representation to represent a resource, where text, JSON, XML, these are the different formats of resource. So when a client tries to talk to this server, there can be different formats of data exchange in a text format, in a PDF format, in a JSON format, in an XML format. So web services based REST architecture are known as RESTful web services. So those architecture which are based on RESTful, those architecture which are based on REST architecture, those types of web services are called RESTful web services. So what are RESTful web services? Web services based on REST architecture. And what is REST architecture? There will be interaction between client and server over internet through the help of either XML or JSON format. So now RESTful web services usually have a URL. So every URL is mapped to a resource at the server. So there can be multiple URLs. Each URL is mapped to a particular resource on the server, which means a function. So REST is a web standard based architecture and uses HTTP protocol for data communication. So REST actually is based on HTTP protocol, which means over the internet it can exchange data between client and server. So REST revolves around the resource where every component is a resource and a resource is accessed via a common interface using HTTP standard methods. And REST was introduced first by Roy Fielding in 2000. So what it says is REST RESTful web services are dependent upon HTTP protocol and the different methods of HTTP protocol that we are going to see now. And this REST was concept was first introduced by Roy Fielding in 2000. So these are the different methods of HTTP protocol which REST-based architecture uses or RESTful web service uses. So using this HTTP protocol and one of these methods, the client is able to talk to the server over internet, and the data form that is getting exchanged is either XML or JSON. So get provides read-only access. So if you have to read something from the server, the client should use get request of HTTP protocol. Get method of HTTP protocol. Put, it is used to update an existing resources on the server. Delete is used to remove a resource from the server. Post is used to create new resource on the server. Patch is used for partially updating a resource on the server. Patch is same as put, but it is used for partial update. Options is used to get supported operation on a resource. So let's say there is a resource. What are the different kinds of action that can be taken on that resource on the server? We can come to know with the help of options method of HTTP protocol. So here is our client. It is can do a post, put, get, delete, patch operation via HTTP protocol to our server, and based upon the type of method, our server will do some other calls to other backend system or maybe interact with the database server, and then it can respond back with another response here. So HTTP request has five major parts. One is the verb, which is the HTTP method get, post, put, delete. URI, which is the URL of the resource. HTTP version, which is the which version of HTTP we are using, and then request header, which contains different metadata information like in the key value pairs. So in future we are going to look at how a particular REST call looks like, and at that time we will see these are the different fields or values we will be able to locate. URI stands for Uniform Resource Identifier. So a URI is formed of protocol, which is HTTP, then the service name, resource type, and resource ID. So these are some of the example of RESTful web services or APIs or endpoints. Post, get, get, put, delete, delete, and this is also another example. So we are going to look at all this in detail in our upcoming lectures. So as per REST architecture, RESTful web services should be kept as clean as a client state on server. Should not keep the client state on the server. What it means is when we are building RESTful web services, one request should not be aware of what did the other request did. That's why RESTful web services are also called as stateless. Stateless means one request from one client to the server was not being known by any other request that will come in future or came in the past. So the RESTful web services are stateless. It is the responsibility of the client to pass the context to the server, and the server can store this information to process client's request further in future. So if they want to maintain the state, so now the client will make sure it will find a way that the server should recognize that it is the same client which was sending the request in the past. Otherwise, by default, the server will not understand any new request coming from the same client. It will treat the request as a completely new request coming from separate client. So idempotent operation means there will be always the same result no matter how many times these operations are invoked. So put and delete operations are idempotent, which means if you try to update a resource, let's say, then if you try to update it as many times as you want, it will get to give you the same result. If you try to delete an operation, delete something from the server, you try to do as many times as deletion, it will return you the same result. That's why update and delete are idempotent operations. As mentioned, HTTP protocol has some methods that we covered: get, post, put, delete, patch. HTTP also protocol also has some status codes which it returns. So if we return 200, it means it's okay, success, everything is fine. 201, something got created on the server, like in the example of post and put. 204 means no content was found. So let's say a resource was deleted on the server, then we can return 204 in case of delete operation. We can return 201 in case of post or put. 304 is resource was not modified on the server. 400 means it's a bad request, which means server is not able to understand the request that is coming from the client. 401 is means forbidden, that this particular resource is not allowed to be accessed by somebody else. 404 means the resource was not found on the server. The resource that was looked for was not available on the server. Next, we have some Spring Boot annotations. So these are the important annotations. One is enable auto configuration. What it means is, let's say there are 10 functionalities that we want to offer, but the 10 functionalities has to be enabled, right? But then how it works is, if we have enable auto configuration on our main class in Spring Boot, then if we just add the Maven dependency of a particular functionality, this enable auto configuration will make sure the functionality will kick in. Let's say if we put the Spring security related Maven dependency in our POM XML in the class path, then this auto configuration is automatically going to invoke the functionality related to Spring security because it found the dependency in the class path. Then we have added Spring Boot application. This annotation is a combination of three annotation: enable auto configuration, component scan, and configuration. Auto configuration enables the automatic configuration or enabling of the functionality of the component it finds in the class path. Component scan, it scans for all the packages for the different Spring Beans. Configuration, to make any class as a bean class, we can declare it as a configuration. Component helps us to declare any class as a singleton bean. Controller helps us declare any class as a Spring controller. Service is used to create another singleton class. Remember, controller, component, all these are creating singleton class. Same way, service and repository also create singleton class, but service is mostly used for business layer, and repository is used for the database access layer. Request mapping helps us to map a particular URL to a function. As we mentioned, In RESTful web services, everything is a resource which is mapped by a URL, which means this particular URL is mapped to a Java class function. This is mapped to another in the same class another function. This is mapped to another same class another function. So if we see in that sense, if every URL is mapped to a function, then there are certain annotation which helps to do this mapping. Request mapping is one of the annotation that helps us to map the URL to a particular class and its function. Request mapping is one of the generic way to map it, but if we want to go with a specific method type mapping, then we have get mapping, which is used to map the get request. Post mapping maps the post request of the HTTP URL to a method. Put mapping for update, delete mapping for deleting, patch mapping for partial update, and request body. This is used to convert the JSON format of the data that is coming. So at the start we saw this JSON format of the data that will come from client should be converted into the Java objects, and this is done with the help of @request body annotation. Similarly, path variable. Let's say in the URL we want to get this information. So if the URL, if this URL is containing something with after slash, let's say 1 2 3 number, if I want to get its value in my function, then I will have to use the annotation as path variable. Similarly, here this is not after slash but question mark title equal to something. So let's say I want to access the value of the title in my function. Then I have to use not path variable but request param annotation. So we are going to look at all this annotation, how they work with hands-on example. So this is request param. Similarly, if we want to access the header which is coming in the request, we can give @request header. And if we put any class with an annotation @REST controller, then it is a combination of a controller and response body annotation. So this response body helps us to convert the Java class into the corresponding JSON object, and it is itself annotated with address response response entity annotation. So response body annotation and controller annotation is equal to REST controller. So we are going to look at all this with examples. If the REST controller is used, then there is no need for annotating each method with REST response body. So this is an example how we can declare a simple class it as a REST controller class and give a request mapping on the class level, but get mapping on the method level, and we can get the request param which will give us this value. And in the request param we can also say whether it's a required field or not. And if you want to get the path variable value like this, then you can do something like this. We are going to look at all this with examples. One thing to notice, let's say if we want to access this controller endpoint from some other IP address and port like some other client, then we have to on the controller level make sure to give address cross origin. The reason we have to do this is because our server and client are running on different IP addresses, and by default any browser for the security purpose blocks that if you are not running on the same server or same IP, the request will get blocked. Hence, by saying cross origin on our controller, we are saying to our controller allow request from any IP address. So this is an example, but we are going to look at nice examples in our upcoming hands-on lectures. So thank you for watching this video. I will see you in the next one. So today we are going to talk about a design pattern which is called MVC, Model View Controller. So let's understand why do we need a design pattern. First of all, what is design pattern? So design pattern are basically such a patterns. You can say patterns means it's such a way of organizing things that will make your life easier while you are building a big application. So it helps the developer to organize the code for a big and complex application in much simpler, repeatable forms. So that's why design patterns have become popular And model view controller is one of the most popular design pattern seen throughout this evolution of microservices development. The reason is it provides such loose coupling between different components so it can be easily scaled and complex functionalities can be easily achieved using the same structure. So let's try to understand what exactly is model view controller MVC design pattern. For that, let's understand how a request comes from the user first. So if you see, this is the user makes a request and then it has to go somewhere on the server and then some operation should happen, maybe fetching data from the database and then passing that data back to the controller and then the controller asking for the page on which this data to be shown and then bundling this data together and sending it back to the controller and then the response is sent back to the user. So in a nutshell, this is how it works. But let's understand now in very detailed way. The reason of separating the model view and controller in separate boxes is that each of them has their own responsibility that they have to uh, get through. So let's we look at what is the responsibility of model, what is the responsibility of view, and what is the responsibility of controller. And when does this responsibility comes into picture? While processing the request which is coming from the user. So every block here has a specific functionality. So let's try to understand each of the blocks responsibility here. So let's say first there will be a request from the user to the server, and the server will basically first check the URL, and based on URL, so let's say this is number one when the request is being made. Now this request will be having certain URL, and based on that URL, server is going to send that request to a specific controller on the server, because on the server there are many controllers running. Now as the specific controller which matches this URL receives the request, then this controller is going to tell the rest of the application what needs to happen, and that's why its name is controller. It controls the processing of the request. So let's write down the first functionality of this is handles request flow, and then as this is meant for handling the request flow and then interacting with the model and the view, so this controller should not have lot of logic. Otherwise, we are defying the purpose of the model view controller design pattern. The job of the controller is just to handle the request coming from the user. So based on the URL, the request gets mapped to a particular controller. And then its next job is to navigate or do the controlling part with the model and the view for that particular request. So we should not have a lot of business logic in the controller layer. Let's let's look at what happens next. So after the controller receives the request, it sends this request to the model to get the data for it. Basically, model is responsible for doing everything that's needed to process the data for this particular request. So let's put it here as point number 2, get data. Now that the model receives the request, its job is to basically first handle the data logic like it talks to the database, does all kinds of SQL queries, saves the data, does all the validations that's needed, those kind of things it does. When I say data logic, it does the validation and then does the querying on the database, fetches the data, populates the Java model or the model object. The second thing that it does is, of course, interacts with the database. So these are the two things that the model does as soon as it gets the request from the controller. So now it simply means that the controller doesn't have to worry about any data logic or interaction with the database. It just sends the request to the model, and then the model knows what data logic and how it has to interact with the database to process that request and fetch that data and return that to the controller. So they are independent. They don't interfere in between their jobs. So what happens next? Then the model sends the data to the controller. The data which was requested is returned here. Then the controller knows how to handle all the uh, error handling and what kind of next page or the view or the navigation that has to be shown. The controller will do it next. So here, let's write down a point. Controller never handles data logic. Controller is not responsible for handling the data logic. So next is, once the controller receives the data from the model, it is going to send a request to the view. So now the request is sent to the view. The controller asks for the specific view for this particular request. So let's mention here, get presentation. And now what is the responsibility of the view or the presentation? Its job is to just handle how to show the data, how to show the data which is returned from the model to the controller. So this data, let's put that in words, handles data presentation. So view is just a dynamic, let's say HTML, which is getting the data, and its job is to just show it in a nice way. So dynamically renders the data, dynamically rendered, which means, let's say if the data changed here, so model is going to give a new data to this view. This view is going to show the new data next time. So the job of the view is just to handle how to show the data and render it dynamically. So once the view has presented the data, it is going to send the response or the final representation of the view back to the controller. Let's put it this way. And now the view knows, the controller knows to return this particular view, which already has the data rendered, to the requester. So we have the response here. Let's put it here. Yeah, the response. So now the user gets the response. One of the important point to keep in mind is in this design pattern is that the model and the view never talk to each other directly. If you see, there is no link between the model and view. Everything happens via the controller. So this is a very key concept of this model view controller design pattern. We have to keep this in mind. The biggest advantage of having no interaction between the model and the view is that you don't worry about how to fetch the data. The view doesn't have to worry about the how to fetch the data. Similarly, the model doesn't have to worry about how to show the data. So the controller is the middleman who is acting and doing the coordination between the model and the view, which means now you can build a very complex application in using the same format and the same pattern, and then the application can keep on growing. Even doesn't matter, the complexity increases by 10 folds. So that's the advantage of following model view controller design pattern. Okay, let's take an example of a user requesting a list of products, all the products. He wants to see all the products. So the request is like slash products. Now on the server, the controller which is responsible for handling the products is being invoked. So that particular controller, product controller gets invoked, and that product controller calls the model and asks for the data for the products. The model then queries the database. Let's say select star from product table, and the model returns the list of products here. And if the controller receives a successful list of products here, the controller is going to ask the view to give a view which is responsible for showing this products, all the products. Now the view is going to embed all the products inside it and is going to return the view with embedded products data. Then the controller is going to respond back to the user with the HTML page and the CSS style in it with the products data. But let's say while fetching the products from the database, the model does not get the products and it returns error. Then the controller is going to ask the view again, but this time it will ask for error presentation, error page, where it will show that something went wrong while fetching the products. And that presentation will be returned to the controller. And then the controller is going to return that to the user, that there was an error accessing the products. So this is how controller is doing all the controlling mechanism. So if you see, the model handles all the data part, the view handles how to show the data, and the controller tells the model what needs to be done, and the controller tells the view what needs to be done. And the controller interacts with the user, and how does the control specific controller gets invoked based on the request URL, because there are many controllers here, many models, many views. So each controller gets invoked with this on a specific URL, and that controller knows which model to invoke and which view to invoke. So this is how the model view controller architecture works, or the design pattern works. All right, what we have seen so far is the traditional model view controller design pattern. But this used to be the case until the time when we were having the user, it was a monolithic application. Monolithic application means everything was inside the same application, the controller, the model, and the view. And from the browser, from the request, the user was sending the request from the browser, and then the response was returned as an HTML. The response was returned as an HTML because this view is an HTML presentation, so it had the data. So the response was here an HTML. This was the case. So let's put it here as HTML response. In the traditional MVC, HTML response. But now, when we are learning the microservice implementation or the API development, then the response is no more an HTML. It is a JSON. Most of the time it's a JSON. So let's copy that picture and go ahead and put it here. So this is basically, so this was monolith architecture MVC design pattern, where the response was HTML. That's what we saw. But now we are learning the API based development, the microservice architecture. So here things will slightly change. So what is going to happen is this. In the API architecture, in the API architecture of MVC design pattern, what will happen? We will still have the model, we will still have the controller, but the view will disappear. The view will disappear. And then the controller is returning back not the HTML response, but it is returning back the JSON response. JSON response. The JSON response is being returned. And now there is the the whole HTML or the cloud, the CSS and styling and rendering of the data. All this is now handled at the level of the client side on the browser. So here there will be an Angular app or React JS app, or normal HTML, CSS, JavaScript to render the JSON data. So this application now knows how to show this JSON response data. So now we got rid of the view, all the processing overhead that was done here by the view, and then the response returned. So that now the job of the controller is simple. It doesn't have to worry about which view to pass this model and then get the view back and return back the view. No, now the controller just receives the JSON request, takes it and interacts with model and returns back the JSON response. So now the request also becomes the JSON request. It's now going to be JSON request. So JSON is JavaScript object notation. It's a simple format, neutral format to talk to between client and server. And now the whole responsibility of showing the data, rendering the data is back to the client side application or browser side application or any single page application framework like Angular, React, Vue.js, or maybe a normal HTML, CSS, JavaScript. So this is the small change that has happened. So we are going to focus on this API based development because this is old technology. This monolith architecture of design pattern is old technology. It's not followed anymore. So let's put a demarcation here. Hope you understood this. It's a very simple thing. Model view controller design pattern. Responsibilities are defined with model and view and controller. They know what needs to be done. Controller facilitates all the things between the model and the view. There is no direct interaction between the model and view. This helps in achieving quite complex functionalities in a bigger application much easily and scale your application to the next level if this design pattern is followed. Welcome. Let's go ahead and create our model classes. What do I mean by model classes? So whenever we work in an application, it has few layers. Number one layer is this, then it has some layer like this, and this has another layer like this, and here is our client. So this is our client, and this client can be a browser, mobile app, or just tools like Postman who can consume our API. So this client makes a request. So first it comes to a controller layer. What is it called? Controller layer, controller layer. Then this client is trying to send some data to us, and that data will be in the format of a JSON, and this data can be like a title, name, description, those kind of information. And here we have our controller layer. So now this controller layer has some methods. For each type of URL which the client is trying to talk, that there will be that many types of methods in the controller layer. So let's say this client is trying to access this method, which is like a create property, and this client is trying to pass this JSON data. JSON data means JavaScript object notation based data. But this controller is in Java. This is not in JavaScript, and this is coming as JavaScript. So JSON is nothing but JavaScript object notation. So this is JavaScript, and here controller is Java. So Spring somehow does some magic. It converts this JavaScript JSON object into Java class. And that Java class should be able to hold these values of title, name, description if there are any more fields. So that class we are calling as model class. So we will create a model class to hold the information which is coming from the client. And this JSON will be directly mapped to this model class variables, and the values will be automatically converted from JSON to model in Java and Java model to JSON. This will be done by Spring Boot using some kind of parser, JAXB parser. So now we are going to create this model that will help us parse this information. Let's go ahead and do that. So for that, we go to our application in source main Java, right click, create a package called model, and we are going to, this is as you can call as a model, or also you can call data transfer objects, because this object is not on, this is going to help us transfer the object. So take this data and transfer it here. We can also call it as model. So DTO or model. So now we will create a class inside it. Let me convert this to DTO only for your understanding. In industry, we either call DTO, data transfer object, or model, doesn't matter. So DTO. So we will create the first DTO that we want, that is property DTO, property data transfer object. Okay, so what are the fields that it will have? Of course, any property that you see, whether it's an apartment or a row house, anything that has certain types of fields. So first field is private best practice is to keep every field as private. So private string property name, let's say, or property description or details. So I can say it as title. So here it will describe what kind of property it is, like two-bedroom apartment, one-bedroom apartment, this thing. Then I have private string description. So we will have a description of the property. Perfect. After that, we will have a owner of the property. So private string owner name. Then we will have owner in email, private string owner email. You can keep phone number as well, but for now I will just keep name and email. Then this property itself will have some price. So we'll say property private double and price. After this property will have an address, private string address. Perfect. Now these fields are private. In order to access them outside this class, we have to create getters and setters that are public method that will help us read and write into these variables. So right click on this and we do generate, choose for getters and setters, select all the fields, click on OK. So now it has created the getters and setters. So either we could go with this approach, we can have getters and setters created, or if we want, we can directly skip this getters and setters and we can take help of Lombok. And Lombok provides us some annotation using which we can also declare getters and setters. So here I will say at the rate getter. So for how do we call any annotation? With the help of at the rate and then the name of the annotation. So I will say getter and that is coming from Lombok. Then similarly we will take at the rate setter. Again this is coming from Lombok. Perfect. So we have created our DTO object. That is great. And we have also seen how to create getter setters or use Lombok's getter setter annotation. So this is it for this video. Let's continue in the next one. Welcome. So we have now created our DTO. So let's go to the diagram again. So now our model has been created or DTO has been created, which can capture the data which is coming in the request from the client. But we have to also create a controller. Only then our client will be able to make an HTTP request to a particular method inside this controller. So let's go ahead and create our controller. So here I will create another package for controller. So I will say right click in new package and say controller. Hit enter. So right click and create a class called property controller. Hit enter. Great. So let's create just a hello world method to understand how a controller works. So I will just so now this is just a Java class. There is nothing special about it. So I'm going to create public string a method say hello. I'm just going to create a string method public string say hello and return from here return hello. That's it. And now I want to call this from my browser. I want to do something like this. HTTP, because browser is also I'm going to say localhost, and then I'm going to say 80 80 and then give some name. Let's say hello. When I want to hit hello, I want to basically from my browser, I want to make a call to my Java class. Now nothing happened because this is just a Java class. This does not have the capability to intercept request coming from browser like here. So we have to take help of Spring and Spring Boot to enable this normal Java class into a Spring Boot REST controller. By doing that, it will be able to take the request. So let's do that. So now I'm going to make this as, or I'm going to give this normal Java class a super hero power to interact with the browser. So what we have to do for that? I have to just say REST controller, and I also want this controller to be able to access request, receive request based on a particular URL. So I'm going to say at the rate request mapping, and here I will say I will just give some name. So I will say API slash v1, and now I will say slash properties, or I can even ignore this and I can say API slash v1, and here I can say what type of request will it be able to intercept. I want to say HTTP GET request. So like we are making giving our controller a capability to intercept any request that is coming from browser or a client like Postman, or let's say a mobile app. By using these two annotations, similar capability we can give to our methods. So using this, it can come to one of our controller. Let's say there are 10 controller classes in our project. So using this, it can come to one of our controller. So if I say this as properties, so it can now come to properties controller. Similarly, there can be, let's say, categories. So we can give similar URL API slash v1 slash categories. So it can come, it will go to categories controller class. But now if when it comes to one of the class, enters inside one of the class, we also have to tell inside that class which method it should go to. So here, and what type of method it is. So any HTTP request comprises of get method, post method, put method, delete method, head, patch, those kind of methods. But for our concern is get, post, put, delete. So what does a get method do? So we will say at the rate get mapping. And what this will do? This at the rate get mapping will now try to take any get request that is coming from our browser or from the client. But I want to access it under a URL slash API slash v1 slash properties slash hello. So I have to also say slash hello. So if I now save this and start my project here, I don't have to build it again by Maven clean install. Only build it again if it is not reflecting your changes. Otherwise, I can just click on this button which is going to run this class, which was our this class, and that is it. And now what I have to do, I have to go to my browser and copy this URL, and then I have to go here and paste this URL. Be careful, this is the double slash, and then also put the So this until here it is going to come to this particular controller class, right here. But in this class there can be many methods. It's a get mapping, multiple get mappings, some post mapping, put mapping, delete mapping. So what I want is to have a get mapping class with this URL. So I'm going to copy this URL now, go here, and here's I would say I want to go to this one. So there you go. Now it says hello, which means now we are somehow able to connect from our client, which was here the browser. We are not sending any data now, but we are able to call from browser via HTTP protocol. Which protocol? If you see here, what is the protocol it is using? HTTP colon double slash. So that's the protocol it is using. Via HTTP protocols, what method? Inside HTTP protocol, what is the method it is using? Let me show you. If I refresh here in the network, we can see. If I refresh, go to the network all, you see this is the URL. This is the URL HTTP protocol, and localhost is the computer on which our application is running. 8080 is the port, and slash API slash v1 slash properties is the name or path of the controller, and slash hello is the method inside the controller which is of type get. So if I click on this one and click on headers, you will see, click here and click on headers, you will see it is a get request. Request method is get, and the request URL is this. So who is making this? Browser is making a get request URL to our server, or browser in this case is the client here. It is making a get request to our server which is running in the Spring Boot embedded server, Tomcat server, which is running on localhost 8080, and it is trying to make this method call, not this method, this method. How come? Because it got identified by the help of the URL. So this is called RESTful Web Services, RESTful API. And as soon as it reached the method here, the method is a normal Java method which got executed. It just got executed, and here the logic says is just return a string hello. It can be here the logic could also be calculation of addition of two numbers, or doing some other logic, calling to another service or database layer to save some information or to get some information from the database. Any kind of logic can be done now from here. So now we saw how to make a connection, right? Connection by how can we make a normal Java class and its normal Java function into a RESTful web service, RESTful API. So what is RESTful API? RESTful API is nothing but a simple Java class function can be converted into RESTful API, so that that can be now accessed with the help of HTTP protocol, with the help of a URL. So a particular URL is mapped to a function, that is RESTful web service. So this is what is RESTful web service. So this URL is mapped to a function. That is what is meant by RESTful web service. And now what this function returns goes via as a response of this RESTful web service back to the client. Here it was the browser. So I hope you now get it what is RESTful web service and how to create a normal Java class and its function and convert it into a RESTful web service using the two annotations, REST controller and get mapping. And of course for extra annotation you can use this, but you can also ignore this and run it and just now access the URL with the slash hello. You have to now get rid of this part and you will still be able to access, but it's a good practice to make your URLs more specific and keep versions, version 1, version 2, version 3, because in future there can be different version of the same controller. So this is our RESTful API, is just mapping of a URL to a Java class function. So can there be many RESTful APIs? Yes, of course, there can be many methods here in the same class, and they can be connected with different kinds of URL to the browser. So can we accept parameters coming from the browser in this? Yes, of course we can do that. Otherwise, how we will? Otherwise, it is more static. So as our functions accept some parameters, our APIs can also accept parameters, and there are different ways to do that. So in upcoming videos, we are going to see how our controller class can accept parameters from the browser. So this is it for this video. I will see you in the next video. Thank you. Welcome. Let's go ahead and explore further what we can do more with this particular situation, that when the client is trying to call to the controller, what are the different ways it can call and what are the different possibilities. So let me create another board where we can zoom it a little bit only to this layer. So now we will just focus on our controller layer. So this is our controller, and after this there will be other layers. We will not worry about them. For now, just let's say this is our controller, CTRL. This is our controller layer. And here we got a client. And this client can be anything. A mobile app, a postman, or a web browser, a React application, an Angular application, or anything. So we will just call this as a client. So let's say client. This is client. Now we saw that the client and this controller can have method number 1, number 2, number 3. So we saw this controller was just a Java class where we did some mapping. So we said, let's say like this some mapping, and then we gave some mapping to our method as well. This method we will also give, and this method. So we were able to form a URL with the help of the class level mapping to the method level mapping and reach here. But what if the client wants to send some information? Let's say from here to here. He wants to send some information. So let's see how we can do that. For that, let me create a practice controller. So let's say we will create a controller for doing calculator operation. So I will say calculator controller, and we can also have a calculator DTO. So let me put it this way. So I will say calculator DTO. So let me stop the server and close everything except this. So I will close all. Just open our calculator controller. As we know, this calculator controller is just a normal Java class and it has some functions. Let's say we'll say public, and it returns some kind of information. So we can say public double, and then we'll say add function. Let's say similarly we can say, and it takes two parameters. So let's use integer num1 comma integer num2. Those are the parameters, and what it will do nothing but just return the addition of these two numbers. So num1 plus num2. But this is a different data type, so let's convert this to double. because we can have a floating point number also, like decimal value number as well. So now I could do REST controller, that is mandatory, but having request mapping is not mandatory. I could directly go and say get mapping, and then I could say slash add. I could do this. So let's try to start our server and see if we just try to hit this, what happens. So I will click here, start the server, and now I will open Postman. Of course, I could make calls from browser because it is a GET request. So from browser we can make GET request, but I will use Postman, and we will use HTTP protocol because that's what the REST API follows. HTTP colon double slash localhost colon port 8080. That's the port. From where will I get the port? If I open this in the console, it is printing me that the port is 8080 on the local host. That's where our server or Tomcat server is running. So now if we go to our picture, we have our controller created. It has an add method which is URL of slash add, and now we will try to make a call from our client, which is now, it was browser but now it's Postman, and we will make an HTTP get call. So what is this? We have HTTP methods get, post, put, delete, patch, copy, hard, but we will just focus on get, which means we will just ask the server to give us some information. So what is the URL? So up to here I can reach to the server, but the server can have many endpoints. So I would like to call add. So let me see. So I will say add add. That's the mapping add add. Let me try to hit. So what happens? I get an error. It's an internal server error. And let's check what is the error here. So it gives us some sort of error. What it says, null pointer exception. What does it mean? So if we see here, it says null pointer exception. In this calculator controller line number 11, there is an error. So if we scroll to the right, there should be more print stack trace of it. So here it's not detailed, but it is clear enough that there is a null pointer at a particular place, that is at line number 11. So click on this, it will take you to that line number. So this is the line number. So here this value by default, if you know the value of this kind of capital double, capital D, this is called wrapper class. It is we could have written small double, which is primitive data type, but we want to use capital double with the wrapper classes, and by default the wrapper classes value is null. So it was trying to add null plus null, and that's why we got null pointer exception. So if you want to see what happened, let me run this in the debug mode. I will put a debugger here and run it with the debug mode. So this is how you also debug. So you will see what will happen now. Now our server is going to start in a debug mode, which means we can see the values of our variable whenever we want. So let's the server start. I will take this here, and this is how you put debug point. Just click once with your mouse, left click, and if you click it goes away, click stays, goes away. So try to keep this within the executable line. So here within this, so this is an executable line, so I will keep it here. So now it says the server has started. So let's go ahead and hit it again. So now when we hit, it stops, the program stops here, the debugger stops here. So now if I hover on this, it says num1 value is null, num2 value is null. Let me try to right click, and also I can say right click, and make sure to right click on this, and then right click, and you can say evaluate, and it says null. What did it means null? Because we are not passing anything, the value is getting null. And of course, after this, it will give us a null pointer exception. Great. So let this click here to resume the program. So it will further continue. So how we can solve this problem? But before that, let's make it more better by adding class level mapping as well, because we should focus on best practices also. So for best practice, we should add like this class level mapping as well. So we will say slash API slash v1 slash calculator, and then in that there is a function called add. So now our endpoint will also change. So we will have to copy this, and we have to, before the add, we have to paste this slash. Now it will do the exact same thing, but we have a problem now. So let me show you that. If I run this and try to hit, nothing will change. It will come here. So this is class level mapping of URL to a controller class, and this is method level mapping of a URL to a controller function, right? To a controller function. So if we say what is its value, so this is its value. So if I come and hit this, we will get the exact same thing. It stops here, but we know that we will get null pointer. Okay, so how to fix this one? So somehow this function is expecting two numbers. So if I could create, let's say, another main method class here. Let's say I will say calculator main, and just create a main method class. I will say public static void main, and I will say string array args, and now I can now just say, I will stop this server. I will say calculator controller cc is equal to new calculator controller, and now I can say double result is equal to cc dot, I will just call the method add method of the calculator controller class. So in the calculator controller class we have this add method. So I'm now calling that. Let's say I will pass the value as 4.5 comma 8.5, and now I can print it system dot out dot println, and I can print result. If I run this program like a standalone Java program, I will get my result here. You will see I will get the output, and the output is 13.0. But what I had to do, I had to first create an instance of controller and then call its method, pass the value. If I pass the value, let's say 14.5, and then run it again, then again I will get a different value. But somebody has to do this, right? Because here, this is the add method. Somebody has to call it and pass the values. So who is calling it? Already when we are annotating these things with REST controller and mapping, it gives this method a power to be called from the URL instead of running as the main method program. But we are not passing any value. That's the problem. So let's pass the value. So there are different ways to pass the value. Let's see the first way. So the first way is, we can say before this @request mapping, and here we can give a key. So let's say I will say num1. And similarly, we can have another mapping as well, and then we can say num2. So these are annotations provided by Spring. So here I can, this is one request, sorry, it should be request param, not mapping, because what we want to do is pass the parameter to this function as a HTTP request. Similarly, I can say I want another one. So there can be many parameters. So I can say request param. And now in the bracket I can say num2. Okay, so now we have kept this variable and this variable same, but it can be different also. Let's say I can say num111 and this can be num222. Doesn't matter. We can keep this value and this variable name different. But this should be same as what we will pass. So let's go ahead and see how we can pass. So now what we can do in the URL, we can say question mark num111 is equal to 6.7, and we also have to pass another one. So we have to say ampersand num222 is equal to 1.3. Remember, so now our URL is going to look like this. So let's copy this and try to paste it here. So now what will happen when we will try to access the application? This num111 will match with this num111, and because of this annotation provided by Spring Boot request param, this value of num11 which is 6.7 is going to get assigned to this variable. Because num111 is the key which is getting mapped, its value is getting assigned here. Similarly, num222, because after and there is num222. Here this value is going to get mapped with this key and its value 1.3 going to get assigned here. So let's put a debugger and try to run. So this is exactly the same thing that we were trying to do by calling our controller with the main method. So let me resume this and we will try to hit it again. So here we called our controller with some values and we got the result. So same way, when you want to pass value in a REST API get endpoint, this is how we have to do. Request param and request param. If there are more fields, keep on giving comma and keep on giving the request param field. So if we run this now, let me, so if you already see this value, it's already coming. Let me resume this. Oh wait, because we were running this one, calculator. No, make sure to have selected this one, not this one even. In fact, we have to, yeah, that is correct. So we have to run our application. If we run this one, it's going to run this main method. That's not right. We have to run this, which is our main application. So run this one, right click, run main. So now here in the drop down, we got that as well. So now it's running that application. So let it run and then we will see what is happening. So now the magic will be, we will be able to pass the value. So you can right click and clear the console. So if I now click here, you will see send. We got the response as 8 addition of this. But then because we did not run in debug mode, it did not stop. So now I'm running the debug mode to show you how the value from the URL will be captured and set to our Java variable like this. We'll see. So now it has started. Let me clear the console. Let me change the value to, let's say, 1.7 and hit. So now our debug point, see, it stopped, it's waiting. And if you see, now the value, num1 value is, just hover on it. Hover, keep your mouse there. It will stop, it will show you. Then if you see, the value is 6.7. And from where is it coming? From the URL here. So if I go here, see, num111, 6.7. Great. And what is the value of num2? Let's hover. See, 1.7. From where is it coming? Again from here, 1.7. So now if I resume this, the value we will see. So we'll see 8.4 as the response. That is great. So now we know how to do this. But the best practice is try to keep this as same. So I will change this to, we should try to keep, again, it's the best practice. If you don't do, then it's fine. If you do it, then it's considered as good practice. So copy this, try to keep this name same as this name, and this name same as this name, and in your URL also modify to same. So 1 1, this should be 2 to 1. So now num1 key will map to num1 and its value will be mapped to num1. Num2 key will map here and value will be here. So let's try to see, debug, and maybe change its value to test it again. So I will say 1.8 and 6.9. So now the server has started. Let's hit. Oh wait, yeah. So now the value we got here, 6.9 and 1.8. Click here to resume the program and we see the value as this. So this is one way to pass data from our client, which is our Postman here, to our server, which is our Spring Boot. And that way is called request parameters or request param, which is nothing but after the URL, add one question mark and add the key value pair like this. And then for others parameters, you have to just give ampersand. If there is another one, you say ampersand num3 is equal to 666. So you can give like this also. That's also fine. So you can, this should be 1 ampersand. So again 1 ampersand. Similarly, you can say ampersand num4 is equal to something 878. So you can keep on passing that. So if we go out to our picture now, we will see that we managed to pass the client information to the server through the URL with the help of request parameter, and on the server we were able to get the information via the help of Spring Boot's annotation called @request param. So are there any other ways to do this? Yes, let's explore it in the next video. Thank you for watching this video. I will see you in the next one. Welcome back. So in the last video we saw one way to pass data via the URL in our HTTP request of our RESTful web service. So what is this called? RESTful web service, where one URL is getting mapped to a method in a particular class. So we saw one way to pass the data, that is with the help of request param, where we pass it with question mark and then query parameter key value pair and ampersand key value pair, and ampersand it continues. So in this video we will look at another way to do the same thing. So let's say I have a method now, public double, and I have to, let's say, subtract. Now I will put the annotation as get mapping, and this time the URL will be slash subtract or slash sub, doesn't matter. And what I want is I want to pass double num1 comma double num2, and here we will say logic double result equal to null, and then if we will say if num1 is greater than num2, then we will say return, then we will say result is equal to num1 minus num2 to avoid. Now this will be result is equal to num1 minus num2. Else we will say result is equal to num2 minus num1. And at the end we will just return the result. So return result. Perfect. But now we have one option to get the values from our postman or from the browser is by request param with question mark and key value pair ampersand key value pair. But I want to do it in a different way. That is called path variable. So here we did it with the help of request param. Here we will say map the values of URL to Java variables by path variable method. So for that what we have to do? We have to put a slash here, put curly braces, and make sure to use the same variable here. So I will use like this and put it here. And if there is another one, then I will again do slash and then curly braces and put this one here. Okay. And now I have to put an annotation of Spring Boot called @path variable. And here I can say num1. What I have to say? Num1. And this should map to this one. So here it can be different. So here it can be 111 and here it can be 111. But this can be different. So this will map to this one and take its value and put it here. Or it can be also same. So I can say another annotation, another one here as @path variable. And here, because here the name is num2, I will copy this and this should be placed here num2, and then this should be num2. So now how will our URL look like? So our URL will also change. So let me click here and click on duplicate. So it's going to duplicate me. So here calculator and I will say sub, and now instead of question mark this, I will get rid of all this and I will pass the first value like slash, and let's say it says 4.8. So this is going to get, this is the first value, so it will come here and get assigned to here and then assigned to here and then assigned to here. So here it will come first value. Is there a second value? Yes, there is a second value. So again slash 9.7. Is there a third value? If there is, then you can continue to give like slash. So now here we are passing the value which we need in our function in the URL path itself. So that's why we are calling path variable. So let's go ahead and start our server in the debug mode. Make sure you have selected this one. And now we will see if it is stopping or not. So let it start. So it is starting up here. Let's see. So it says starting up. So it says started. Perfect. Now I will put a debugger within the function between these brackets of the function. So this is the executable, first executable line. I want to print it, put the debugger here by clicking left click once on my mouse. Now if I go here and say send, now the debugger stopped here. It did not stop here because the URL mapping is different and the values are different. And the URL debugger stopped and this value got assigned here and the value came here. So let's check. So it's 4.8. That is the first value that is coming in the URL after /sub, that value. And the second value will go to num2. So num2, here path variable num2 and it will get assigned to num2, again 9.7. So it is a good practice to keep this variable name same as this variable and this variable. I just wanted to show you it can be different also. So now we got variable values as num1 and num2. So how can you debug now? So you can click on, if you hover this, it says step over, and this one it says step into. This is force step into and this is out of the function. So if we want to enter inside a function call, then we can use this one, otherwise we can use this one. And if we want to terminate the program, then we can click on resume. It will not terminate the program, this debug will terminate. If I want to terminate by keeping a debug point here, if I resume, then it will stop here before the processor or the execution will come here. But I want to show you by going line by line. So I will click here. So here it says, what is the value of num1? 4.8. Hover here on the num2. What is the value? 9.7. So we can also evaluate this. So select everything inside the if block. So select everything inside the if block. Make sure that you are on this line when you are selecting. Right click and then click on evaluate expression. Let's see what this executes. So click here evaluate. So it says false, which means our flow will come into else part. So go next. So here it says num2 minus num1. So again we can click here and evaluate. Right click. So we have to first select this. Right click, evaluate, num2 minus num1, evaluate. So it says 4.899. Let's go next. And you see the value of the result will be this. And if we resume now, the control will go back and here we got the data. So let's say if I click like this and now it's here, I don't want to go next. If I click this, so it directly stops here because there is another here debug point here. And if I have to now again resume programs to terminate this particular debug flow, because the program won't terminate, it is running. So it gives me the same result. Alright, so what we learned here, that there is another way to pass the data from the client, which is Postman, to the server, which is this Spring Boot. And that's what we have seen in our picture. So one way was with request param, another way with the path variable. Is there another way to do that? Yes, why not? But can we combine them together? Yes, why not? So I can also do like this. I can use here one request param and with slash I can also say num3 and I can keep a path variable here as num3. Anything can be combined. So let me show you this at the rate path variable. And here I have to mention this thing num3, copy this, paste it here And now I can say double num3. Let me break this here by hitting an enter. So you will see now if I go and try to debug and run my program and try to hit the first link, then it will stop here. So let's, yeah. So this is complaining because we have to pass another field now. This is just our dummy value, dummy main method, because we modified the method syntax here. Hence the calculate main is also asking us to modify. So now put on debugger. So let it start and then we will see the magic. So now if we check the console, it is starting up the server. Yes. So it has started. Perfect. Now we will go to our first endpoint, and if we try to now hit, nothing will happen. It says I did not find any mapping endpoint. So there is no mapping endpoint with this one. Is it true? Yes, that is true because now it has become add slash something. So let's go and add here. Add and then slash something. So we say 99. If I now hit, yes, now it works. So let's check. The value of num1 is 6.9. Is it 6.9? Yes, it's 6.9. Value of num2, it says 1.8. Is it 1.8? In the, yes, it is 1.8. Num2 is 1.8 with a request param. Third one, which is coming via path variable. Let's check. Yes, it is 99. So let's check. Is it 99? So we will not find it here because it is not going as request param. It is going as path variable. So we will find it here after add and then slash. That's where we have given. Can I have after anything after this? Yes, why not? We can have something else here, but accordingly you have to modify your path URL here as well. Otherwise it won't recognize. So now if I resume, the program gives us the output because we are not using this num3. Which means what we learned is we can combine request param and path variable to make our RESTful API endpoints. No one is going to stop it from doing us that. So hope this concept of passing the data from the client to the server via get mapping using request param and path variable is clear to you and you can now play around this. Thank you for watching this video. I will see you in the next video. Welcome back. So let's go ahead and talk about what is the other way to pass data from the client to the server. So let's stop this and let's first try to understand why do we need another way. So let me show you an example. So let's say I will say public and then I will say uh, multiply double and I would say multiply. So now I would say return. For now I will say just null. Now what I want is I want to multiply 10,000 numbers. So if I make it as a get mapping and then keep on passing at the rate request param or maybe let's say at the rate path variable path. So I have to do it 10,000 times and how will my URL look like? It will be such a long string with so many variables which is not good. And also people are seeing my values in the URL. That is also not good. Everything is going to be seen already in the URL. Third thing is the length of the URL is also limited. It cannot be infinite. At some point of time it will break. So after that point, whatever will be the value will be lost. We won't be able to get it in our Java variables. like we are getting it here. So for those kind of scenarios, what we have to do, we should not use get methods, rather we should go for post mapping. So we can say post mapping, and here we have to give the URL like slash multiply. That's it. And now we have to create class, and in this class we have to keep variables. So I will say private double num1, private double num2, private double num3. Similarly, I can keep on going private double num4. I can also keep different data types as well. String, integer, doesn't matter. I can keep, also this can be an employee object as well. Doesn't matter. So now I have to create a generate getters and setters. So I will right click here and generate a getters and setters. So for now I just took examples of 4. So now I will press Control and keep selecting all. So I want to create generate getter setter for all. Perfect. Now what we will do is very simple. We will just go ahead and say calculator DTO, and we will say calculator DTO variable, and we have to now use an annotation called @request body. Now what will happen with this annotation? Whatever we pass will be converted into automatically mapped inside these variables, but we cannot pass it in the get format. We have to pass it in the post format. So let's go ahead and create a variable here, double result equal to null, let's say. And now we will say result is equal to calculator dto dot get num1 multiplied by calculator dto dot get num2 multiplied by calculator dto dot get num3. Similarly, as many number of variables are there, we can do that. Multiplied by calculator dot get num4. Put a semicolon. Perfect. This is done. And now I can return the result. Right. So now let's go ahead and see how we can get this value. How we will get this value. So let me put a debugger here and start my application. So this is a post mapping, which means now our client is going to send the data to the server. This is the post mapping. This client will send the data to the server, but not in the request mapping, not in the path variable, which means not part of the URL. Rather, it will send it in the JSON object format, JavaScript object notation format as key value pair, key value, comma, key, another key value. This is a comma. So you can continue giving that. And this key should match with the variable name that we have defined in our DTO class. If we keep the same name in, then Spring Boot is automatically going to make sure with the help of this request body annotation, it will take that value from the JSON object, which is JavaScript object notation. It will take this key value and put it inside the variable here as a value. So let's see that in action. So first thing first, if I copy this, Control A, Control C, and then I can to try to hit this via browser. So it's working. It comes here. Perfect. I can resume it. I can resume the debugger point. It works fine. So if I go to the browser, I will see the response as this. But now, because our other method is post method, this one, so the URL will look like something like this. So if I go here, I can say copy this up to here, calculator, up to calculator, I will copy this and paste it here because that is common. That is something which is common. It is coming from class level request mapping. And after that, I have to paste slash mul. So I will say mul. But is it a get mapping? Can I use get mapping? Can I go into the browser and say like this? I get an error because there is no method with mul as get mapping, and browser can only fire get mapping. What it is saying? Method not allowed. So it says method not allowed. What does it mean? We are saying this is a post mapping annotation, which means data should come in the body instead of in the URL of the HTTP request. So now we got a problem, which means browser cannot help us sending this request. Can Postman help us? Yes, Postman can help us. So we have to first change here get to post. Then we have to click here body. In the body, we have to click on raw. And here we have to form a JSON. How does a JSON look? JSON means JavaScript object notation. So just two curly braces, give a tab, give the first key. What is the first key? And its value. And its value. So let's see what is the name of the key. So in our DTO, this is the name of the key. And what is the data type? Double. So copy the key name, go here, paste it here. And the value, is it of string type? If it is string type, then give it here, XYZ. But it is not string type, so we will not use string type. We will use what type? We will use double, which means we will say 65.83 or something, comma. Another we have, or do we have more data to pass? Yes. So we will say num2, copy that key. Again, some value. So let's say 1.2, comma. Make sure to give comma. Then num3, because that's my key. I know that in the class. So 2.1, comma. Then num4 with the key colon, which is key value pair, and then I can say 3.2. That's it. I don't have any other key, so I'm not going to look into more. Remember to change this to the application slash JSON, because now this is our client and it is trying to send JSON information. What it is trying to send? This is our client that we see here. Now it is trying to send JSON object to our server. Hence, this client has to say, I am sending application slash JSON type of data. Only then Spring Boot is able to map that JSON type of data via the help of this into its corresponding variables inside this class. If we don't say that, then we are in a problem. By default, this post mapping accepts application slash JSON. If we want to use different kind of REST request response type, we can specify that. But for now, we are going to just leave it to default, which means it is going to use application slash JSON. So here I am going to say content type as header value, and its value will be application slash see JSON. If I see select this and now click on body, you see it now shows me as a JSON and it's saying invalid JSON because I have forgotten a double quotes here to keep it in double quotes. So now if I go and run this, fire the request, it will stop here. See, it stopped. And now if I hover on this, I see all the values populated. If I add more fields here, it will come. And also it is now secure because nothing I have to put in the URL like I had to put earlier here, here. And also it will not break because the URL is also very small. So the data is getting passed in the HTTP body. So every HTTP has a header and body. In the header we are just passing what is the type of data, and body we are passing the JSON object, which is getting converted into Java object, and one-to-one mapping of the variables are happening. Num1 value is getting assigned here, num2, num3, num4, because we kept the same key. And now if I go ahead and resume the program, then we will see the response will be coming to us. And here we can see the response. See, response. Let's say I by mistake say num4 to num41. But in our Java variable, there is nothing called num41. So let's see what will happen. Run this. This will come. Nothing will break. But if I hover now, you will see the value of num4 is null. The reason is there is no such variable called num4. There is no key. So this request body annotation of Spring Boot, when it tried to map this num41 key to the num41 of Java variable, it did not find any variable called num41. Hence, there was a problem. Hence, the value for the last variable did not get populated. So, is there a way to solve this? Yes, let's try that. Let's try that how we can solve this problem. So, the solution to this mapping issue is very simple. We have to come to the DTO in our class, and for whichever variable the mapping is different from the request JSON type, we have to do one thing. We have to hit the enter and then put another annotation called JSON property, and make sure this JSON property annotation comes from Jackson from faster XML. And here we will now say with what name is the request coming. So with this name the request is coming, name41, num41. Copy that and paste it here. So now when the Spring Boot's request body annotation will see, okay, there is num1 here, and in the request there is num1, so num1, num2, num2, num3, num3, num41. Aha, so it's going to see num41. Let me check. There is no num41. Oh, but yes, there is an annotation, num41. So it will populate the value for us. Let's put it in debugger and see if it is working. Same can happen for other variables as well. So it removes the tight coupling of your Java variable with the JSON request. So the JSON request can have now any variable name, and your Java variable can have any variable name. So this JSON property helps us in doing that decoupling. So now it has started. Let's go ahead and try to hit this. So if I hit this now, if I hover, you will see the value is now populated perfectly, even though the variable names are different, num41 and num4. But because of this JSON property, the value got populated here. See, num4. Perfect. So now if I click resume, our program will run nicely. Very nice. So this was about a post endpoint. Are there more ways to send information? Yes, there are. Put and patch and delete as well. But put is a combination of, you can say, when you use post and get together, it looks similar to put, which means along with this body, I can also pass something in the URL, like let's say ID as 1, and I can make this as put. This is fine. This will work. For delete, I will just pass in the request. I will not pass the body. So that's how delete works. So we are going to look examples about them in future. So it's only the matter of the fact when you should use get, post, put, and delete. Get you can use when you are just passing one or two value in the URL or like this one or two value which is not sensitive. Post you should use when you have to pass lots of data in the body and it is going to create something in the server. Let's say creating a new employee information in the server. So use post. But what about updating the details of the existing employee? So if you want to update the details of an existing employee, then go for put. P-U-T. U means update. Put is used for update. Post is used for creating new resource in the server. Put is used for updating an existing resource on the server. And delete is used for deleting an existing resource on the server. And what is then get used for? Get is for fetching. You want to query and fetch something from the server. So get is for fetching something from the server. Post is for creating new resource on the server. Put is for updating an existing resource on the server. And delete is for deleting the resource on the server. And patch is same as put, which means patch is also going to update the information on the server. But for with put, you update everything. Let's say there's an employee, you want to update employee name, employee email, employee phone, employee address. Everything you want to update in one shot, you go for put. If you want to just update one thing at a time, let's say you want to only update employee name, then go for patch method for updating employee name. If you want to only update employee email, then go for another patch method for updating employee email. So patch is a partial update and put is full update of the resource on the server and post is for creating a new resource on the server. So these are the different um, HTTP methods that we can use and they are those are the difference between each of them. So all these methods can be used to communicate from the client to the server via using HTTP methods that we saw: get, post, put, delete, and patch. So client can send information to the server and server can send response back. That's what we have been seeing. So different methods exist for different kind of scenario. One thing to note is if you see always we are getting 200 OK, which is the default response from the server. Here also we got 200 OK. And these are HTTP codes. So not always we will send from the server, we will not always send that it is everything was fine. Sometimes we will also send error, which means another different HTTP code. Like when we try to access this method with the get request, then we got another HTTP error 405. It said method does not exist. So those kind of scenario can also happen, which means along with our data and the response, we should be also able to send a response. So how can we do that? We can do that very simply. So let's do that. So there's something called response entity. Response entity. And with response entity, what we can do? We can send two things at a time from our client to our server. One thing, of course, is the data itself, and another thing is our what is the type of response code. So we can also send a response code along with the data information. So let's go ahead and do that. So we will say response entity of what? Of response entity. In this case, what is the return type? Double. So whatever is the return type, you create the response entity object of that type. And then we say response entity is equal to new of response entity. And here we have to pass two things. First thing that we have to pass here, of course, we have to again say here copy this double and put it here double. So if this was about employee, then we can use employee. So what we have to pass now? Two things. that we want to return. One is of course the data itself. And what is the data? Result. So we'll copy result. And then HTTP status. If I pass OK, then we will see 200. But I will pass created, because with the post endpoint we should always pass created, which is nothing but 201 status code. And now instead of returning double, we will return response entity. So this will change now, and we will return response entity. So this will also change. This will become of response entity. Perfect. So now if I start the server, you will, and just try the same request, you will see we will not get 200. Okay, instead we will get 201, because we decided to send a different status code. We could also send another HTTP status code. There are many HTTP status code like 100, 200, 400, 300, 500, authorization error, whatever. But we would like to for now keep it simple with another like for the created one. So let me clear this. And now if I try to send this information, you see we got the same result, but now the status code is 201 created. And that's what the post is used for. Post should be used for creating a new resource at the backend. Hence we got 201, which is stating that the response, if it is having status of 201, something new got created on the server. So this is how using response entity you can pass your data, also the status together in your response when you return back to the client, which means now the client is receiving the data plus status, two things. All right, so I hope all this is clear for you. Thanks for now. I will see you in the next lecture. Welcome. Now that we know how get, post, put, delete works and have an idea about them, let's go ahead and continue with our property manager application. So in this application, as mentioned earlier, you as a normal user can go and register to this platform, and then you can log in after that, and then you will be able to create many properties. So you can log many properties that you have. If you have a house, you can log that. If you have an if you have a shop, you can log that. If you have an apartment, you can log that. So that in future, if somebody is looking for that property as for rent or sale, they can come and look into this portal. So there can be many people who own property, so they can come and start to log their property details on this application. So that's the overview. For now, what we will do is go to our property controller. Here, first endpoint that we would like to create is for adding a property. So I'll say public, and then I will say property. For now, I will just say property. We will modify that property DTO, save property. And as we know from our post mapping, this will be like post post mapping post mapping, and here we will say slash save property. So whenever user will hit API slash v1 slash property slash save, it will come to this method. This is one way of naming it, or what we could also do is take this here and just keep up to here and say properties. That's it. This is another way. So we will keep the endpoint always same and the method name will change, because of which we can create multiple endpoints. Alright, so now this will take a property DTO, and that is going to come from the user. And as we know, this is a post mapping, so we have to say at post mapping. No, not here. Here it should be at request body, because this is going to convert data into this format. And here what we want is, we want to just for now say system dot out dot println, and we will just for now print the property DTO, and from here we will just for now return the same property DTO. So let's test this if it is working as expected. So I will put a debug mode here and start debugger. So let's go to our postman. So let's duplicate this, and now it is v1 slash properties with the header of content type application JSON, and a body will now change. So let's form the body. For that we have to go to property DTO. We will say property title, property title as it will be a string, so we'll say property or apartment 1. Similarly we have another one, description, nice property, something like this, and others property I will ignore for now. Let's try to hit this. So if you see, now it came here and we see what will the value of it. So here in the property DTO, it's giving us apartment 1 and nice property. Others we haven't set, so by default its value is becoming as null. Perfect. So far it's good. So what we managed to do is, we managed to basically save the property. So here from our client we managed to get the property details to the controller. But here is our database where we want to store the property detail. So this is our database. So now we could directly write the code to save the data in the database, but that is not a good practice. So like this is a controller layer. Similarly, we have to create a service layer, and service layer is for writing business logic. And then we have to create a repository layer or a DAO layer. And this DAO layer is going to talk to our database, or this repository layer, whatever you can call, is going to talk to our database. And then this service layer is going to talk to this repository layer. And this controller layer is going to talk to this particular service layer. So we will write the flow now for everything in such a way. There will be 3 layers: controller, who is directly talking to the client, service, which is for business logic purpose, repository, which is going to interact with the database. So in the next video, let's go ahead and see how we can create our service layer. Thank you. I will see you in the next video. Welcome back. So let's go ahead and create another package for keeping our service layer. So click on the root and right click and say package. We can give this name as service, or it can be also called as business, but we will keep it as service. In this service, we will create a interface first, and that interface name we will give as property service, and this will be an interface, and we can keep some methods in it. First method is proper private, or wait, sorry, public property DTO save property. So what we are doing is whichever property user wants to save, we are going to return the same property back. So now this is the property service. So let's create an implementing class that will implement our property service interface. So the implementing class we will keep in IMPL package. So we need to create another package here, new package implementation IMPL. So here we will say class property service IMPL class, and this class we will say implements property service interface. Now we will hover and it will ask us to add unimplemented methods. Done. So why did we do this? So this we did it because it's always good to create an interface and the implementing class. In future, there can be a situation that there can be more than one implementing class for the same interface, so that there will be different implementation logic in different classes for the same method. So this kind of pattern is called factory design pattern, where there can be multiple implementation class of one interface, and based upon whose implementation class object gets created, that particular class logic gets executed. So this is called factory design pattern. All right. Now we have to tell Spring that take care of object creation for this particular class. What we will say to Spring? Spring, you from now on take care of creation of object, giving memory to this and destroying memory for this class. You should take it from now on by creating a singleton bean instance for this class. So for that we could use multiple annotation, either at the rate service or at the rate configuration or at the rate component or at the rate repository. We can use, or even at the rate controller. But as this is a service layer, we should go for at the rate service. All the annotation that I showed, component, configuration, repository, all this has the same functionality. That is to make this particular class object as a singleton instance, which means the object will be only created once until our application is running, and whenever next time a request is made for this class object, the same object which was created once will be returned. which means singleton. Making it singleton is much more memory efficient. So Spring automatically does that. If we put @service annotation on top of a class, it's going to make sure it's going to create a singleton instance for that class. So we can make a class singleton by putting any of the one annotation like component, configuration, service or repository, but I chose to use service because this is service layer. Alright, now this singleton is a pattern, design pattern, another design pattern where we are saying that create single instance of a class and reuse it whenever it is asked for. So what will be the other pattern where more than one instance of the same class is used again and again, or created again, more than one instance of the same class is created again and again? That is actually opposite of singleton and it is called prototype. So here we have singleton is a creational. So design patterns are of three types: creational, structural, behavioral. So we are talking about creational design pattern where we just saw factory design pattern where basically we define one interface and there can be multiple implementing class. Based upon whose implementing class memory is given, that particular implementation class functionality is invoked. That is factory design pattern. Singleton design pattern we just saw by annotating our service with @service. That class becomes singleton, which means only one instance or object of that class will get created and reused throughout the application lifecycle until the time we stop the server explicitly. Opposite of singleton is prototype, where multiple instances of the same class will get created and they will get destroyed. For example, if I create property DTO object, it can keep one property for, let's say, apartment. If I create another property DTO of, then it will keep a row house. It will keep another. So property DTO should be of prototype design pattern. If it will be of singleton, then we have problem, which means everyone is seeing the same property detail, which is not good. Hence, objects like this DTO or model or entity, they should be used as prototype. By default, they are prototype only, which means we should not make them one instance and use it again and again. Rather, every time a new instance of this should be created so that to keep the local copy of the data. But these kind of classes can be singleton, whose one instance can be created and used as many times as we want. So now where we know what is the difference between a singleton bean, because this is also called a bean and this is a prototype bean. Bean is nothing but just another Java class with a fancy name. Now what we will do is we will try to pass the data that we have in our controller layer. So we have the data from the client now here. We want that data in our service layer and we also have created a service layer with its implementation class. So there has to be a way that controller should talk to service. Only then this DTO data can be transferred. And DTO is also called a data transfer object. So there should be a transfer from one layer to another layer. Alright. And that is how the thing how we do that is with the help of another Spring mechanism called dependency injection. What it means is here we have our controller. So here we are going to create a class level variable of our interface of service. So private property service, press control space and then press control space, it will suggest you a name. property service, and do not forget to write auto wired here. If you don't write auto wired, then this will be having null as the data because no one is giving it memory. Only when we make it auto wired here, Spring is going to create an object of the implementing class because we have asked it to make it singleton, and then that object will be pointed by this particular interface instance which has been injected here. So if we don't do auto wire, Spring is not going to create an instance of this class. Hence, the instance or the this property service interface will be pointing to null. Let me show you that. So now that we have done this, so from here we can now call property service dot save property and pass this complete property DTO as is. Pass this complete property DTO as is. Okay, and here it is returning something, but we don't have to worry about that now. Now let's say I will comment this and then I will try to run my application. You will see what will happen. Put a debug here and start the application in the debug mode, and we will try to hit the service via Postman. We will see the interface value will be null because we did not do auto wire. If we don't do auto wire, Spring is not going to do dependency injection for us. What do you mean by dependency injection? Dependency injection is another design pattern by which, or it is kind of a process by which Spring will make sure an object of the singleton bean is created and its corresponding interface is pointing to that object. And when we do auto wired, it makes that instance of that object available to this interface in a particular controller class, or may it be any other class, any other bean. Because wherever you are doing this auto wire, that should be also a bean, like at the rest controller, at the rate service, at the rate repository, at the rate configuration, doesn't matter. It should be at least one of this. So let's say now our application is started. Let's go and try to hit this. It is stopping now here. We will see now this property DTO is populated, which is good. And this is by default prototype in design pattern nature, which means every time new one will create it. But when we see this value of this property service, this is null because Spring did not create the instance of this bean, even though we gave it as address service. Because we did not do it auto add. When we do auto add, then only this bean instance will be created and it will be injected into this controller's this variable. That is called dependency injection. So let's stop this and now uncomment this, and now I will show you, and now we will also go and put a debugger here. So now let's start the application. Let's close this class not needed. Also close this one which is not needed. Right click, close. So let's see if our application has started. It is starting up. So it has started. Now if I go to Postman and try to hit it again, we will see now this is no more null. It has an object of an IMPL. If you see what it says property service IMPL object it's holding. Sorry. Which means now we can go inside this method call. And how do we do that? By pressing this button F7. So it will go inside this. And we are passing the same data which we received from the client to controller. We are passing that same DTO to our service. See? So what we are doing? Let's check in our picture. From the client we got the data. We pass it to controller. From there, now we passed it to our service. We have successfully done that. So let's continue in our next video to pass this data to even to the repository layer and save it into the database. So thank you for watching this video. I will see you in the next video. Welcome back. So now we are here. We have the information available in the service layer. Next is to build a repository layer, which is this one, and in the repository layer do the magic that we are able to connect to this database, and in this database we are able to store the information which the user is passing from the client here, from the postman, which is coming in our DTO. So this what we are doing now is called layered architecture. So we have a controller layer, we have a service layer and a repository layer. So this is called layered architecture. So we are following a layered architecture. With that we are making sure every layer has some responsibility. So controller layer has responsibility to take the request from the client which is coming via HTTP protocol in the URL. This service layer has the responsibility to do some business logic. Repository layer will have the responsibility to connect to the database and save information in the database. So let's go ahead and start with configuring our database. So we have multiple options that we can use the database. So let me tell you few things about it. So we have in real life what we have is a development environment where the developers are working. Then we have a test environment, then we have an acceptance environment, and then we have a production environment. So when we deploy, this is the software that we are building. This is the application that we are building, property management system. This is the Spring Boot application that we are building now. This is what we are building. But in real life, what happens in the project in the company that you are working, the same code will be deployed on dev environment. Then the same code, after developer has done the testing, everything is working fine, he will deploy the same code to the test environment. Then the same code will move to acceptance environment. Once in the test environment, let's say the tester says everything is working fine, then the code will move to acceptance environment. Here the business users will do the testing, and if everything is fine, the same code will be released to production environment. Which means what? Every environment should have its own database. So this is a database for dev, T environment. This is a database for test environment. Because if we keep the same database for dev, test, acceptance, then our dummy data will be shown to the production users, because this production, they are the end users who are using our application, end users, and they will put real data in this database. So this should have another database that is production database. Similarly, acceptance should have another database which should be acceptance. So we are making the same code, but the same code runs on different environment where the development happens, testing happens, then business approval happens with acceptance, and then it goes to production where the end users use them. So what we can do is we can use the same database. Let's say now in this course we are going to use MySQL database. MySQL. So that database, that this is the MySQL database server. MySQL database server. Here we can create multiple database. Dev database, test database, acceptance database, and production database. In the dev database, we will connect this application to dev, test will connect to test, acceptance with acceptance, and production with production. Or we can also decide to do for dev for local development, but we are also, this is DTAP, dev test acceptance production, but there is also a local environment which is ours, where we are doing local development now in our computer. So here also we can have another database as well, local. But for simplicity, I want to just show you that there is another simple database also called H2 database, which is a very simple database. We can use it for local development. And for dev test acceptance production, we can use MySQL server, where we can create independent databases. And each database will have tables. It will have table, this will have table. All these databases will have its tables. And tables what we define in our application. Okay. So now what we are understanding that at least we need a database, which is the H2 database, to connect at, for with our Spring Boot application in local. So in the next video, we will try to set up this local database in our computer, and that to an H2 database, and we will try to connect our application to that. So thank you. Let's continue in the next lecture.
All right. So far, you already know that JPA is just a specification. When we say specification, it means it has only given how it can be implemented, but it has not implemented anything. So in very layman's term, JPA is just an interface. But Hibernate is actually the implementation framework. It has implemented all the interfaces and all the methods that is needed for doing any kind of operation. Hibernate has implemented that from the JPA interface. So Hibernate is the actual framework which does the work, does the implementation. So as we know, ORM is object relational mapping, which means that developers or people who don't know database, they don't have to worry. They just have to focus on writing their Java code and using some annotations, and then Hibernate, following the JPA specification, is going to take care of creating the different tables based on those mappings of the Java class, and do all kinds of things that is needed for connecting with the database and doing all the transactions. So Hibernate is going to take care of it. But how does Hibernate does it? We don't have to know everything about Hibernate, but we need to little bit understand how Hibernate does that. So let's say this is our Java application, and here is the Hibernate framework. And Hibernate framework is also written in Java. It's nothing different. But here is our database. Earlier, from our Java application, we were directly connecting to the database using the JDBC driver. And then we used to create the connection object. And with the connection object, we were getting the statement or prepared statement. And from that, we were executing the update queries or the query objects, and we were getting the data. But this was only possible if you had knew how to write SQL queries, and we were writing the SQL queries in plain string format. We were passing it. So from the database, from the Java application directly to database, and then database to Java application. But then all this was taken over by all this pain was taken over by JPA and the implementation framework like Hibernate. So in the Hibernate, what they said is just focus on the entity. Let's say we call this as entity or the class which will store the data. And the class is going to get mapped to a table in the database, and all the variables of the class is going to get mapped as a column in the table. So we said that's fine. So what Hibernate does is it takes that object that we want to store into the database, and it calls it as a persistent object. And then based on some configurations and mapping that we have given with the help of XML or annotation, it is going to talk to the database and store the data, or retrieve the data for us and convert back our data to our Java objects. That's how the abstraction, the Hibernate took away all the pain that we had earlier when we were connecting directly from the JDBC Java application to the database. That's why Hibernate is called as also a multi-layered. I mean, if you see here, Hibernate is a layered architecture which helps in operate without having to knowing the underlying APIs. So we don't have to know how Hibernate does all these things internally. So Hibernate is going to talk to the database, just that we have to provide different configurations for to the Hibernate for it to connect to the database. So let's see a little bit in little detail. So if you zoom through this picture, this is how Hibernate does it. So whatever entity classes we are preparing by putting the annotation at the table, at the entity, and then at the rate ID, column, different annotations we are putting. So what Hibernate does is, and then we also give the configuration related to our database. Where is the database? What is the URL of the database? What is the username, password of the database? All that we give to Hibernate. And now Hibernate is doing the magic behind the scenes. So for doing the magic, Hibernate has these 6, you can say interfaces, which are working together for Hibernate. So Hibernate has these 6 interfaces which are working together. So there is in the interview there are questions. What are the 6 different Hibernate interfaces which Hibernate uses to do all the ORM activities? So ORM activities means object relation mapping activities. So first thing is configuration class, or you can say configuration interface. Here you can say configuration object. When I say interface, it's literally not interface, it's actually class only. Interface in the sense there is an interface between Java application and database. So configuration object is a simply object which has 2 things. One is the mapping that we provide, like all the column mappings, entity table mappings, and the database configuration that we provide in our property files. Like here is our database URL, here is our password of the database, here is the username of the database. All those configurations are getting mapped in the configuration object. That is great. So one interface is gone, or the one class job is done. Now this session factory uses this configuration. So the configuration object is used by the session factory object, and then the session factory object helps us create one connection with the database based on this configuration. So actually this session factory is going to make one connection per database with the database for us. And how it will do? It will take all the inputs that we have given to configuration, and then it will create a connection. But then this session factory is thread safe. Thread safe. What thread safe means? In very layman's term, I'm going to explain. Later, you will know about what is thread and what is thread safety. So thread, let's say in a multi-threaded environment, let's say there are many applications running and they are trying to access one common thing at a time. So if somebody is trying to take that common thing and then somebody is trying to, let's say, do some manipulation to that thing. So let's say there is a variable called account balance, and then account balance shows 100 rupees. But at that time, somebody is manipulating that account balance and changing the value to 80 rupees. But at the same time, you are also seeing that account balance. So you will see 100 or 80. So that's a problem. So it is not thread safe situation. So in thread safe situation, what should happen? If the variable is having account balance as 100, then if you are seeing that value, then at that time, no one can modify that account balance field, which means if I try to do a request at that time, after the manipulation is done, let's say it has become 80, then I will see 80. If it has become 100, then I will see 100. So thread safe way means session factory basically creates one object per database using the configuration class, and then the connection is basically thread safe. Okay, now we have covered configuration, which is being used by session factory. And now session factory is being used by session. So using the session factory, multiple session with this database can be created. So let's see that. A session object is used to get a literally physical connection with the database, and then the session object is used for the interaction with the database, and whatever object we want to save in the database or get from the database, we will do with the help of session object. So session object gets created from configuration object. So session object gets created from session factory object. Session factory object gets created from configuration object. But this is only one per application per database. But this can be, the session object can be multiple session object created from the session factory. Because, at a point of time, at one time, we are running many queries on the database. The Hibernate is running many queries on the database for us. So it is creating many session objects for each of the database transaction. And now, the next object is the transaction object, this transaction object. So what is a transaction? In a very layman's term, let's say, if you are basically, if you want to say that its transaction is something that is either complete or not. So what it means is, let's say I want to go outside to buy some groceries, but if it rains, then I'm going to come back. But if it doesn't rain, then I'm going to go and buy groceries and then go for, let's say, lunch outside and come back. So now, what is my one single unit of work? Going to buy grocery. And then after that, going to for lunch. If these two activities are complete, then I can say it is one single unit of work complete. That is one transaction. So when I'm coming back, then I have done both the things. One is bought the groceries, but also had my lunch. So that is one unit of transaction. But what if I am outside and I bought my grocery, but suddenly it started raining and I haven't done my lunch, which means I will also not bring grocery. I will leave the grocery and I will come back to my normal state. What was my normal state? I am back at my house without grocery, without my lunch. So this is called one transaction. So the transaction should be either complete or it should be rolled back to the previous state. So how it happens in our database world or application world? When you try to do a certain operation, let's say you want to do a get operation, select query, and then you want to do an update query, and then a save query, and then again a select query, and then an update query. But let's say the third update query failed. Then you need to roll back everything, whatever you have done before that, and come back to the state of the database, which was before you started this all operation. So the transaction management, you don't have to do anymore. Earlier, if we were using JDBC, we had to do the transaction management using the JDBC or Java Transaction API mechanism. But now Hibernate is going to take care of the database, the whole transaction activity for us. Next is we have a query object and a criteria object. So query object helps us to write SQL queries on our database. It's like normal, but you don't write it now as a query literally as select star from something, but you write the query on the entity classes, on the persistent objects, on the Java classes. And then we have criteria queries. So this is same as a query object, but here what you do is, let's say if you have to write query which is which is complex, where let's say it has a select star from where product category is let's say food, and the price range is between this and this and this, let's say or this, there are multiple and or those kind of conditions are there. Then Hibernate has provided us a criteria object. Using this, you can do a filtered select query, or with where there are many where conditions available. You can do all this using the Hibernate criteria query, criteria object. So those were the basically 6 Hibernate classes, or you can say objects, which helps Hibernate to actually easily do the job of talking from our Java application to the database in the day-to-day job, day-to-day work that we are expecting. But now, let's say at any point of time, the object which we want to save in the database can be in different states. It can be in the database. It will be not in the database, which means it's just a Java object, or it can be it was in the database, but now it's a Java object. So how do we say that Hibernate object has different states? So let's say if we have just created an object person equal to new person and done nothing with it, and this person class has different annotations applied on it, like @id, @column, @entity, everything is applied, but we haven't done anything related, anything data operation, database operation on top of it till now, which means this particular object state is now transient. So here, if you see the definition, a new instance of persistent class which is not associated with the session. So if until the time the entity class, or the class which is our model, where we are actually putting the annotation about @entity, that class is, if it has not been associated with session object till now, which means the state of the object can be called as transient. Okay. Now, as soon as the state of this object gets associated with the session object, let's say as soon as you do session.save, you are doing session.save, because we know multiple session objects can be created to do different operation, and those can be created from session factory. So a state of the object can be in a persistent if it has been associated with the session. So we are saying session.save and then passing the person object that we created here. So now the state of the person object can be in persistent state. Now, if let's say after doing this operation, we close the session, we say session.close, then the persistent stay instance will become detached instance, because it is not associated with session anymore, but it can be made reattach. So if we, of course, now the session is closed, means whatever was the state of the session object is now saved in the database. But as soon as, let's say later on, we want to fetch the same object again, then we have to again attach it with the session. At that time, it will become reattached. Until that time, it becomes detached. So this is a small picture. So first we have the session. First you have created the object new. Then it, before it has been associated with the session object, it is transient. So here it can be just like any other normal Java class. It can be garbage collected and the memory can be removed. But if you do some operation on the transient object with session here, then it becomes persistent stage. And as soon as the session is closed, the object becomes detached. So detached object can again become persistent if you do any operation on it, let's say update or merge or any of the operation that you do. So this is how the object state works in Hibernate. All right, we talked about the Hibernate object states, transient, persistent, or detached. So there's something called caching. So what is caching? So let's say caching is a mechanism to enhance the performance of the system. It is a buffer memory that lies between the application and the database. What does it mean? So here is our application and here is our database. Let's say I want the list of employees from the database whose age is greater than 30. So if I know those employees, this list is 2000, and I know that the list is not changing that frequently, I can basically, instead of always making a query to the database via Hibernate, I will ask Hibernate to cache that data. So it will cache it here. So whenever next time my application is calling, it is giving from here, from the Hibernate cache itself. It is not coming to database anymore. So, so what is the caching? It is a temporary memory which helps to improve performance when we know that data is not changing that frequently. So we can keep that in the temporary memory. So that mechanism is called caching. So caching is a mechanism to enhance the performance of the system. It is a buffer memory that lies between your application and the database. The cache memory stores recently used data items in order to reduce the number of database hits as much as possible. Exactly. So if we are not making many direct session connections with from our Java application to DB, which means we are saving the number of calls, and that's why it becomes faster. So we are going to see also implement the caching as well, how it works. We will see them. But on a very high level, Hibernate supports few levels of caching. The first level of caching is at the session cache, and it is a mandatory cache which through which all the requests must pass, and the session object keeps an object under its own power before committing into the database. So as we saw, this session object maintains a cache. So any operation that we are doing to the database, we are doing by the session object. So this session cache is called a first level cache, and it is a mandatory cache. It is by default enabled, and all the operation happens via from the Java application with the session object through the session cache to the database. That's how it works. So there is another level of cache called the second level cache, and that cache is basically not mandatory, it's an optional cache, but this cache is working, this cache works on the the session factory level here, and this cache is shared across multiple sessions. So the second level cache works on the session factory level, and as we are creating many sessions from this session factory, which means the session factory cache is shared by different session objects, but it is not a mandatory cache, or it is session factory cache is an optional cache. And here the session is before even creating any session factory cache, it will be consulted with the session cache whether it's required or not. Because as this is a next level cache, it will be shared between multiple objects. This can cause a lot of memory. It can take a lot of memory. So it completely depends whether it's really needed for a session factory cache, because it is per database, one session factory object gets created. So it will be a big session, big cache. So the second level cache is this one. Then there's another cache called query level cache, and this query level cache is basically, if you see here, implements a query, Hibernate implements a query level cache integrated closely with the second level cache. This is also an optional cache and requires 2 additional physical cache regions to cache the query results and the timestamp with the table. This is useful for queries that run frequently with the same parameter. So let's say here, this query cache works together with session factory cache. So this is also optional. So now what is the use of this query cache? So let's say if you have certain queries which are almost common for all the different types of users that you have, or it has the same parameters. Let's see, this queries runs frequently with the same parameters. So let's take an example. I want basically the list of countries, all the list of countries. So we know that it is going to remain same. So that query gets cached here in the query cache. So you may or may not want, because this is also an optional cache. So the queries which are running frequently, but also they have expect the same parameters and to be and the same query to be run again and again, you can put that can be going in the query cache. Okay. So there is a small picture of how the different cache level works. Database in the first level cache, then the first level cache is the session object cache, and this is the client. So or the client means Java application which is talking to session object. Session object is talking to the second level cache, and session level object also maintains a first level cache. And then there's a database transaction. So database transaction happens via the first level cache with the session object. And then if there's a second level cache existing, it will be interact here. And then the response will be given to the application. So far we have seen different types of caching in Hibernate. Now let's talk about what are the different properties, because we said that initially the different objects that Hibernate has. One is the configuration object. So in the configuration object, we can provide many configurations. How do we provide that? With the help of property files. In the property files, we will see in the later in the hands-on tutorials, we can put different properties. Let's say one property is I'm using an H2 database. So I'm saying spring.h2.console enable true, which means I want to access this database via the URL or in the browser. So I have to make this property as true. Similarly, spring.h2.console.path h2 this. So I want to access this browser database on this URL. So if I can change, let's say XYZ, then I can access the database on the XYZ URL. So whatever is your preferred URL path, you can give. Same goes here, spring.datasource.url. Here you provide your database. Where is your database running? You give here. So here we are saying it is a file-based H2 database, which is running in the same computer. Then you provide the database username, and then you provide a database password. So you provide it with the help of this properties. Now we have other configuration. We said spring.datasource.driver class name. So here the class name for the H2 database is org.h2.driver. But for different other, there are many databases from MySQL, Oracle, MS SQL Server. This value will be different, but this key will be same. So you can Google what is the driver for, let's say, MySQL database. So you will get the class, the complete package in the class name. So you can paste it here, and then you will be able to configure that for MySQL. So there's a spring.jpa.hibernate.ddl-auto. So this has property called update. This has value called update, and there's another value called create. So what happens with update? So what you want is whatever let's say in your application you have 5 Java classes, and all of them are @entity and @table. So now you know there will be 5 tables created in your database also for these 5 Java entity classes. But what if you want that only for the first time when the application starts, those 5 tables should be created, and then they should not be dropped. It should not drop. Next time onwards, only the data should get inserted or deleted, or select query should work. It should not drop it. Then you make it as update the value. But if you want every time the application stops and starts, drop all the data, drop all the table, then you make that as a create here. So let's say now you want to see what kind of SQL query is getting generated. So you can say spring.jpa.show-SQL true. So it will show you all the SQL statements printed in your in the console itself, there where you are running the program. Similarly, if you want to see the same SQL but in more formatted way, you can use this property. String data JPA properties Hibernate format SQL. And there's another one called Spring Data JPA database platform equal to all.hibernate dialect, H2 dialect. Again, this is dependent on the database that you are using. Like here, like the JDBC driver we used to have specific for a database, specific driver. Similarly, the dialect should be also specific to the database. So this, if you say literally dialect, it literally means what is the language it speaks. So let's say if you say the Hibernate is, let's say, a translator. So if somebody in front of him is French, somebody is German, then Hibernate should know how to convert this English to the French person's French and the German person's German. So here, if we are using, uh, let's say H2 database, so we have to provide what kind of the so S2 database might have different syntax for writing the same select star from table name query. So if we provide this, so now Hibernate knows, okay, this is S2 database, so I have to convert the select star from in this way. So for let's say MySQL, this dialect property will be different because MySQL might have a different syntax of writing queries. So this dialect property, this property makes Hibernate generate appropriate select SQL queries, not only select, insert, update, delete queries for that particular chosen database. All right. Now let's see. If you remember in our entity classes where we do @entity and @table, we provide another annotation called @id, which means that we want Hibernate to automatically generate values for our primary key column. So what does it mean? I don't want to every time create a value for my primary key column and insert into the database. In that case, you can ask Hibernate to do that for you, but it does it in a different way. So it provides 4 options. You can say auto, which means Hibernate will select the generation strategy based on the dialect. So here, whatever database dialect you have given, whatever is the default way of generating the ID, it will use that and generate. So this is the safest way to use. Then identity, another way. Hibernate relies on the auto increment database column, relies on an auto incremented database column to generate the primary key, which means here it will do exactly same as auto, but it won't be dependent on dialect, but it will be dependent on the auto incremented database column. Whichever column you have said it is auto incremented or which is a primary key, it will use that. And then you have sequence. Some database does not support, let's say, identity. So it's always safe to go with auto. If you say sequence, then what you can do is you can create a sequence in the database first, and then you can give that sequence here. And then based on the sequence, the primary column value will be generated. Another strategy is table. So Hibernate uses a database table to generate the sequence. Again, it's similar to the sequence. First, you will go and create a table in the database and then use the strategy of ID generation as table and give that table details. So Hibernate is going to use that and generate the sequence or generate the values for the primary key column. The best is to go with auto. Hibernate takes care of everything. Okay. Now we so far talked only about Hibernate. Before that, we talked about JPA. And now we know Hibernate JPA is a specification. Hibernate is the implementation of the specification. But then what is Spring Data JPA? Because don't have to worry about Hibernate and all these steps. We just have to know what exists, but we don't have to worry about, because now we are not using Hibernate. We are using Spring Data JPA. And what is Spring Data JPA? Spring Data JPA is an abstraction layer built on top of Hibernate to make our life easy. So what is a Spring Data JPA? It is an abstraction layer built on top of Hibernate. So if Hibernate was helping us to connect to the database and do all the operations for us on the database, Spring Data JPA is an abstraction built on top of it, which means it even makes life easier for us. We don't have to worry about all this, and we don't have to worry about how it does this and this. These things we don't have to worry about, because now Spring Data JPA saved our life by adding another layer of abstraction, which means we just have to focus on writing queries. Other things will be taken care by Spring Data JPA and internally by Hibernate. So if you say Spring Data JPA, it's a part of the same Spring Data family and makes it easy to implement JPA-based repositories. This module deals with the enhanced support for JPA data access layer. So what it helps, implementing a data access layer gets rid of it. It helps to get rid of a lot of boilerplate code that is needed for writing queries, pagination, or the auditing. All those is taken care by Spring Data JPA. So we just have to focus on writing queries. So we will see all this. We will see how to implement all this, and then now how to start using Spring Data JPA? Basically, Spring Data JPA provides us three interfaces. One is the CRUD repository, and it is purely for CRUD operations like select, update, insert, delete. Then there's another interface called paging and sorting repository, and this will help us to do all kinds of pagination and sorting things. Let's say I have 2000 products, but I want to show 20 products per page. So if you do next, it will fetch the next 20, next 20, next 20 products. So that we can implement that kind of functionality we can implement using paging and sorting repository. And sorting, let's say if you want to sort by date, sort by product name, sort by price, you have to want to sort the result of the data. Then you don't have to write any more logic. Spring has given you interface, you implement it, Spring does it for you. Spring Data JPA does it for you. And then we have JPA repository. This is basically related to things like you want to do things in batches. So using Spring Data JPA, this normal JPA repository also, you can do all the operations, but this gives you features like you want to do things in batches, then or maybe flush. Let's say flush means you want to do reset of your persistent objects. Those kind of specific functionality, if you want complex functionalities, you can also achieve it. So if you see here, this is how it is combined. So you have this repository. It has been extended by CRUD repository. So CRUD repository is extended by paging and sorting repository, and then paging and sorting repository is extended by JPA repository. And similarly, here you have different query by. These are basically to write the queries. So we will see by default, if you use a repository from Spring, like this, any of these, so you get by default some methods with which you can execute queries. So we will see them. So maybe there are also different ways to write queries. So one way is to write it like this, find by field name. Let's say this is an example. So this is a repository class, a survey repository, which is extending JPA repository, and then it has survey. So now in the survey, let's say there's a column called ID. So find by ID, by default, it will take the value and run the query against the primary key column. Let's say you want to write your own query, that I want to run a query by created date column, created by. Then you can run find by, just write find by and then the field name. What's the field name? Created by. So in the camel casing, first C will be capital and B will be by, in by B will be capital. Same goes for if you want to do a long count, find by ID in. Let's say if you want to do a query which is like select star from and then where ID is in, then you do this. So there are different ways to write queries. We will see them. Similarly, there's another way to write the query. Same query is like address query column. So on you write a method, you pass some parameter, and then you write the normal query like query, and then you say select something, and then you write the query on the class. See, this is not the select star from, it is the class on the choice vote counts class. You are writing some query. And then similarly like this, you say select V, not star, select V from vote, which is V, where now v.user.id is equal to colon user ID. And what is this colon user ID? The parameter which has been passed here. You can pass it here. Same here. So you can basically do all kinds of join operations also. So we will see all this in the future, how to implement these kind of queries. Next thing is, let's say if you wanted to add some restrictions, if you want to add some, let's say, restrictions, uh, then to your entity, you can use this kind of annotation. Let's say you have a name and you want the name should not be null or blank, and it should not be more than 40 characters. So you can add a max and a min of the length. So you can say at the rate not null, at the rate size, max is equal to this, min is equal to this. Similarly like this, and you should use all the annotations from java x.persistence. So here you see all the java x.persistence annotation has been used. And for validation, like not null, at rate in email, size, you should use java x.validation dot constraints from this package, all the annotations. You can also, instead of writing these two annotation, you can do the same thing like this on the name column. You just say at the column name is equal to name and nullable false, so it will be not null, and length you say 40, so it will be of 40 characters. So this will create a query like with the column name and the varchar 40. It will be the data type, and not null will be the constraint on this column. So you can give constraint here, constraint like this. So this was a very short overview of Hibernate, how JPA works, Hibernate works, how Spring Data JPA works. All the important concepts have been now covered. But don't worry, all this we will do implementation also in our upcoming hands-on classes. All the things we will cover in detail in the hands-on.
Welcome back. So if you remember our first lecture going to Spring Initializer, we had added some dependencies. One of the dependency was H2 database dependency. So we are using Maven as our build tool, and the configurations that we need for building this Maven project, like the dependencies, we are keeping in the pom.xml file. POM stands for Project Object Model, pom.xml file. Here we keep all the dependencies. So we have a project tag, and then it has its own parent tag. So parent is pointing to Spring Boot starter. Then this project itself, which is this one, has its own group ID which we had entered while downloading it from the initializer. Then artifact ID, its own version, which version of Java 8 we are using. Then it has dependencies tag, and this is an array. There are multiple dependencies. So we have added these dependencies. One of the dependency was H2 database. That was a dependency we added, and this is the database which is now will run on our file system. So we don't have to download any extra database like Oracle, MySQL. We will download MySQL later, but for now we will use this database. So again, if we go back, so in how the database works, there is a database server. On that database server, we can create multiple databases. Database 1, and then database 2, and each database has tables, table 1, table 2. So this is how it works. Similarly for database 2 also. So database server has multiple databases, and each database has multiple tables, and each table has rows and column, which where we store the data. We will see that in detail. So now I want to enable H2 database in my application. So when will this H2 database server run? Because this is also a database, so it should run as a server. Because this is part of our Spring Boot, so it will run on the same port and IP address as our Spring Boot will run. It will run in the embedded mode along with the same credentials, but it will have a separate URL, and that is what we will explore now. So there is certain configuration that we have to add. So I'm going to copy this and then I'm going to explain you the details. So the configuration for our database we will keep inside the resources file. Source resources application.properties here. We'll paste it here. So let's understand one by one the different properties what they mean. So here we are saying this is a database. So we are saying allow H2 database to be accessed via URL. So we have to enable this property. If we want to have a specific URL on which we want to see our database explorer on the browser, we can give that. I have kept it to default. Default is this only. If I don't give this, then also it will be available on this URL. Then the database name and URL. So here let's say I will say property management system DB. So I'm going to copy this and paste it here. So this is the database URL. So H2 database we can run in memory also and also file based. So in memory means until the time our application is running, the data will be there. As soon as it will stop, the data is gone. But what we want is even after we stop the application, our data should stay. So we have taken the file based. So remember to use this syntax. Now, this is a database, right? So database is going to, this is a database. Similarly, there can be many databases. So every database runs on the server and the server in this case is localhost 8080 slash h2-console. That's the server URL. So the server will have its own username password. So by default, the username is SA, password is blank. And now every database also has a driver name, driver class name. Okay, what is a driver class name? Let's understand that a little bit. So what we are doing now is we are using an ORM framework. ORM framework means object relational mapping. So let's try to understand that. So here we have our Java class and our Java class has a property called title description. So this was the property. So property, we know the property. The property class we created. So it has a title description. Then it will have a price. Then it will have an owner like this. Similarly, we also have to create a table. In the table, we have to create a table. Our database is inside our database. This is a table. And name of the table is, let's say, property table. This is the table. And now table has rows and columns. So this table will have first column as ID, which will act as a primary key. The second column will be this one, title. So title. Third column will be description. So description. Fourth column will be price. So price. Fifth column will be owner details. So let's say owner. If there are more columns, similarly there will be more fields here. Now, if we did not use any ORM framework like Hibernate, so what we are using? We are using an ORM framework called Hibernate and JPA. Hibernate, Hibernate and JPA. JPA stands for Java Persistence API. ORM, object, which means this one. Relational mapping. Relational means this one, table, and their mapping. So this object is mapping to this table. In this object, this the variable is mapped to this column. This variable is mapped to this column. This variable is mapped to this column, and this variable is mapped to this column. And that's it. If we will create an object of this table class called product entity 1 is equal to new product entity, and then we will set the value of this title and this, then this entry will be also stored in as a one row. Similarly, we will create object 2 of this, that will become another row here, another row. So the the class variables are becoming column names in our table, and the every object's data stored getting stored in the variables is becoming the values here and in a row. So this is called object relational mapping, ORM. And who is doing that? With the JPA specification, Java Persistence API specifications, we are using Hibernate and Spring Data JPA together. So Hibernate along with Spring Data JPA is doing this magic of mapping our Java class objects to database tables, their columns, and Java class objects values as the rows. So this is done by this ORM framework called Hibernate and JPA. For in our case, it's Spring Data JPA, and that's the dependency we had added. If you remember, we had added this Spring Data JPA dependency, this one. That internally this uses Hibernate framework. So Spring Data JPA internally uses Hibernate framework to do this mapping between our Java class object to database. So now comes the question, what is this driver name? What is this driver name? So this driver name is a specific to a database. So here we are using H2. So we will use or.h2 driver. If we are using MySQL database, we will use a different driver. And what this driver does is it tells Hibernate how to convert the queries from this Java code to a H2 database understandable language. Because every database you can write queries, but every database has small amount of difference in their syntax with which you can write the SQL query. Hence, this driver name helps Hibernate to know, okay, for H2 database, I have to write the queries like this to insert information to the table. For MySQL, there will be another driver we will provide, which will tell Hibernate to create queries for this object in a form that it will be stored in a MySQL database. For Oracle, it will be another driver. So driver tells Hibernate or the ORM framework how to convert this data in the supported database query. For Oracle, the query will be different. H2 it will be different. MySQL it will be different. So because of Hibernate, we don't have to write query. Hibernate or the Spring Data JPA, they will take care of generating query and dealing with the database. We will just focus on writing code and writing the queries also in Java understandable language. So we will see that in upcoming lecture. So now this is about whenever we run our application, what do we want to do? Do we want to drop all the tables in the database and create new tables again, which means all the data will be lost? Or we want to keep what exists, whatever table exists, and only if there are new items available, only then do the update. Don't drop everything, just keep updating. So this property that you see helps to do that, helps Hibernate to do that. DDL-auto. We can either keep create here, which means it will drop every time the application restarts. Everything will be dropped. New table will be created again and the data will be lost. But in real world, we don't do that. Otherwise, our application data will be lost from, let's say, from all social media platform, from banks. So it should be update. This one is used for enabling printing of query. So in our local development or in the dev environment, we want to see what kind of SQL query did Hibernate create for us. So if we put this to true, this property, it will print that query here somewhere. We will see that as well. And then we have the dialect. And this is the class which along with the driver works together to create the query of our Java code into a supported database that we are using. So if we are using H2, so this dialect will work with this driver to create H2 supported queries. If we are using MySQL, this dialect will go and create queries for MySQL supported database supported query. So I hope now what is an ORM framework is clear, what is Hibernate is clear, what is JPA. JPA is just a specification. Spring Data JPA is built on top of it. Hibernate has implemented that specification. So JPA is a specification. Hibernate is an ORM framework which has implemented the specification, and Spring Data JPA is built on top of Hibernate. Spring Data JPA is built on top of Hibernate. But the main goal is converting a Java class based data into a database table so that developers can only focus on Java coding instead of writing queries for the table. So let's continue in the next video to implement this whole thing that we just discussed. Thank you. I will see you in the next video. Welcome back. Now we know that how to configure our properties. So next we have to work on our next layer, that is the repository layer. So if you remember the picture, we have reached until here, service. And now we have made some configuration in our application, in our Spring Boot application about the database related configuration. So we have to now create a repository file which the Spring Data JPA will use to connect to database. And we know that Spring Data JPA is built on top of Hibernate, which is an ORM framework, and Hibernate implements the JPA specification. And it means is to convert the object into database tables, map the Java class variables to columns, Java class to database, and Java class object values to the row in the database. So this job we will give it to Spring Data JPA. So let's see how we can implement this. So first thing, we have to go to our package and create another package called entity. So what is an entity? Entity is that class which will get mapped to a database table. So why can't we use this DTO then? We can use this DTO. No, we won't be using the DTO, but we will need the exact same fields that we have in the DTO in our entity as well. The reason we won't use the DTO is basically responsible for holding the data in this layer, in the controller layer and in the service layer. But we want to have another type of class which will be holding the data in the repository layer, and that class is called not called DTO but entity. And entities are actual objects which the ORM maps to database. So we will see it now in action. Then I think things will be more clear. So copy the exact same fields of the entity of the DTO, and let's create the entity class called property entity. Hit enter and let's paste them here. we need to paste all the things that we copy from here. So copy the whole thing, paste it here. Remember that we also discussed every table has its own primary key column. This is this one, this primary key column. So in the entity, we have to also keep another column as ID. That will become the primary key column. Hence, we will declare private long ID, and this ID will act as a primary key column for our table. But how do Hibernate know whether I have to convert this class into a database table? Hibernate doesn't know. We have to tell Hibernate. And we tell Hibernate with the help of two annotation. One is @entity. So if you see, this annotation comes from JavaX persistence entity, which is nothing but Java persistence API, JPA, provided by Java. Then another is @table, and in the table we can say a name. If we don't specify any name here in the table, then it is going to create a table with this name. But what I want to have a proper name. So I will say property underscore table, property table. That's the name I'm giving. So it will create a table with the name property and underscore table. Similarly, what I want is I want to have various fields associated with this. So I want to make this as a primary key column. So in order to make something as a primary key column, we have to tell the JPA that this is the annotation, ID annotation. ID is the annotation with which we can tell JPA that make this column as a primary key column. So in our case, we are going to make this ID as a primary key column. So for that, we will use the annotation this. So now this column will be treated as the primary key column. And remember, we don't want to generate, we don't want to insert the value of the primary key column manually. We will give the values for this type fields, but not for this. We want the primary key column data to be generated automatically. So for that, we have to use, again, take help of annotations coming from JPA, that is generated value. And here we will say what is the strategy of generating the value. So what we are saying is please generate automatic values for this ID column, which is of long type. So now we want to say what is the strategy that you should use to generate random values. So we will say generation type dot auto. Using this strategy means whatever is the default generation type used in this particular database. For example, in H2 database, it will use that strategy to generate the ID. Basically, it's going to create a database sequence. Okay. Now, if I want a separate name for this particular column with some restrictions in it, I can do all those things. Like, let's say if I want this title to be with the name, different name than title. So I can use column, and here I can say name is equal to, I can say property underscore title. So now it's going to create a column not with the name of title but with the name of property underscore title. But for this one, if we don't give @column here above this, then it will create with this name. For this also it will create with this name. Can I give more things? Yes, I can say should this column be null? No, so nullable false. Any other constraints I can add? I can say length of the data in this column should be this much. It should be unique. So those kind of constraints I can keep on adding, and I can do the same with other fields as well. Like I can say owner email as well, anything. So I can say email nullable false. So I can give it here as much as I want. If I don't use for this, then it will be with this names. It will be created with default conditions. Next is either we have to generate the getter setters for this because they are private, or we take help of the Lombok. So we'll say getter @ setter, and we also need a no argument constructor. So we'll use @ no argument constructor. That's it. So now we have created our entity class. So in the next video, we will go and work upon our repository layer. So thank you. I will see you in the next video. Welcome. Let's go ahead and create our repository layer. Let's head back to our IntelliJ. Now I'm going to create another repository package. So let's name it as repository. And here I'm going to create a new interface called property repository. Yes, this will be an interface because that's how Spring Data JPA works. We have to create an interface, and then this interface should extend from CRUD repository. In Java, one interface extends another interface, one class extends another class, but one class implements another interface. So in short, same type extends each other. So here we have an interface which extends another interface. And this interface basically takes two parameters. The first parameter is the name of the entity on which the whole CRUD operation will happen, like the update select queries will run. In our case, that parameter is nothing but property entity. And the second parameter should be the data type of the primary key column of this entity. So let's go to this entity and see which is the primary key column. This is the primary key column because it is annotated with @ID. So what is the data type of this? Long. Hence, here we have to give long as the value. That's it. Now what will happen? Magically, this CRUD repository already has some methods if you see. So how did I enter here? Keep pressing Ctrl, hover your mouse and click. So here it says this is a repository which has methods like save an entity, save multiple entities, find an entity by ID, and here by ID it means the primary key column. Check if the entity with this particular ID exists or not. Find all, find by find all by ID, count how many records exist, delete by ID, delete all. So all these are already existing methods. Save can also be used for update. So if all these methods exist, which means we don't have to even write any methods. We can directly now use this interface because our interface is extending this, and all these were public methods, public abstract methods. So they will already be inherited here. Hence we can directly use this. All right. So now we have declared our repository. Next thing we have to do is if we go to our picture, like we used our service in our controller and auto wired it here for dependency injection. Similarly, now we have to inject our now we have to inject our sorry. So we have to now inject our repository layer inside our service layer and then auto wire it here for dependency injection. Let's do that. So this is our, let me minimize all this which is not needed so I can get rid of this. POM not required, DTO entity not required. I will, this is our service layer. Here I have to now say private property repository property repository, and then I have to also auto wire it. So Spring, so where is the implementation class for this interface? We haven't defined. Spring by default with the help of Spring Data JPA is going to create an implementation class for us. Just that we have to make sure we auto wire it, otherwise we will get null pointer error. And now we can call our repository here. So property repository dot save method. But this save method takes, what does it takes? It takes an, let's say, it takes an entity type, property entity type. But what we have? Property DTO type. So that is not correct. So what we have to do here? We have to now make sure that we convert it. So we have to convert the property DTO into property entity type, only then it will take, this function will take that. So let's go ahead and do that. So we'll say property entity. I cannot directly assign property entity equal to DTO. That's not allowed. So property entity PE is equal to new of property entity. Then I will say property entity dot set ID. We don't have to give, it will auto generate. I have to set property title. So I will grab that title from property DTO. So get title. So I one by one I will get the values from here and start putting it here in this object. And then I can save this, copy, paste. Now that is fine. Again, property entity dot set of address. So we will get it from property DTO dot get of address. Then we have property entity dot set of owner email, property DTO dot get of owner email. Then property entity dot set of owner name, property DTO dot get of. So we are just doing get and set, get and set. So this should be name, because we are setting in the name, so it should be name. Then what else is left? Property entity dot set of price. So property entity dot get of price. Okay, now for now we just ignore what we are returning from here and why it is null. Leave it. That's fine. We will work on it in future. Okay, now what we want is to run our application and see if everything is working. So let me run this application in a debug mode. As soon as I will run my application in the debug mode, you will see some magic happening here. Here we will, in the log, when it will start, it will try to create a table also for us. And because we have given SQL property show true, so it is going to show us the SQL statements here. So if you see here, it created a property table. Then it also created an sequence that will start with 1 and increment the value by 1, and this will be used for our primary key column, because here we said auto generated, and then it created this property table for us. So it created this whole create table query. We did not have to write anything, and now it has started. So if I go to the property file and again and show you, this is the property we gave. So it is showing us the SQL here, and then we gave this @ID and generated value this. So it generated a sequence which will start with value 1 and increment by 1. So first the ID value will be 1, next time it will be 1 plus 1 2, then 2 plus 1 3, because increment by 1. That's how it will be saved in the database. And next, what did we say? Allow this database to be accessed by the browser on this URL. So let's go ahead and try to access it. So if we go here, this is the URL, base URL, because we are using the embedded database. So this will be database will be also running with the Spring Boot only. So this is the database server page. There can be multiple databases. This is the driver of multiple databases. So let's go and grab our database. So this is our database URL. Copy this, go to the server page, paste it. Default username is SA, password is blank. So let's go and use the same. SA, password is blank. Test connection, it's successful. Connect. As soon as I will connect, you will see it created a property table column, a property table. And this property table, why its name is property table? Because in the entity we said create with this name, property table. If we would have not given the name here, then it would have created property entity with this name. Let's check what is the title column it created. Property title. See, automatically it created property title, but description, it will be description. Owner name, yes, because we followed camel casing, so it will create owner underscore name. Wherever it was capital, it will replace with underscore. See, but description, it kept description, email, address. Perfect. So now our table has been created. Very good. And it also created a sequence for us here. This is the Hibernate sequence it created, which we don't have to worry. And this Hibernate sequence value will be used to fill up the primary key. So click on this. So you can clear from here. Click on this and run. So now now there is no data in this row. But at least now our ORM mapping has been done, which means our table corresponding to our entity class, a table got created in this, which is with this name. Corresponding to these fields, different columns got created. That's what we saw just now, right? Table got created, columns got created, and this table and column correspond to this particular class, and this particular class corresponds to the table, and its variables corresponds to different column names. Let's check. Variables corresponds to different column names. You see this? Perfect. So ORM, object, and database is relational database. So relational mapping is being done. Who did it? Hibernate. How can we prove that? See, Hibernate. Everywhere it's Hibernate. So under the hood, under the Spring Data JPA, Hibernate is working to do this task for us. It's creating the queries and it's talking to the database for us. We are not doing anything. We are just using this interfaces, classes, and everything Hibernate is taking care. How? Because of the properties that we gave it. We said use this driver class, use this dialect, and use these configurations. All right. So Hibernate took those and it is doing our job. Now, now if I try to hit this, let's say send, so we see what will happen. So this is our controller. So request came here. Let's see. We gave two values only. Apartment 1 and nice property. That is fine. Others are null. That is great. So in our picture, from here, we gave a request. We gave a DTO. This is our DTO now in the controller. That's what we are seeing now here. Let's move forward. So to move forward, we have to go inside this. So I will click this F7. So it will go inside this. So where are we now? See, we are in the service layer. So let's check. So now our data, the DTO from the controller came to service layer here. Perfect. Now in our service layer, we are doing some conversion because our repository layer is not taking what is coming from our service, from our controller layer. So from our controller layer, it is coming as DTO, but our repository layer is taking entity. So we have to do this conversion. And this conversion that we do, which means when one layer gives one type of data, another layer, which is here, accepts another type of data, then the compatibility conversion that we do, which we are doing here, this kind of pattern is called adapter design pattern. Adapter design pattern, which is this one. It is one of the structural design pattern, adapter. What does it mean? That here, repository layer here, it's expecting entity, but service layer is giving DTO. So they are not compatible. So we apply a conversion. So we are converting the DTO to entity. And same way we will convert the entity to DTO. So this pattern is called adapter design pattern. What we are doing here. And what are in general design pattern? Design patterns are a way in which we can write our program so that it is foolproof, future proof, and it adheres to certain standards and guidelines. So it is a nice way to write program. So it is basically the best practices that we should use. Design patterns are the best practices that we should use in writing program. So we know about singleton design pattern, which is just one object gets created and reused. We know prototype. Every time new object gets created. We know the adapter design pattern now, where it is converting one to another so that the layers are compatible with each other. We know factory design pattern. Factory design pattern is one interface will be there, multiple implementing class will be there. The object of which implementing class gets created, that particular class functionality get executed. That's factory design pattern. We also have something called MVC design pattern, model view controller, that we will see in some time. But for now, if I now further go, because now I am in this class, I have to move forward in this same function, so I can use this F8. So what I'm doing, I'm taking the value of this. I will take this title value from this DTO. I will take it out. It's like opening one box, taking the value and putting it in another box. So I will evaluate. I will click evaluate. Sorry. So we have to copy this whole thing. So property DTO.get title and then evaluate. So it's giving me apartment 1, although spelling is wrong. Now if I move forward, it is already set here. So now apartment 1 is set. If you see, ID is still null. Who will generate the ID? Database will generate the ID. That's what we have said here. So ID will be null, but other things will be set. Let's go further. Let's move further. So it's setting the other values. And now if I click this, let's see what's the problem. Let's resume it. Let's resume it and we see what is the error. So it says that the property value cannot be null on, oh yeah, we have passed some null values. That's what it is complaining about. So let's clear this and resume this. I will resume this. So let me debug it again because we are passing null values. So database is not able to store null values. So let me start in debug again. Meanwhile, we will form a proper request. So here I will say what else we have to pass according to our DTO. In our DTO we have title, then we have owner name. Let's go and take the owner name. So let's also correct the spelling apartment. Owner name is, let's say, John Doe. Then we have owner email. So we will have it as John at gmail.com. What else? Let's check. So owner email, price and address. So we will use price and address. So price wise, I'm going to put some data. Price, what did we keep? Double. That's good. So price of this apartment, say 999 something. Then we have address, address, address XYZ ABC Street JKL country, something like this. Now it's done. Now if we try to send request, it will stop, it will get all the data, we will go forward, and if I go here and just resume this, we will see nicely our database will have some data in it. So I will cancel this and run it again. So session has expired. Let's log in again and click on this run. You see, very nicely we have the information now stored. Why is the description coming null? Let's check why is the description coming null. So we have description, that's correct. Nice property, DECRIPTIO in description, spelling is correct. In the property also description spelling is correct. Let's see in the converter. Yeah, here we forgot to set the value of description. That's why it is not correct. So let's set it. Let's set description is equal to property DTO dot get description. So now if we restart our server, it will also save the description. So this is how we basically save the data. So what we just did is we passed the information from the client postman to controller we receive the information, the JSON information in the DTO, and then we passed it to service. In the service we converted it to entity using the adapter pattern, and then entity we saved it into the database, and that's what we saw. So we completed the whole flow of saving a property in the database. Let's continue in the next video with this. Welcome back. Let's understand a little bit what do we mean by model view controller design pattern. So what it means is whenever we are passing some information from our client, it is coming in the form of JSON. So this information we are receiving in our controller layer here. So how? Because in the controller there can be many methods. This is one method, this is another method. So how will the uh, application know which URL should be mapped to which function? And that is where the controller is taking the control. which means the URL is getting mapped to a particular method. So controller is deciding that, okay, this is the method with this URL, it should get mapped. And then what should be the model that should be returned? Again, controller is deciding. Here we don't have a view. View is the page, UI. So in typical model view controller, what happens? This model will be bind to a view, and controller is going to decide which model is going to get to bind with to which view, and controller returns that. Hence it is called model view controller architecture. But for our case, we don't have the view, so we have the model and the controller, and the view is like the JSON data that is getting response. In the response we are getting JSON information, so this is acting like a view. So what is model view controller architecture? The model view controller architecture is model is the information that we get, the placeholder, this in the case here property DTO. Controller is the one who decides which model will get bind to which view, and in our case there is no view because we are building APIs. So JSON is kind of the view it is acting. Hence controller is deciding which URL the client is calling should get mapped to which particular method, and then it controller is also deciding which model data should be returned. So this is model view controller design pattern or architecture. Thank you. I will see you in the next video. Welcome back. So now what we want to do is we want to clean our code a little bit. So first thing that we want to do is in this service, what we did is we did some conversion from one data type like the property DTO to entity, because that was the need of the hour. So now this is fine, but if there are more data that we have to convert, get and set, it's not a good practice to do it here. For that we should create another layer called controller layer. So let's create a package called, sorry, converter layer. So let's create a package called converter. Here we are going to create a class called property converter, and then we will annotate this class with an annotation called @component, so that this class will be now becoming a singleton instance and we can inject it, auto wire it in our service layer. And now what I want to do, I want to create a class in function to convert DTO to entity. So I will create a function here, public convert DTO to entity. What does it mean? It says it is going to convert, it is going to take a DTO and return an entity. Hence the return type will become property entity, and it is going to take property DTO. Perfect. And now we can bring this whole piece of code that we have here, cut, bring it here, paste, and then we can return this, return PE. We can do this now. Now what we will do, we will inject this, we will auto wire this, we will auto wire this in our service layer. So we will say private converter, it's asking to import, so hover on it, just hover on it and import. So it's, you should take it from your package property converter, and then we have to also auto wire it, otherwise it will not get memory. Perfect. And now we can say, we can call property converter dot convert DTO to entity. So we will pass this DTO which is coming as a method argument. this one. And what we will get? We will get property entity, which is, let's say, PE is equal to. So now nothing changes. Our code is also quite simple. Everything will work as expected. No worries. Let's even test it out. So let me run this. Nothing will change. Just that we added another layer. Where did we added another layer? Here, between our service and the repository, we added another converter layer. So we are calling it as a converter layer. CTV converter layer. Okay. So now it has started. So let's go to Postman and I say apartment 2, and let the John Doe will be the owner, doesn't matter, and apartment 2, and address will be, let's say, KBC. So same owner can have multiple properties. If I send, it creates it. So let's go to the database. Let's run it again. Connect, select this, run. So we see nice property. Address is KBC Street, JKL country, and this is apartment 2. Perfect. So now nothing changed, but we were able to also improve our code. So if you see, the queries also get generated. Insert into table name. This is the query, insert into table name, and it is inserting the values which we are passing from Postman. So now what happened? The code from controller, it came to service, service to converter, converter to, then converted back to service again, and then passed to repository. Perfect. But if you see, we are returning null from here. We are not returning anything. So what I want is, ideally, whatever is the object created in the database, I want to return it back. So if you see, we are not getting the ID of the property because we are not returning the data. But our database has also a new column ID. So let's go ahead and improve our code further. Thank you. I will see you in the next video. Welcome. So now it's time for us to improve on our end-to-end flow. What do I mean by that? What I mean by that is, from here I want to return a DTO so that I can hold the ID of the entity which it has. So let me go ahead and create another field here called private long ID. Now our DTO and entity looks exactly alike. So there should be a question, why do we need two classes then? The reason we need two classes is, if in future something changes at our database layer, like in our entity, we don't have to modify things on our controller layer in the DTO. That's for the decoupling purpose. Whenever we develop applications, we make sure applications are loosely coupled, not tightly coupled. So let's go ahead and now create another method like this to convert the entity back to DTO. So we will kind of copy, we will go ahead and say public convert. This time we will convert the entity to DTO. And here, if we are converting entity to DTO, then this should take an entity and it should return a DTO. But then what we want is, we want to create an object of property DTO equal to new property DTO, and then now start setting the values. But what I want is, I don't want to set everything. So I will set the ID, and I can get the ID from the entity because now it will be created by the database as an auto-generated field. And what I want is just the property title. I don't need the other details. If I need, I can set it. Set. Or for now, let me just save everything and that's fine. I will copy this and paste it here. I just have to change things here and there. So now this will be all become DTO, 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 DTO. You can send all the data or any specific field which you want. Nothing, there's no issue with that. So copy this and here we'll change it to entity, 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 and entity. And finally, we will return the DTO from this particular method. So it's a return. That's it. Perfect. So now, if we go to our service IMPL, here we have to return a DTO. So I will say, after this save is being done, we will receive the entity object. So let's hold the entity object inside this same thing. So the same variable, first it will save without an ID field. Once it is saved, it will also have the ID field. So after saving, it returns the entry of the whole database. So this whole row, let's say it saved this new row, so it will also return this whole new row from the database. That's how JPA works. So we are holding that new row in this entity object. And now what we will do, we will convert this to property DTO. Property DTO, because here from this method we are passing property DTO. DTO is equal to, we can say, property converter dot convert entity to DTO. I will pass this and I can return this. That's it. I can even use this, reuse this variable as well here. There's no problem. So I don't have to create another variable. So I can say this and return this. So here we are first converting to entity so that we can save, and then we are converting to DTO so that we can return the DTO. So now from our service layer, the DTO will be returned. So next, where will we go? It will go to the controller layer. And if you remember, what we did is any post method, it should basically just not return the data but also return the response or the status. So let's create that. So we will get rid of this. We will now say response entity of property DTO equal to new response entity, and then the first parameter we will pass is the what we will get it from here. So what we will get, we will accept it inside this. So we will reuse the same variable, because for it works like this. First this will go, this data will go into this method call, it will get executed, then it will get returned, and we are assigning the same variable. So it is getting stored here in itself. Then we will pass it here and we will say HTTP status created. And now we will modify this method that it will return the response entity. And hence we also have to modify the return type of it. Perfect. So now if we run our application and see if everything is working as expected or not, if everything would work, then we will get a new entity with this details. So it's running now. So yeah, it's starting. And remember, whenever we are restarting our database, data still exists, the old data. It's not going away. The reason is because of the property that we have used here as update, DDL to auto update. If I make it as create, then as soon as I restart, this whole old previous data will be lost. Okay, now the data server has started. I will clean all. Go to here and I will say Jane Doe. I will change the name of the owner, Jane Doe, and apartment 3. I will say Jane, and I will say YYYT1, something like this, doesn't matter. And the price I can also modify. Alright, now if I save, you will see here we will get the same response back, but with ID as well, and this ID will be created here. So, and next thing is we will also get not get 200 OK anymore, we will get 201. So let's run this. Perfect. So you see we get an ID 35 and we get the status as 201 created. That's the proper HTTP status code for a post endpoint according to the RESTful Web Services standard. And here we see insert query got created. So if we see what happened, so data came to the controller. From controller, it went to the service. From service here, it went to the converter. This converter, which converted a DTO to entity, and then it came back to service again. Then it went to the repository. Here it's then saved it into the database. No, not here. In the repository, it used the JPA CRUD repository method to save. After saving, it returned the inserted record of the database that we received here. Then we converted again the entity back to the DTO and we returned the DTO from the service. After that, it went back to the controller from service and we received the information here with now it has a DTO with property information along with the ID of which got generated automatically in the database via the sequence. And now we are taking this and setting here and with the status code we are returning a response entity like this. And that's what we saw here. We got the ID along with the status code. If we check our database, let's quickly check the database. I think the session would have gone. No worries. Let's connect again. Search. So we see another entry in the database and the ID is 3 which we got here as well. Perfect. So this is it for this video. Thank you. I will see you in the next one. In this video, we are going to create another API endpoint that will get us all the data related to all the properties stored in our database and give it back to us as response. So let's go ahead and do that. So it will be a straightforward get endpoint or get when I say endpoint means another mapping that we have to do. So let's do that. So we'll say public and then get all properties. So it is going to return all properties. But what we have learned is we will not return only the property, rather we will also return with response entities. So let's create a response entity. So here it will be like this. But before we do that, for now I will just make this as void method to avoid any error. And what we will do is we will say property service dot get all. So we have to now create the same method again, get all properties. So we will go to the service and in the service we will create this method again. So because if you see now what is happening is because this is an interface, by default everything is public abstract, so we will get rid of this. So now we have to say this get all properties. So it will not take any parameter because we are getting all properties, and all properties means we have to return a list of properties. Okay, just import this, hover on top of it and import the java.util. So now we have added in the list. So here if we go to the service IMPL, it will ask us to hover on top of it. It will ask to implement method. Click on it. So now we have added a method. So from here in our controller, we can now call that method. So get all properties. Perfect. And what it is returning us? We just saw that. It is returning us list of properties. Get all properties. So take this. We'll say property list. That's it. And now what we have learned, we have to create a response entity. So let's create the response entity. So response entity, this time it will be response entity of what we are going to return, list of property. So copy this, paste it here, and then we'll say response entity equal to new of response entity, and then we have to pass it again. This time in the body we will pass the property list, and HTTP status will be OK, 200 OK. That is the part we wanted to do here. Next is we will return this response entity from our method. So it's a response entity. And now we have to take this and put it as a return type instead of void. So this part we have done. So we have done the controller part, which is good. But let's add the get mapping. So we'll say get mapping. And here we have to pass the endpoint. So what is the endpoint we want to keep? We will keep the exact same endpoint, and we will not have any problem because the method type is different. Here we have post mapping, here we have get mapping. So there won't be any issue. Let me stop the server. Now in the service IMPL, we have to now call the property repository dot find all. As soon as we do find all, so it is going to the database, and it is going to first it's going to go to the repository, and it is going to find all. When it does, it means find all this entity, because there can be different tables. So it's going to do find all on this because we are calling this repository here. So find all of this property entity. So it is going to return us list of property entity, list of properties. Let's say that way. Now we will see there's an error. So let's say what's the error here. It is returning us an iterable from here. Required type, it says required type list is provided is iterable, it says. So what we have to do, we have to typecast it. We can take this and typecast it to this type. So now we won't get any error. Perfect. But now we are returning a list of properties. So we have to convert it. So what we will do now, we will apply for loop, and I will take help of enhance for loop. So I will say colon this, and on the left side I will keep each entity. So I will say property entity, and I will call the converter. So I will say property converter dot convert. What I am converting? I am converting an entity to DTO. So I will pass the entity, this entity. It will give me a DTO. So let me hold the DTO. So I'll say DTO, and now I will create another list to which inside which I have to add the information. So I can say property list, prop list equal to new array list, and I will just say prop list dot add. I will add the DTO. So for every entity I'm getting, I'm first converting that entity to DTO and then keeping that DTO in this list. And at the end, I will return this list. Alright, so now we also completed our this layer, service layer. So service layer is calling the repository layer. It is giving the data. We are converting. We are returning the list from the service layer. And now we are this data is going to get returned to the controller layer. So let's this layer the data is returned. So let's start our server and test it out. So now we will go to our Postman and then we will take the exact same URL, but this time it will be a GET request. So I will go here and paste it here, and then I don't have to pass anything because I'm not passing, and I will hit this. So there you see, we have all the properties. This is one property, this is another property, this is another property, and we are getting also 200 OK. So what just happened is when we asked our from our client Postman, we asked the controller give me all properties. So it went to service and it asked okay, give all the properties. Then from here the service it went to the repository to ask all the properties. From the repository it went to the database. Database return all the list of properties entity. Then we got all the list of property entity, so we passed it to the converter. Converter converted the list of property entity to list of property DTO. So and that was in the service. And then list of property DTO was returned to the controller. And in the controller, we converted this list of property DTO along with the status into a response entity which we returned back to the Postman as JSON response, which was this one. In the controller, this was the JSON response with response entity and status. And that's what we see. So our Java data, which was the list of property, automatically got converted to JSON data as response. This what we see is JSON. This one JavaScript object notation. This is another. So who converted it? Again, Spring Boot did it for us. It converted the Java list into JSON array, and here it was converting the JSON array to Java object. JSON object to Java object. Similarly, a JSON array can be converted to Java object. So all this conversion from JSON to Java and Java to JSON is being done by Spring Boot with the help of its Jackson bind annotation and that kind of API it's using internally, which this input this mapping that we are doing annotation, these are taking care of this. So this is it for this video. I will see you in the next video. Thank you. Welcome. Now let's go ahead and see how can we do a full update of our data. So for that, again we have to go ahead and create some methods. So let me start by creating method here. So I would say update property. So we can update one property and then we will say property DTO. We will pass the new property which we want to update and also the property ID we will pass, property ID, and we want to return back the updated property object. That will be the return type. Now if we go to our service layer, it will ask for adding the implementation. So just hover on it, we will add the implementation. So here what we will do is we will say, first what we will do, we will first find out. So how do you update something? Let's look at the database. So this is our data. Let's say I want to update that this record, the complete record with full update, which means I will update this column, this column, this column, this column, everything I will update. That's full update of the whole row. So let's say I have to do this update. So first I need to get the ID of the row. Then I will fetch the row data, and after that I will modify that data and then update it again. So let's do the first step. First we will fetch the row with the ID. Okay, so for that we will go back, and here we will say repository, property repository dot find by ID. This is the method we will use. And what is the ID? We already got. This is the property ID. Alright. So this is going to return us, if we hover on this method or put, so you see it's returning optional of property entity. Optional of property entity. So let's capture that. So we'll say optional of property entity. So optional helps us. So I will say optional of optional entity. So optional helps us to do a nice null check. So I can now check if optional entity dot is present. So if there is any data inside it, only then we will go for update, otherwise not. So this helps in condition checking. So here I said, okay, if this data exists, then what we will do, we will bring out the information. So I will say property entity is equal to optional dot get. As soon as I do get, it is going to return me this entity. So optional is actually just a wrapper around us, our entity. It's a Java 8 feature, optional. Okay, now we got the property entity. So this property entity will hold all the data that already exists for a particular ID in the database. Now we need to override all the fields like the address, description, this and that, all with our own information that we got. So we'll do property.set. All this we will say set title, and we will override it with the new value that we got inside this dot get title. So in a way we will call the converter, and converter will do it for us. So I will say property converter dot convert. Actually we don't even have to convert it, we just have to set the data. We don't need to even convert it, we need to just override the data of this property entity from the new values of property DTO. So if I go to the converter, here I have already this piece of code, I will just copy paste. So I will copy this and paste it here. So we have updated the database property entity information with our new values that we are getting from our in the method, and this will be called from our controller. And now what we will do, we will just call the property repository again and call the save method again and pass this updated entity. So what this will do now, so this made it, so here we got the data from the database. So data from database, And after that, we are overriding its value with the one which we got from the front end. So now we are saving it. And then what we have to do, we have to basically return the updated entity, updated record. So I will say property entity, property DTO is equal to null, and I will just save it here. Before saving it, I will say equal to. In fact, we don't need the updated value because that already exists here. We already have the data which we want to update. But if we really want that data to updated data that we want from this particular, then we can also do that by calling the property converter dot convert entity to DTO. So we can pass this. This will convert this DTO and we can return this DTO. Perfect. And now this is the method. Now we will call this method from here, from our controllers. So we will say public. For now, let's say void update property. And now this will take two parameters. One is at the rate request body and property DTO, and then at the rate path variable long property ID. And we will have the at the rate put mapping here, put mapping, and we will say slash properties slash ID. What ID? This one, property ID. We'll paste it here. Now we will just have to call our repository from here. So let's call that property repository service, dot update property, and we have to pass this information. That's our DTO, comma property ID, and it is going to return us an updated property. So we can directly keep that updated property in this DTO itself, and then we are going to just copy paste this for now, or we can copy paste this, and we are going to return the response entity like this. Perfect. So now we have completed our flow for updating the property. Let's quickly test it out. Let's say I want to update the property XYZ. So let's see what data we have now. So this was the property apartment 3 we have, whose ID is 35. So let's update this. So I'm going to duplicate this now. Right here, click here and duplicate this tab. So now we have this information. In the body we have this. So now I will update this description to nice property, looks great, and then I will say Jane Doe, and then email also I will update. So just see, I'm updating more than one field. So Jane Doe at gmail.com. Price is also going to get modified. Let's say 22YY111. Country updated. I will mention this all, and I will not update this for now. So now we have to make this as a put. And what is the URL we have to form? Slash, and then we have to pass the property ID, that is 35 here. So if we go here, the property ID we have is 35. So 35 is the property ID and this is the object. So now this data will come here. DTO will hold this information. Let's restart our server, stop and start. Let me put it in debug mode. So whatever will come in the body will be part of the DTO, and whatever is coming here in the URL will be part of the path variable, this one. And then of course it will go to the service, and from there it will go directly. So let's put a debugger here and let's see if the server started. Yes, server started. Clear the console. Let's hit this. So as soon as we hit, it's going to stay or stop here, and there's a debugger. So let's check the property. So we have the ID as null, of course, because we are not passing a new one, and this is the value. And let's see the property ID. So this is 35. Let's go inside this method call, which is the service layer call. So we are here. So first thing we will do is try, it will find the object with property ID 35. So we'll go over. Okay. So it found it. So in the optional here we will have optional, and we have this property entity. So we see that it got our the data from the database for ID 35. So we got exactly this record which is in the database. Perfect. So first, in order to update, first we need to find and get the one which is in the database. Then we go and do a null check. Then we found the entity, and this holds the database data. Now we will override this data with the data that we are getting from our front end, which is in this property DTO. So we will override that. And we will override everything except the ID. So it is now setting the value. Now it will save this in the database. And now we will go back. We will go back and we will, let's say, resume it. And if we go to our response, we'll see that it has updated the information. See, updated. John Doe looks great here. And if we look into our database, this value should be modified now. Let's run it. Session expired. Connect again. Click here. Run. So we see the updated value. This is also updated. Updated. This is same. We did not modify. This is updated. This is same. We did not modify. So this is how we can do a full update using put mapping. So this is how we can do that. Okay, thank you for watching this video. Let's continue in the next one. Welcome. Now what we want to do is we want to look at an example of partial update. What do I mean by partial update? So let's say now in our database, I just want to update this column, description column of this particular row, and keep these values as is. So for that, we have to use a method called patch method. So what I'm going to do, I'm going to just copy paste this, or let me do it for you. So I will say public. For now, let's name it as void update property description. All I just want to update description. So I will say update property description. So I will say update property descript. That's the type of description. All right. And now what I can do is I can pass only the property description. So I can pass a string, or I can just use like this @ request body, and I can say property DTO long property ID. And now I will use something called @ patch mapping. And then what I'm going to do is I'm going to copy this exact same thing, and I'm going to just try to change the URL as update description, slash, so that tomorrow, let's say I want to update the price, so I can copy this and paste it again, and I can say update price, and everything will remain same, just I will make this as update price. So we can have many number of patch operation. All right, so now what I want to do is I want to also keep this method in my service, so copy this, and of course after updating, what we want is the updated DTO, so copy this. Yeah, similarly I will also copy this method, which is update price, and put it in our service layer. Similarly, we can have more fields, more methods stating update email, update owner name, whatever we want. Now we go to our service and hover on it, implement methods. So it will give us two dummy methods. Here again, we have to do the exact same thing what we did here. So we first need to find out the element. So we'll copy this, paste it here, and we'll find the element with the ID this. And what we want to do is, we instead of updating everything, we don't want this, because we just want to update description. So we don't want this, no, don't want this, neither this, only description, that's right. So we only want to update the description, and then we want to return the data. So I'm going to copy this, paste it here, and here I will just update the, instead of description, it will be get price. This will be set price. Perfect. So now we have this method, and this will be exactly the same, nothing changes here. So we have the price, the same entity we will pass to for update. So let's go ahead and now see to update the partial, to update the price, and also to update the description. So let's start our server. So we will use the same, and then we will just try to update the, let's see. So this is the ID2, property ID2. We want to update the description. Now it's null. So we want to update it with, yeah, our server has started. Let me clear it up. So this is an example of partial update. So our ID is 2, property ID is 2, but our URL is also changed. What's our URL? Let's see in our controller. Oh wait, before we test, we have to complete our controller. We haven't completed our controller logic. So copy this thing as is. We can paste it here. One thing that is not correct is, we are passing in update, we were passing created. That's not correct. We should pass OK, because then we are just updating something. So let's copy this, paste it here, and we paste this here. Same thing, nothing changes, and we change the return type to this and this. Okay, so now we have to update the description. So copy this URL. So let's start the server, go here, and we say update description slash, we can get rid of everything, and we don't even need title, we just pass the description. So we say nice property that, or we can say property facing the sea. Perfect. So let's go ahead and try to hit. So if we clear this, we can see the what is the query it's generating. So let's try to hit this. So we see that something went wrong. And what is that? It says API properties this. So we are using a wrong method. See? So we got a wrong status. 405 method not allowed. Because our method is actually patch, not put. So let's change this to patch, which is partial update. Now we send it and we have an error. Let's go ahead and check what's the problem. So the given ID must not be null, it says. And where is it? So if we go here, so we have property description, property ID is the value that we are passing. Properties update description 2. Alright, we have to change this method. Now it should not be update property, it should be update property description. And this method should be update property price. We made a copy paste mistake, that's fine. This is how we also learn and debug and fix errors. Save it. Let's start it again. Let's start in the debug mode to show you how we can debug this. So let the server start and then we can debug it out. The server is starting up. It's initializing the JPA entities. Started. Clear all. Let's put a debugger in here. Hit this. So we got, now what we have is in the property DTO, we will only get one field, that's description, others are null. And we will also get our ID. We did not get our ID, which means something is wrong. Yeah, there it is. We did not use the path variable annotation. So it did not set it. That's correct. Let's fix this as well. So path variable. Similarly, we have to use the path variable here as well. Now start it again. Never mind. We are now also learning how to debug our code because not always you will write the right code. So there will be situations where you have to also see what's going on in your code, understand the error and fix it. So that's good for us. We are doing that. So now clear the console. All right. Now we have the hover on it. We got this. Perfect. Let's hover on this. We got this right. Let's go inside this service layer. Let's go again. So great. Let's see what in the property description if everything updated. Yes, property facing C, other details are exactly same, nothing changed. Let's go there further and resume it. So what we see, it has updated the description. Can we check in the database? Let's connect again, run it. Perfect. Yes, we did updated the database. Let's try to update the price of this from 999 to something else. and we can use another method. So I can say price, and here I can say 232324.56, something like this. And here now the endpoint will change to update price because that's what we have in our controller. So in our controller we have update price as the patch method. Nothing else changes. So let's go to console, and here you see this is the select query that is got fired for this find by. Whenever we are doing this, first we are doing a find by, right? This one, and then for this save there's an update query that got fired, and if you see update only the property where the description value got updated. So now if I clear this and run it again for price, we'll see only the price will be updated. You see the price is updated. And if you see again two queries, one is select to find the item and then the update. Let's check the database. The old price was 999. If I run the query again, the new price is this. So this is how you can do partial update of the data using patch operation. So thank you for watching. I will see you in the next video. Now it's time to work on delete of a property. So for that, we are going to go to our property service again and create a method called, of course, we don't want to return anything for deleting that product, just void delete property. And for deleting a property, I would just need the property ID. So I will just say long property ID, that's it. And now if I go to my service IMPL, hover on it, implement methods, it's there. I don't have to return anything, so I will just say property repository dot delete by ID. Delete by ID. That's a method I have. I will pass the property ID. That's it. And now I'm going to call this. Let's see what is it complaining about. We have an error, it says. It says there's a missing return statement. Yeah, so make it small void instead of capital void. Yeah, that is also small void. That's fine. Now what we will do is we'll go to the controller and just create a method called public void delete property at the path variable long property ID, and we will use the exact same mapping as put, just that the annotation here will now change. It will be at the rate delete mapping, and then the method here we are not going to return anything, so we'll say property repository, sorry, property service dot delete property, and we'll pass the property ID. And if we want, we can say return new response entity dot response entity dot no content. In fact, we could copy this line and here we will not pass anything. This will be void, and this will be also void. So we could just say here null and http status dot no content because we are returning nothing, and then we can just get rid of this and say response entity. That's it. So now our delete property, we will delete the, it will call the service delete, and that will call the repository delete. Let's try it out. So let's say we want to delete the property of our 35, row number 35. So let's wait for the, so it has started. Clear it up. Let's form the URL. So it's more or less the post, but slash 35 is the ID. Nothing to pass. Method will be delete. Send. And we get no content and nothing is returned because we passed null. Let's check if we have the deleted item. So if I search, this 35 should not come. If I search find all. Perfect. So one is gone. Let's confirm in the database. Run, connect, run. It's gone, deleted. So this is how we can delete an item. And if you see, it also created a delete query for us. Perfect. So this is it for this video. Thank you. Welcome back. Let's go ahead and see how we can implement profile-based configuration in our Spring Boot application. So if we come back to this picture and you remember, we have the same source code like the same Spring Boot, but that can be deployed either in the local environment like we are doing, or it can be deployed in a dev environment which can be running on an Azure cloud or an AWS cloud or Google cloud or any other server. Similarly, there can be test environment, acceptance environment, and production environment. And this same code should run on all this environment without the need of any code changes. So there should be some way that we can modify the configuration based upon the environment which our Spring Boot will run. And that's where the concept of Spring profiles come. What we do is we tell Spring Boot that take this file and read configuration from this file for running on local. Take another file where you have configuration for this one. So if we have a different database on dev, so that configuration will be picked up from another file. So for each environment, we will create a different configuration file. So that's how we handle this. So let's go ahead and see that in the code how we will implement. Let's do that in the next video. Alright, now we have to go ahead and create the configuration file for our different environments. And where do we create them? We create them under SRC, source main resources. So source SR, that is SRC main, and then resources, and here we can create the file. The name of the file would be something like this, application, and then we have to give the name of the profile. So let's say this, in this file we are going to keep all the configuration related to local. So our profile name will be local and the file name will be application minus local dot properties. We can also create, I will copy this. We can also create YAML files, but for now we will stick to properties files. So I'll paste this again here. Let me try to paste this file and then we can copy paste. Then it will allow us to rename. Then I can create file for dev.properties. Then I can create file for test environment, test.properties. Then acceptance.properties. So I can say ACC. Then production, which will be the final one where the end customers will see our product or our website. So this configuration will be for production. So prod. Okay, now what we will do is this configuration that we had for our database in our direct file, which was application.properties. I'm going to take this, cut everything, and I'm going to paste it in the local. Perfect. And now on the dev environment, I don't want to use the H2 database. Rather, I want to use a different database. Let's go ahead and add the configuration for that. So for that, we will use MySQL database. So for that, I need to add this Maven dependency in our form.xml for MySQL. Then our Java application will try to start understanding how it should behave when we will try to connect to a MySQL database. So done. So now if you click this, it will import the new dependency for MySQL. You could also click here and reload from here, re-import. We don't have to do anything else. It is automatically downloading. Meanwhile, what we will do is we will go ahead and add the database configuration for our MySQL database. So I will copy this configuration. It is exactly same as the one which we had done for H2, just that the values are different. So I will paste this and let's go through them quickly what they mean. So here we have the database URL. So now here we will say it is not database for production, rather it is property property management system DB for dev environment. Let's call it that way. And the username password of the database server, we can by default the username is root and password is blank. So this is the database name and this is the database URL. So localhost 3306. We will run the database on that port. Next, I am going to copy the same thing. So here, instead of this, I will paste this. I will get rid of this for now. And I will copy this now and paste the same thing. Let's say, in test and acceptance also, we want to use the MySQL database server, but we want to have a different database. So I will go to test environment, paste this and change this value to test. Remember, we have not created these databases, we will create them test. Then I will go to acceptance as well and paste this. I will change this to ACC acceptance. And then I can go to production as well. I can change this. So now this will be production. So you see the same database server is running different databases and we have different configurations for different environment. Now how we will tell Spring Boot that which environment configuration it should pick. For that we have something called spring.profiles.active. A property is equal to, we can give the name and name should be either local, dev, acc, prod or test. Accordingly it will append application hyphen and then this value and it's going to take that file. So let's say I will say local, and if I start my application, nothing will change. It will work as expected as it was working earlier. So let it build and we will test it out. So if we have to start the dev environment, then it won't work because we don't have a database for the dev environment. So let it start. We are also going to experiment with the dev environment. So if you see now our application has started on local, and if I try to get this data again, I will get this information. But if I try to now change this profile to here as dev and try to start my server. Remember, when you change something in the property file or any code change, you have to restart your server. So doing this, now our application will not start, it will break, because it is now going to take application hyphen dev file, which is this one, and here we have configuration related to localhost 3306 and this database which is not running. Hence our application will try to make a connection and it will stop. You see, it says connection refused because nothing is running on that data on that URL. So the server, MySQL database server, is not running. That's why we get a link communication failure. So in the next video, we will see how we will use the database server to fix this problem. So thank you. I will see you in the next video. Welcome back. So let's go ahead and now try to start our MySQL database server. For that, search here as XAMPP, right click and or run as administrator. It's going to run in the admin mode, and that will help us. Now we can start the Apache and start the MySQL database server. So now Apache is starting on port 80 and the database server has started on 3306. So let's close this and try to go to localhost 80 or localhost directly and phpMyAdmin. And this is our database server where we can create multiple databases. See, so let's create one database for our application which was PMS dev. Copy this and go there and create this database dev. Don't do anything else, leave everything as is, and then we will also not create any table because this is not required. See, it has created a database. Similarly, we can create a new database. We can say test and prod and acceptance. Similarly, we can create them. And now what we will do, we will go back to our application, and here we have already modified the property to in our application.properties. We have already said use the active profile to dev. So now if I start my application, it will try to make a connection to this database and it will create the required table. So let's see. Now application is starting. So let it start. So see, it has already started our application without any error, which means it made a connection to the dev database on MySQL server environment. So if I go to this dev database and do a refresh, you will see it already created the sequence and the property table that we needed. And in the property table, there is no entry. So let's go to Postman and try to make an entry. So here I am in my Postman and this is the post. So let me try to create new property. I will do a send. So it will create a new property, but it won't create it in now our H2 database. Rather, it will create it here. So if I refresh now, let me here it is. So just click on it and again you will click on the table. So you will have this new property information. So now we are able to connect to another database with the same source code. Nothing changed on the code base. Everything is same. We are able to connect to a new database by providing a different configuration. So we can do the same thing for test environment. So if I change this, and same thing for acceptance environment and production. So if I change this to test and save it and start my application, now it will connect to another database on the same MySQL server. And this time the database will be test. So now it has not created any table because application starting. Let's wait. See, now it just created automatically. And who created it? Hibernate. Hibernate created it for us under the hood. With the help of Spring Data JPA, we are calling Hibernate. So if I now click send and go back and again try to click on this, so we will have an entry here in the table. Perfect. So now what we saw, we can have different database configuration for our same application and our application can run in different mode. So we have kept only the database configuration here, but we can keep any kind of configuration we want and that will work same as like the database configuration. So this is how you can manage profiles. So let's go ahead and in the next video look at by keeping another configuration also how it will work. Thank you for watching this video. I will see you in the next video. Welcome back. So what we will do now is we will try to see how we can access this configuration. Let's say I want to access this configuration in my data in my Java class. So can I do that? Yes, we can do that. We can access this property file configuration in any of the class in Spring which is annotated with either @service, @component, @configuration or @rest controller. We can access these properties there. So let's say there's a requirement that I want to use a different value for different environments. So let me create a property here. So yeah, so let's say here we will create another property. So that this is not related to database, but let's say property management system PMS dot dummy dummy, and we give a value here. This is a dummy for dev environment. But this property value will be different in, let's say, in the local. So let me put it here, and this is for local environment. Now what I will do, I will just put this as local, and I want to access this property. I can access this property also, any property I can access. But let me try to show you how to access the dummy property that we created. Let's say I want to access the dummy property in my controller class. So in the controller class, what I have to do is I have to just go at the top and say private string dummy whatever, and I will say @value. So what we have to do here is we have to say @value annotation, and in this we have to say dollar, and in curly braces we have to just give the name of the property. So let's say the name of the property is PMS dummy. So I will copy this and I can go here and paste it. And now I can take this and just print its value. Let's say I will print its value in the all properties. So I can see that. So system dot out dot println. I will try to see this. So now what will happen is if I start my server, it will give me different values for different environment. Let's try to see. So my application is starting up. Okay, now if I go, let me clear the console and I can access this. So this is, let me hit this, get all properties. Where is get all properties? This is post, this is patch, this is put, this is all properties. So let me hit this. So in this flow, we see that you see this value is printed for local. You see local. So it is coming from the local property file. Let's say I want to want the property of the dev dev one. So I can go to my active profile and change that to dev. So in the active profile, I will change this to dev. Can I also read more properties? Yes, I can read more properties. So let's say I want to also read another property. Copy this, and maybe I will want to read this property also, the database URL or something. Copy this, and I will just go here and say this, and I will say DB URL, and I can also print this one at the bottom. So you can do a lot of things. You can have different values for different environments and you can print them. So I will say DB URL. That's it. Now let me change the property to active profile to dev. Yes, it's done. Let's start it. So let us start the server, and now we should get the dev profile. So it will go to the dev property file and it will get the two values. One is this property value which we created and another is this one, and it will print it. So I am using just for printing, but you can use this property or this kind of mechanism to do any kind of logic you want. So let's go and check. So here you see, so it is for dev environment and we also get the property for dev configuration of the database. So this is how we can have different configuration. So, but if you see, this property name does not exist in all other files like test, acceptance, production, and I'm accessing this here. So sometimes it kind of complains there is a issue or error, this property does not exist. For that, always try to keep a colon after this, colon mark after this. This will not change anything in terms of your code or any problem. But if the property does not exist, then also you will not get any null or any error you will not get. So can I use this in like, any other class? Yes, I can also do the same thing. I can in the service ampere also. Any class which is annotated with this configuration, at that service, at that rest controller, other things, I can do that. So let me try to show you that also. I will just quickly print the value here inside service, and I will say dummy for now. Let me start the application. Let's change it back maybe to local, and I will start the application. We'll see now. So it will print two times dummy because we have printed two times dummy, and it will only print one time that one URL because we haven't printed the URL value. So let's see. So our application is starting now. It has started successfully. Let me try to hit this endpoint. Let's check. See, perfect. This is coming from local environment. This is because this was part of the controller. So it printed from controller. We have printed it here. So we have also printed URL. So it's coming from controller. But this is coming from service because we have printed that in the service ampere here. If we print the DB URL also here, it will print. So this is how you can create multiple configuration files. We can create multiple configuration files. In them, we can create multiple configuration as well, like this, my property, another property, and you can access them in any class that you want. And you can do some logic. You can say if this is dummy, then I do this. If that, you can do that. So those kind of things you can do with this. This is a very powerful capability to read what is there in the property file in your Java class. So you can read whatever you are having in the property file inside your Java class. So this is it for this video. Thank you. Welcome back. Now let's go ahead and commit our source code to the GitHub repository. So GitHub is a source code version control system where we can keep our code and different versions of our code, and we can continue to create different branches and work on those branches. So for now, our code, this one is not connected to any server where we can keep this. It is in the local. So let's say if something goes wrong, then there are chances that this code might be gone from my laptop. So let's say my laptop's hard disk gets crashed, so it will be gone. So that's not a good idea to keep the code in the local only. Hence, we need to always have a copy of this code somewhere on the server. And that is nothing but version control system. There are many. We can use the free one from GitHub where it provides the public repository. We can also use private ones. GitHub also provide the private one, but we have to pay. But there's also a free private one called Bitbucket, but it has a limit until which you can add the number of users. And of course, if you are using Azure Cloud, there you will have Azure DevOps. In that you will have the Azure repos where you can keep your code. Similarly, if you are using the AWS cloud, then there is AWS code commit where you can again keep your code. But all those servers where you keep this code work on the same principle of Git and its Git commands. So if we learn one, then we know how to operate with all others. So now what we will do, we will go to our browser and go to GitHub and create an account. Once you have created an account and logged in, then click on this plus button and click on new repository. Type the name of the repository. Let's say I will say property management. That's my name, property management. I'm going to just create the repository. Once it's created, it's going to give me few options. It's going to say whether I want for a new project. If it is not a Git project already, then we have to run this command. And if it is already a Git project but pointing to another server, then we have to run this command. We can also import this, but we are going to go with this approach. So I will copy this and then we have to go to the location where we have the code base. So the code is located here. So here I have to open git bash. If you don't have git bash, you can go to Google and search for git bash download. Here you can download it for Windows, but you have also other operating system. Once it's downloaded, just run the commands and it should be good to go. Like if you download for Windows, you have to just run the exe file and it should execute and it should get installed. So what this does is git bash, it helps you to connect to any of the Git repositories, like let's say a GitHub or Bitbucket or any Git understandable server you can connect. I already have installed the Git bash client, so I will directly go here and right click open Git bash. Once I have opened git bash, I have to first type a command called git init. It is going to initialize my repository as a git repository. Then what I have to do is I have to go for the other commands. So here we have the commands like git add, git commit, git branch, git remote push, and git this. So we are going to continue in the next video executing this command. But before we conclude this video, remember, in order to commit anything to Git, because this is your own Git project, anyone can see it, but only few people are authorized to commit or push the code here, who will have certain token. Earlier GitHub was allowing with username password, but now we have to use token. So for getting a new token, you have to click here, go to settings. I will open it in a new window. Here, go to developer settings. Here, click on personal access token. If you have any, you delete it and click on generate token. It's going to ask for your credentials, password. Just enter your password and after that give some commit, local code commit, something like that. Give a name for which you are creating this token, and then you can say, let's say expiry is 7 days. Select all these operations you will be allowed to do with this token. So I'm going to select all this except the delete ones. I don't want to keep any delete thing. Generate token. Make sure to copy this token and keep it somewhere safe. I will show you in the next video how we will use this token. Thank you. I will see you in the next video. Welcome back. So now we are back. We have our repository. We are now able to get the token, and we also have the repository your details, and we have already done git init. Once we have done the git init, then do git space add space dot. It's going to add index all the file. Dot means all the file present in this location. Then we have to do git commit minus m, and then you can put any comment. Initial commit. Done. After this, if you want, you can do this. It's going to create a new remote branch with the name as main. If you don't want, you can leave it. By default, it will take the branch name as master. That's what we are saying. But one thing we have to do now is we have to form a URL like this. Git remote set or hyphen URL origin this. So let me write down the steps that we are doing. Number one, git init. Then we have git add all, that is dot. Then git commit minus m, any message. Remember, all this is only for the first time, and in the fourth point we have to you form this URL. So for me this URL will be, I got my token because we created it, so I'm going to put my token here, paste it. Then I have to get the username. So username is this one, after github.com. Copy that, put your username. Then we have to also put the username again here. After that we have to take the repository name. So the repository name comes from here. So copy this, replace it here. Now take this whole command and run here. Remember the steps that we are doing is common for all the locations. So here it says no remote origin found because it is not yet connected to a origin. So let's go and add it to the origin. So this will be our first command. So here. So the fourth command will be this one to add it to an origin. And fifth command is the one with that we created. So let's run it, paste it, hit enter. Now we ran the git remote add origin command. After that, I can take this command and go ahead and run it. I can also type CLS and it will clear the console, or C clear, it will clear the console. Then I will paste this, hit enter, then it's done. So we are done. Now we just have to say git push. As soon as we do this, whatever code that we have done commit from here is going to go to the server. So I'll say git push. So here it says to which branch you want to push. So copy this, copy, paste, hit enter. Now it will push our code to the remote server. So let's put this as our final commands. And now we are good to go. So let's copy this and keep it as. So for security reasons, I'm going to delete this token so you will not be able to access it. For now, I have just kept it. So let's create a note file here. GitHub setup commands.txt. We can also add this to our code. So now this will be also committed together with that. So how can we do that? Again, so next time onwards, we don't have to do much. Just if we have modified anything, we will say git add dot. So let's first check if everything was here. So now it was blank as we have already done git push. So if I refresh, our code should appear and there is a branch already created called master. Great. So now if you do it for the first time, git is not in your laptop, then it might sometime ask you to set up the git user global and git email global. When it asks you, just type your name and email, and that with that name it will commit. So for me it's committing with the name of skill sapphire. All right, now the code, this changes here and it says 6 minutes ago I've modified it. Let's say now if I just added a new file right in my code, git commands. So if I want to modify, I can check the git status first. What are the changes? So it says new file has been created with this name, which is in my local but not in the server. It doesn't exist here. See, it's not there. So as soon as I say git add, it is going to index it. Then git commit minus m. So give a proper message added new commands file, and then we will just say git push. Now it's going to push this new change. So if I refresh, you will see a new file here. This is the new file created 13 seconds ago. It was pushed. So let's update the command. So this is for the first time Git setup. Git setup. Git and GitHub setup. From next time onwards, when you modify anything, next time onwards, when you modify anything, you run these commands. Git add dot git commit -m some message git push. Make sure to always do a git pull first. So one it should be git pull. So if something else is present as updated one, it will come in your code. So if I do a git pull now, it will say everything up to date because nothing else was committed. Okay. So this was how we can connect our local computer project to GitHub repository. So this is it. I will see you in the next video. Thank you. Welcome. Sometimes what we would like to do is we don't want to always use this git bash. So we would like to use IntelliJ for doing git commit, git push and those things. So for that, what I'm going to do is I'm going to go here. Let me delete this token, generate a new token, local code commit, give it a scope of 7 days, let's say. And then I'm going to give some permissions what we can do with this token. Try to avoid delete permission. So now generate token. Take this token and go to our command that we had. Let's replace this token with the new token and then take this command, copy it, paste it here, hit enter. So now our remote is connected with the server. Our local git is connected to the GitHub server with this particular token, username in this token. So let's go and use the same token in our git in our IntelliJ's GitHub. So in the IntelliJ, I will go here and settings. I can get rid of this one and click on in version control. You must be inside GitHub. So I will click on add account and then click on use token. So now paste the same token. So now it's connected. It says apply. Okay. Maybe we will do some changes. And now if I try to let's try to do a reload from the scroll down, reload from the disk once we do that so that it identifies the local disk changes as well. And now we will do git commit, and if we can double click we can see the changes also. What was the commit? Here it is no 3 lines. Here we have removed that. If you want you can give some author name here, but I will just say git commit and push. Let's wait, push. So it has pushed our changes successfully to the git repo. So remember, you always have to use the same token that you are using here for setting the git remote URL, the git remote set URL origin, and the same token should be used here when the file settings, version control, GitHub, and when you add this, then use token and use that token. Until the time that token is valid in here in your GitHub account, you will be able to do git commit, git push, other operations from your IntelliJ and also from here. So this is how you can configure your IntelliJ to do all the operations related to Git from here. Thank you for watching this video. I will see you in the next video. Welcome back. Let's go ahead and further explore a little bit about Git. So go to your GitHub and here we can go to our repository. So let's go back and go to the repository, and here we can see the new repository that we created. You can search from here. There can be many repositories. So property management, and here we can create new branch. So let's say I create a new branch called dev, and you have to click here, create branch from master. Similarly, we can create another branch, test. Again, create branch from master. Then we have acceptance. So we can say create branch from, we can choose this. We can choose from where we want to create the branch. So we can say this is here, right? So we select from here. So select this master, and then we can say new branch, which is acceptance, and we can say create branch from master. So always create branch from master, and then we have master branch where we will say create branch from. Then we have master branch which goes to production. So we have test acceptance production. Let's say as a developer you would work on the dev branch. So what we do now, we have the dev branch. So go to your IntelliJ. Your IntelliJ is not aware of, if you click see on the right corner here, your IntelliJ is not aware of the remote branches that got created. So to make your IntelliJ aware, right click on this, go to Git repository and do a fetch. As soon as we do a fetch, it is going to fetch everything. And now we will see in the remote branches there are different branches. So let's say I want to check out this branch. So git origin checkout. Just click on checkout. So now we will be connected to the dev branch. So here you can see it says dev. So whatever changes we are going to do now, it is going to go to the dev branch. So after, let's say I do some changes. Let's say from here, what I'm going to do, I'm going to add some code in the service layer. Maybe I will. So here I will say when you do control D, it's going to duplicate that line. So here I will say db URL. I saved it. Now I want to commit this. Before that, I will right click and I can say git, and then I will say compare. I can also compare my change. So I will say compare with branch. So with the same branch I want to compare. So I will say dev. So what I am seeing is there is a one difference. So it shows here. I see that in my environment, in here it says your version. So here is my local change. Local change is here. You see, which is extra code, and this is remote on the dev environment on the server on the GitHub. Here on the dev environment that code does not exist. So we are now comparing this. So now after comparison I think it's good, so I'm going to close this, and then what I'm going to do, I will close this and I will say right click commit. Also, if I want to see who did commit in the past this many time on the dev branch, so I can see show history. It's going to show me different history. So it says I have created some branches before that some commit was happened, and as soon as I click on this, there will be also files which will be showing in this commit what was the file. So I can double click and see the change also. So I can even right click and from here create a new branch or new tag, or even revert all my changes to this location. So whatever was here in terms of the timeline, it will come to my local computer. So I can do a lot of things with history, but mostly history used to check who committed what during which time period. All right, close this, and then now if I am fine with it, I'm going to that commit this one. So I'm going to commit directory. Now it is going to get committed to dev branch. So commit and push. So commit and push. But now it is going to get committed to the dev branch only. So now I have to make sure it also goes to the master branch. So if you refresh here, you see dev branch has one change. So I have to say compare and pull request. So here I have to say from dev branch to master branch, and I can see what are the changes. I can preview. Here is the changes. So here is my change which is in the dev branch, which is now going to go to the master branch. So the change is only in one file. If there are more file change, you will see the changes here. So I say changed system out statement, and then I can create a pull request. So I will create a pull request. A pull request will be created, and some people will have a look at the pull request, and if they find that everything is good, so they will merge the pull request, and merging the pull request. So when I merge the pull request, what happened? The code from the dev branch came to master branch. So if I go to the master branch now, in the same file, in the service file, I can see my changes already there. So I can go here. You see my change has now come here. So dev branch change is now in my master branch. So this is how we can work in one branch and bring our changes to the next higher branch. So if we are working in low dev branch, then our change can go to test. From test, it will go to product acceptance. Then from acceptance to production. This is how we work. And let's say if I have to take a new update from another branch, so I can right click again, git, and then I will say git pull. And here I can choose from which branch I want to change, take update. So if I am taking update from the same branch, it is just git pull or update. But if I am taking change from another branch, then it's kind of I'm doing uh, a merge from another branch. So be careful from which branch you want the changes to come. So you can just say pull. Now nothing will come because everything is up to date. And finally, you can again go here in git, and you can, if there are anything that you don't want to commit, you can do a rollback, which means the changes which are in the branch will come and your local changes will be gone. And you can of course also here check the history now, and here it will say changes on this file by this guy. So you can check, double click, yes, this was the change which was committed. So like this you can basically compare. So these were some of the git operations that usually you perform during your development in your project. So thank you for watching this video. I will see you in the next one. Welcome. So far what we have done is, from the functionality point of view, we have created a entity and corresponding database table. And what happens is we have created some APIs to say create property, update property, delete property. And whenever we create a property, we are adding property title, property description, property price, owner name, email. But now what we want to do is we want to extend this functionality. We want to create another entity which is called user, and we want to make sure the user is able to first register, then user is able to log in, and then after login the user should be able to create the property or update the property, delete the property. So what we will do, we will not keep this owner email, owner details, owner name inside this, rather we will bring that as a part of the user, because we will assume that the person who is registering is the owner of this property. So for to achieve this, we have to go ahead and modify some things in our application. So let's do that in the next video. So first we will start with creating our user entity. So here I'm going to create a new entity called Java class user entity. I can click this add so that it will do the git add for me automatically. Then I can go ahead and copy some annotations from here, and I'm going to paste it here at the top and change this to user table, or we can also say owner table, doesn't matter. And now we will go ahead and copy some fields. Let's say the ID, because the primary key is going to be same. Then what I want is some details related to the users. So what we want to do is we want to grab this information, which is user owner name and owner email, and bring it here. We will not keep that there. Then we are also going to create another field called price private string phone. So user will also have a phone number, and then user will also have a password, private string password. And of course we have the getter setter, so it will get generated because we have the getter setter annotation from Lombok. Next thing what we will do is I'm going to create the this is the entity we have. Now I'm going to create the corresponding repository layer. So I'm going to just copy this and paste it here and rename it to user repository add, and here it will be now user repository. Done. Let's remove the unwanted imports. So far we have done created our entity and created our repository. In the next video we will create the service. Thank you. Welcome. Now in the user service we are going to create user interface. User service interface. This will be an interface, and here we will have two methods. But before that we also need to have create the DTO. So let's create the DTO. So user DTO. In the user DTO we can get some fields. Most of the time we will need all the fields that we have in the user entity. So let's copy them. So we will have the password name, email, owner, everything. So copy this, paste it. We don't need this annotation, so get rid of that. So we will have this, and we will need the getter and setter annotation from Lombok. Now we go to our service. Here we will say private, not private. Instead, we will have a public method. By default, anything inside interface is public, so we'll say register. That's the function name, and what it is going to take. It's going to take the user DTO because we will get the data from the API, and what it is going to return, it's going to return the user DTO itself. Let's say another method that we will need is login. That is also going to return user DTO on successful login, and this is going to take string email and string password. So if the login is successful, then we will give this to the user. So this is our interface. So in the next video, we are going to work on the implementing class. Thank you. Welcome. Let's go to our implementing class, and here we are going to get rid of this because it doesn't exist anymore here. Let's see if there are any other error. We can get rid of those errors. So we will have some errors in the converter as well because this field doesn't exist anymore. So get rid of them and we should be good. So now if we go to the service IMPL, there is no service IMPL. So let's create one. So user service IMPL. Declare it with @service annotation so that it becomes a singleton bean and Spring is managing it. Let's implement the interface, user service interface. Let's implement the methods. Now let's inject the repository, private user repository, user repository. Let's auto wire it. And now from this we are going to call user repository dot save, but now it will expect us to pass the user entity, so we have to do a conversion. So let's go ahead and do that conversion of user entity, user DTO to user entity, and vice versa in the next video. Thank you. Welcome. Let's go ahead and create our converter. So right click, new, user converter, and we have to declare this as a configuration class or at least a component class so that this can be treated as a Spring Bean, singleton bean. So let's create a method public convert DTO to VO entity, and this time it is user. That's fine. This is inside user converter, so it's known. And what it is going to return? DTO to entity, so it's going to return user entity. And what it is going to take? User DTO. Let's create the entity because that's what we have to return. Let's set user entity dot set. We will not set the ID because it will be auto generated. User DTO dot get owner email. User entity dot set name. User DTO dot get name. User entity dot set password. User DTO dot get password. Dot set phone number. User DTO dot get phone number. And then we have to return this user entity. Similarly, we would also have to have another one which will be the vice versa. So that will be convert entity to DTO. User entity, and this will be DTO. Perfect. And here we have to create the object of DTO. And now we have to get set the values into the DTO and get the values from the entity and return the DTO. Alright, so now we have created our converter. So let's continue in the next video with our service layer. Thank you. Welcome back. Now we will convert our registration flow. Here we will use the converter and convert it. So just add the converter as an auto add, and then what we can do is now we can say entity user entity user entity equal to, we can call the user converter layer, and as we have made auto add it will get the memory, so we'll convert the DTO to the entity and we'll pass the DTO object here, so we'll get the entity, and then we will call the user repository dot save, and it is going to take the user entity. So remember to check one thing, here it should be user entity, in the user repository it should be user entity, and this should be long because we pass the name of the entity on which we are doing the CRUD operation. So now we have the user entity saved, so it is going to return user entity itself but with ID in it. So let's keep that, and now let's convert the user entity to user DTO. So we already have the user DTO variable, so we will hold it. So user converter dot convert entity to DTO. That's where we will pass this user entity. And now we are going to return this user DTO. So let's go and modify our controller layer. So let's create a controller. So user controller, and this will be again, we can copy some annotations from here. We'll copy this and we'll say here. So we'll say slash user, and after that we will have post mapping annotation. So we can also copy that annotate post mapping for simplicity sake. So I'm going to copy this. So user controller, we can go and paste this, and here I can say register, and we here we will say this will be a register, and this will become user DTO, and this will be our user DTO. Let's change this to user DTO. Perfect. Then we will have to inject the property service here. So private, sorry, user service. So we will say user service. Instead of property service, we will have user service here, and we'll do auto wire so that it gets the memory and as a singleton bean, and we will call user service dot, let's get rid of this register, and we will pass the user DTO. That's it. And then of course we will capture the same user DTO here, and we are going to pass this user DTO here, and this will be HTTP created, that's fine. And we have to now change this to user DTO type. So now everything is gone, there's no error. Let's remove unwanted imports. So I think our registration flow is complete. In the next video we are going to test it out. So let's do that. Thank you. Welcome. So now we are going to test our application. So let me start the server, and now the application is going to start. Let's wait for it. And while starting up, let's check under which profile it is running. So resources, application.properties. So it's running under local. So let's go ahead and check the database, what just happened. So here we have our database, refresh it. Session should expire. Then we log in again. So what we see, we have a user table. Let me run it, which has owner name and email. Let me clear this and click on user table and run again. And here we have owner name and email. So now we have owner name and email two times, which is not good. So let's drop that. How can we drop that? Stop this. We will go to our property file here in the local properties, and here we will say, if you remember this property, we have this DDL auto property. We will change it to create. So now it's going to create the tables again. So let's start again. So it's going to drop the table and create it again. And now it will create according to the new entity that we have, where we don't have the, so it will create the entity based on these ones where we don't have the owner email, other stuff. So let's quickly check now. Refresh, login, property table, run. You see it's gone. User table, run, it's gone. Nice. So now we can change it back to update again. Save it, and not here, sorry, don't do it here. In the application local properties, we have to change this DDL auto to update. And now it's not going to drop again and again, rather it will continue with what it will have. So by the time it starts, let's go ahead and create the request for our accessing. So this is our user DTO. So we have to create owner owner email and phone and password. So server has started. Let me clean it up. So let's go ahead and make a post request. I will copy this one, paste it here, make it as a post request. Let's check what will be the URL. Go to post controller, user controller, copy this API v1 user. So this will be API v1 user. Then what else we have? Register. So copy this slash register. Then headers we have to pass content type as application JSON because that's the format our server will expect. So application JSON. In the body we have to pass raw JSON object. So first thing we have to pass is owner name. So copy this owner name. I will say John Doe. Then what we got? Owner email. John at gmail.com. Then phone. We can keep more information we want, but we have kept minimum for now. We have given some phone. Password. Let's say for now secret 123. Let's go ahead and try to hit this. What we see is we get back a response, and in the response we get the same data. The ID is not set, and surprisingly we are also getting the password back. That's not good. But let's check what happened in the database. So we run it again. User table run. So user is successfully registered. That's good. But now our password is also getting returned in the response. How can we solve this? So let's go to our converter, controller, not controller, converter. Here when we are converting the entity back to the DTO, we should not set the password and we should make sure to set the user ID. So we don't have a ID field, so let's create one. Private long ID. Stop the server, and now we can say set ID, which will be coming from user entity dot ID. Now let's start the server and test it out with a different user. So now I will change this to Jane Doe. Jane Doe. This will also become Jane Doe. Number will change and password I can keep the same, doesn't matter. Let's see if the server started. Yes, it started. So let's go ahead and hit this. Perfect. Now we get the ID and we don't get the password. That is great. So this is how we can register a user. So let's continue in the next video. Thank you. Welcome back. If you see, we have a small problem in our response. Even though the password is empty, it's not there. We haven't set the password. It's still its value is coming null. That's fine. But what happens if there are 10,000 variables whose value are null and still they are being returned? So that's not good. It will increase our big array. So how do we avoid this problem? So we go to our DTO and then we say put this to annotation. JSON include only not null fields and it will ignore any unknown fields. So these two annotation will help us to, if there are any unknown fields, it will ignore, and also if there are fields which are not null, only that will be returned as response. So let's stop the server and start it again. Let's see what happens now. So server is starting. Meanwhile, let's modify our response. I will say Peter Dow, and here I will say Peter. Let's put some now random number. And now if the server has started, let's see. Yes. If I try to hit it now, you will see we are not getting back the password because the password was null and it got ignored. Reason, we have only said only pass on the data which is not null. So this is how we can basically ignore the data what we want to send back to the front end. Let's check in the database if our user was registered successfully. User table, run. There we have our user Peter registered successfully. So this is it for this video. Let's continue in the next one. Alright, so far whatever we have done for user registration, it's time to now commit our code to GitHub because it's a good practice to always commit your code regularly to avoid losing any code. And also other developers can, with you, they should be able to take your code and work on top of it. So as I was mentioning earlier, you can also have the the rollback. If you click on rollback, it will ask you which files you want to roll back. These are the files we have modified. So if you select the files and then click on rollback, it's going to roll back the changes. But our goal is not to roll back. Our goal is to commit the change. So let's click on git commit repository here, git commit directory, and then all these changes will appear. So we can click on double click and see the changes of each file here. So we can compare. Here it says your version, and this is the version in the dev environment on the GitHub. So we can compare this. So we had removed from here the owner and owner email and name. That's what it is showing. So similarly, we can check cross verify before committing any changes. So now what I want to do is I want to basically commit these changes. So let's go ahead. So let's give a meaningful message. So implemented user registration functionality. So when you're working as a agile scrum team in an organization in a project, you will be working, let's say, on this functionality. So there will be a number of this functionality. So you should also append the number. And when you create the branches, you should create the branches with the number. But for now, let's keep it simple, give it a message and then commit and push. So commit and push. It says there are some sonar lint issues. We will look at what is sonar lint. But if I want to review this, it's going to tell me that there are some issues that we see related to sonar lint. And how do we get this kind of thing? So if I click here, it says local variables should not be declared and immediately returned. And where is it showing? It is showing here in the user controller line 23. So let's fix this. If user controller line 23. So here it says, why are you creating a local variable? You could directly return it from here, which means I can get rid of this and I could just say return here. That's what it meant. So we will avoid another line of code. So that was the thing. So how do you basically do the sonar scan? So from the file, go to settings, and then we will have different plugins. So in the plugins, I've already install a sonar lint plugin. So in the marketplace here you can search for sonar lint. I've already installed, so I can ignore this. Once you search for it, you will get it here. Install it. And sonar lint is basically helpful for checking the code quality, bugs, code smells, if there are any code fixes or security issues. It will recommend you to fix those. For code quality purpose, we use sonar lint. So I already have it. That's fine. So now let's say we fixed one. We just fixed one. So I have to analyze it again. So I will right click on it, and here I can go. I should see somewhere sonar analysis. See, after you have installed this plugin, so run this again. So it will say proceed and it is analyzing now. After analysis, it's going to give us a lot of issues. So we have many issues. See, it says in the calculator main we have problem. So what it is saying, standard output should not be used directly to log anything. So we have to remove this, it says. Again, sister standard out is not allowed, it says. So let's go ahead and fix. Let's say in calculator main, I will go and fix this. So in the calculator main, I will go and fix this, remove this. Again, if I do an analysis, run an analysis, that will be already solved. So let's see, scroll down, analyze, proceed. So now if we see that calculator main issue is gone. Now if I check this one, again there is something here, it says useless variable result, that we can remove. And here it's saying property controller, there are some issues. So the level of issues, so red is very major, this one is minor, these are minor, and this is major. Sometimes they are also critical that we should look and fix. So let's say I will go to the property controller and fix this. So in the property controller, I can go and fix this. Let's say for now, I will just comment them. If I go and now run it, so now analyze, proceed. So we will see those complaints are gone. But now we have more complaints that we have to fix. So with sonar analysis, we can fix all these problems. So in the report, it will show us those issues that we have to fix. And here it says in line number 18 in DTO, it says that this should be removed. So we have commented this, so it's asking us to remove the comment. So these kind of things we can click escape, it will be gone. So this sonar analysis, this there is the sonar link tool. It is doing the analysis and then it is helping us to improve on the code quality. So now you know how to use sonar link plugin. So let me go ahead and commit our code. So I will go and commit. Implemented this. So I will say commit and push. Here it's already showing perform an sonar analysis. That's why it is doing this and showing us error. If we uncheck this, it won't do that. So commit and push. But it's always good to do this. Commit again and now push. So it's now pushing our code to the dev branch. See, to the dev branch, it's pushing our code. So now our code is pushed. So how do I know that? If I right click and try to commit again, I will not see anything, nothing to commit. That's gone. Alright. So this was it for this video. I will see you in the next one. Thank you. Welcome. Now what we have to do is we have to also implement the login functionality. For that, we need to go ahead and write the flow. So first thing first, we have to go to the repository. So in the repository, either we can do at the rate repository or without at the repository, anything is fine. Because this is an interface, doesn't matter whether we declare it as a singleton bean or not. Still it will work. Now, in our user repository, we have by default some methods called find by ID, find by exist by ID, find all by ID, delete by ID, delete by all by. But there is no such method find by email and phone. It doesn't exist. Does it? Let's check. So let me close everything, close all, open user repository and open this entity. So here we see we have owner, email and phone. So while login, when the user will try to log in, he will try to enter this and this. But we don't have a method in the repository. So that's where we can write a method. So let's go ahead and write a method. So what I'm going to do, I'm going to say optional of user entity because I know there will be only one user that will match. And then I'm going to say this will be the return type user entity. Of course, alt enter java.util. So here I will say find by. Now, how do we write queries? I have to take this field, find by. I have to copy this, paste it here, and make this small to capital O. And then I have to say and then I have to take the password field and paste it here. And I have to make this a small p to capital P. And after that, I have to just pass string email and string password. That's it. So this is the method. So we can also write our own custom find by methods. That's what I mean. So there are different types of ways with which we can write queries. So let's look at them. So if I go to this link, spring framework.guru spring data JPA query. If we are using spring data JPA like we are, then there are a variety of things we can do. So let's say this is a model or the entity class which is book and it has ID, ISBN, title, author, status. So we can write simple query with the help of query. And here we are doing find all books. So find all books. And how do we write it? Let me zoom it a little bit. So find all books we can write like this. Select, we have to create an alias B from what? Book space B. Book space B. And what is this book? Book is the entity, which is a CRUD repository. So select B from book B. You have to write @query and put the query as a string. And you can give any name to this method. And now it's going to return list of books. It's going to return all the books. Great. Let's see if there are other ways to write a query. Yeah. Here we have the code for querying a book with an index parameter using JPQL. JPQL is Java Persistent Query Language. So again, query, first we have to write. So here we are trying to find one particular book. So return type will be one book and give any name. Find by, title, author, whatever. Doesn't matter. Now we are saying query select B from book B where the books variable title is equal to question mark 1, which means the first parameter of the value will be replaced here, and b dot author will be second one. So author name will be replaced here. So can we write our own query like this? Yes, we can write our query, login query also like this. Is there any other way? Yes, there are native way. So if you have to write complete SQL query, let's say, so you can do that, but you have to do at the rate query value, select star from book where this equal to this question mark, and this, make sure to have comma and native query true. If you don't do this, it won't understand star. Then you have to go for this way, B form. Perfect. There's also another way with the address param. So if we go for select this, so this is the param. So if you don't give question mark 1 and you go for title, then in the method here we have to pass at the rate param, and this should be same as this, and then pass the first parameter, then the second parameter, like this. It will get replaced in the query. So there are different ways we can write all these queries. Next thing is, what is the other way that we are using? So what we are doing is, directly we are taking help of JPA, so that we don't have to write at the rate query. And how we are doing that? We are saying find by where on this entity. We are saying find by on this entity on two things: owner email, which whose value you compare from here, along with that use AND operation, and password whose value you take from here. And this owner email and password should match with the variables that are present here. So let's say I have to write a query find by phone, then I have to say find by and phone, and P I will make capital. So similarly we can write more complex queries also. We can say and, or we can also say or, we can also say between some range. Anything is fine. So this is the way we can write queries using Spring Data JPA and JPQL. So now that we have written a query to find out whether the user is existing or not, let's go ahead and integrate it to complete the login flow. So let's do that in the next video. Thank you. Welcome back. So let's say if you want to find between range, or you don't know some query, so you can Google and you will find it. There are also queries that you can write find by price in. So you can provide a list. So it will search for that. Or find by owner name in and provide the list of names here. It will look for that. So you can have in, between, and, or, all kinds of things we can do. Okay. So now we have written the query that will help us to log in. So let's go to our service layer. In the service layer, I'm going to create a method which I already have for login. So in the IMPN, I'm going to go and give implementation to it. So here, what we will do is, we will say property repository, not property, user repository dot find by owner email and this. So now I'm going to pass the email and password that we received. Perfect. And this is going to give us an optional. So optional of, we have said user entity. So OPT user entity. All right. And now it's a time we say if optional user entity dot is present, which means the object is present, then we are going to do we are going to return DTO, user DTO equal to null. We will say user DTO equal to, we'll say user converter, because what I want is I want to show the details of the user who is successfully logged in. So I will say convert entity to DTO, and that's where I will pass optional entity dot get, which is going to give me, so dot get is, this is going to give me the entity object, which is passed to the converter. Converter is converting it, and then I'm going to return it. Perfect. Else, there is no else. For now, let's leave it. We are going to tackle that later. In the controller, we'll go to user controller and create another method for post mapping. Because remember, login is also a secured endpoint, so we cannot make it as a get, because otherwise the user's password will be seen. Hence, we will make it secured. So we will keep post login and user DTO. So here we will say login, but our login just takes two fields. So get owner email, user DTO, get password. It's only going to take two things, and it's going to return something, and we are going to say okay, successful. So let's go ahead and test this functionality in the next video. Thank you. Welcome. Now we want to start our server and test this login functionality. So our server is starting up. Let's give it a minute. It was fast. So it did not take a minute also. Let's go to Postman, and I'm going to copy this register and I'm going to paste it again. Or rather, what I will do, I will just duplicate this. I will say duplicate current tab. Here I will change it to login, and header is this. Body, I have to only use the name, sorry, email and phone. Let me send this. So what we get? We get the phone number, user ID, owner name, and this. Let's say I will send a wrong username. I will pass 111. Send. So we don't get anything. It's null. But we have to handle this properly. This is not good. We are just returning null, empty. So we have to handle this in a nice way, like error, showing error that you are not authenticated user or a valid user. But that we will handle later. For now, we are able to now successfully log in our user. Perfect. So in the next video, we will continue further. Thank you. Welcome. Now we want to implement error handling, because we saw if the user was not registered, then we allowed it to register, and after that we were able to log in. But if the user was not existing in our database, we were returning just null or empty. That is not good. So what we should do is we should return some kind of error, so that whoever is at the consumer of our API or RESTful web service, they should be able to show proper error messages. So let's go ahead and implement the error handling. So the way we are going to implement error handling is with the help of aspect-oriented programming. Aspect-oriented programming is a way of programming which helps us take out the common functionalities and put it in one place. So let's try to understand what it means. Let's say I am doing These are my classes. One, two, three, four. There are many classes. And if I'm doing the same thing in every class, same operation, same type of thing in every class, similar functionality if I'm doing in every class, then it is kind of the same concern which is cutting across, cross cutting across. So, like error handling. Error handling is a scenario which can be done in any class. This class, this class, this class, this class. Logging. Logging is another example. Logging means writing some information in your log files so that you will come to know what is going wrong where when your application is running in your production environment or on higher server environment. So these kind of things like error handling and logging, they are these are the example of two functionalities which are and implemented in across almost all the files. Hence, it does make sense to not repeat this functionality everywhere. Rather, create a separate file like this for handling error. Similarly, create a separate file for handling logging, and then instead of doing error handling here, here, and here, and here, just handle the errors here. And whenever the error happens here, just throw that error, and this handler is going to handle it for us. So this is what is called aspect oriented programming. Aspect oriented programming, AOP, that is part of Spring framework. And what aspect oriented programming means, the common cross cutting concerns of your application should be pulled out from the core application and implemented in one centralized place, and that centralized place should be invoked whenever you want to execute that common functionality. That is what is meant by aspect oriented programming. So in the next video, we will go ahead and implement the error handling using AOP, aspect oriented programming. Thank you. Now that we know what is aspect oriented programming, let's go ahead and implement the error handling using aspect oriented programming. So for that, first thing we will do is go to our Java package in the source main Java, and in the package we are going to create a package called exception, and this is the package where we will put all the exception related information. So exception, and here what I want to do is I want to create an exception model, error model, and this error model will have couple of fields. First one is what is the type of error code, because every error can have error code, error message, error severity level, error type, many information, but we will for now keep just two information. So error code and error message, those are the two information we will keep for now. And of course we have to give getters and setters for Lombok so that it will generate internally the getters and setters for us. So @getter, @setter. So this is our model for error. In the next video we are going to continue by creating further classes that we need. Thank you. So now we have created our error model, but then we know in Java an exception is an object, and that exception object should be extending from exception class. So let's go ahead and create our exception class. So our custom exception class, I will name it as business exception. So remember, in any application, there can be more than one business exception or more than one custom exception doing different kinds of things. For us, we are going to create one custom exception called business exception. And this exception, we can go ahead and extend it from the default or the parent exception class. Then what I would like to do is, as this exception will be thrown from any place, we want to have the error model that we created as a part of it. And we will keep the error model as a list of error model, because there can be a situation, there will be multiple types of errors happening, and we don't want to throw exception for every time. Rather, we will want to calculate or combine all the errors once and to throw them once only. So I will say errors. Yeah. Now I will also create a default constructor for our exception class. Public business exception, not the default constructor. Yeah, we can create a default constructor, but also we would like to have a one parameterized constructor, and that will take nothing but this errors, and it is going to set the class level variable. So this dot errors equal to errors. And finally, we will need to have the getters and setters. Getter and setter. Actually, we can even get rid of this default constructor and give a no argument constructor annotation from Lombok. Alright, so now we have basically created our class that is going to handle the throwing of exception, which means we have created our own custom exception. So let's continue in the next video. Thank you. Welcome back. Now it's time to create our exception handler class, the AOP exception handler class. So let's go ahead and create our exception handler class. Let's give it a name, business exception handler. Or we could also just create one generic class which can handle any type of exception. So for, let's say, I would say I will create custom exception handler. And now first thing that we have to do is we have to tell Spring Boot that this is the class which should be the central class to handle all the exceptions. If we go to our picture, we discussed that now we are creating errors, but then there should be a central class that should be able to handle all the exceptions. So this exception handler class that we are creating is the central class. But we have to tell Spring somehow that treat this class as an exception handler class. And that is where we have to use this annotation called @controller advice. As soon as we do this, now Spring knows that this is the class which I have to look for a particular handler whenever that particular exception is thrown. For a particular handler when that particular exception is thrown. If exception A is thrown, let's say if exception of object A of a class A is thrown, then here it will come and check if there is a handler for that A or not. If exception of a class B is thrown, then here it will come and check if there is a handler for that exception be available or not. Alright, so we will create our first handler called, and that will be for our business exception. So for now, let's say I will say void. We will put what will be the return type, but let's give it a name. So we can give any name to this function. So I'm giving the most logical name. So I will say handle business exception because that's what we will use this particular handler for. And I'm going to also pass business exception as a parameter to it. So I will say business exception a variable. But how will Spring know this is the function it should come whenever business exception is thrown? And that's where we have to use another annotation, and that is called exception handler. And then we have to say what type of exception handler. Now we will say it should be of type business exception class. So whenever business exception class type of exception is thrown, we want Spring to come here. So let's say I will just say system.out.println. I will just print out a message business exception is thrown. And what I want is once the business exception is thrown, I want to return from here this particular exception to the front end so that the front end can get all the error messages or the error, because in the exception we have kept all list of error models. So it would be interesting for the front end to get the exception as well. So now how we will do that? The same old way. We will create return new response entity, response entity, and then we will say PE, and this will be of type. Here we will be returning list of business exceptions. So let's copy this. Sorry, list of business error model. That will be the type. And the first parameter we want to pass is bex dot get errors. This is the error model list. And the second parameter we can say http dot, we could say some error has occurred. So on the server there can be many types of error. So for now I will just say http status bad request. Alright. But now we also have to make sure the return type is modified here. So instead of void, we will have this return type. Perfect. So this is how we can create an exception handler class by telling Spring that this is the exception handler class with controller advice. And then we can create multiple exception handlers. So this is one, we can create another, another. And how will Spring come to know which handler it should take? So let's say if a business exception is thrown from somewhere in the whole application from any layer, converter, service, controller, anywhere, if this business exception is thrown, it is going to come here and execute this code. And that's what we meant by aspect oriented programming, or cross-cutting concerns are being removed from here, which means exception handling is not going to happen in any class, not here, not here, not here. Only exception will be thrown from one of this class. Handling will happen in one central place. So that's what we meant by AOP, aspect oriented programming way of handling exception. So in the next video, let's try to throw this exception and see how this comes into picture. Let's continue in the next video. Thank you. Welcome back. Now let's go ahead and go to our scenario where the user was logging in. So here the user was logging in and he was providing the credentials. So in the service layer, we have this user IMPL, and here we were trying to validate whether the user was logged in or not. So here, if everything was fine, user was logged in, then we are returning this. But what if user was not present, which means this will be not present. So it will come to the else block. And this is where we will throw our exception. So let's go ahead and do that. So first we will create a list of error model. Error models list equal to new array list of error models. And now we will create first one error model, because in this scenario only one error is happening. New error model, and I could say error model dot set error code as, let's say, invalid login, and error message I could set error message I could set incorrect username, email or password. And now we will add this. So if there are more errors, so we can continue to create this error model and continue to keep adding it to this list. So add error model list. So but here we have only one error scenario. But if there are more business validation failing, you can continue new error model like this, and add new code, new message like this. We can continue to do that. But as we have only one error scenario here, so now once we have created our error model list, what we could do is we can just say throw new. That's how we throw exception in Java. So throw new business exception, and we have to pass this error model list to it. That's it. And now it will complain, okay, we have to do this and that. So let's add throws. But if we don't want to add throws, that's also fine. We have to go to our, if we add throws, that's fine. Then it will say, okay, then add throws. But now if I go to controller, here it's complaining to add throws. So instead of adding throws everywhere, what we can do is there's a very simple solution to this. We can go back to our IMPL and say Control Z, and now it will complain. So what we will do now is go to our business exception in the exception package and make this as runtime exception. If we do that, it won't complain, because the exception is for checked exception and runtime exception is for unchecked exception. So it won't complain now, and we are good to go. So in the next video, let's go ahead and start our application and test this flow. Thank you. Welcome back. It's time to start and test our invalid login attempt. So I've started my application. Let it start. Meanwhile, we go to our editor or the postman, and here we have some username password which already exists in our database. Let's check that. So if I refresh this, so user table, there we have Peter at gmail.com, and password is secret. That's fine. Now let me clear this up. And if you remember, whenever the exception will be thrown from anywhere, in our case we are throwing it from our service IMPL. So this exception will be thrown and it will be handled automatically in this controller advice exception handler, and this is the handler method. So it should come here and print this first. So first let's go ahead and try the normal setting. So we see user is able to log in because we received the user information. But let's say I make a mistake in the password. Instead of 3, I make 33, something like this. Let's run this. Now we see we get a bad request, and then we get an this is an array of this is a list of exception, and what we get one exception block as this, which is the code as invalid login and incorrect email or password. If we go here, you see it also got printed system dot the business exception is thrown. So we managed to successfully test it. If I clear it out and now if I go back, correct this password, then this will go away and we will get a successful logins again. And this time it won't come to the exception block. So this is how the error handling or exception handling works. Thank you. Welcome. Let's go ahead and implement error handling for a scenario when the user is trying to register but he already exists in our database. For that, I'm going to head back to our service layer, and in the service we go to our user service IMPL. In here we are now directly calling the save function to save the information of the user, but we are nowhere checking whether the user is existing in the database or not. So first we need to check if the user exists in the database. So how can we check that? We can check that with the help of the email ID of the user. If the user with that particular email ID already exists or not in our database. If the user with that particular email ID exists, then we are going to throw an error or exception. So first we need to go to our repository to make sure we can write a query, our own custom find by query to find the user with the help of email. So here I can duplicate this and paste it here, and then the query will be only find by owner email, and we just have to pass one field to it. Now that we have written the query, let's call this query from our service IMPL. So we will call it as user entity. In fact, let's go ahead and use this user entity at the top so that we can reuse it. So we can put this here and we can say user entity. I would roll back that because we will get a user entity of optional. So I'll say optional of user entity equal to repository dot find by owner email. And we know that we are already getting in the user DTU the owner email. So we'll say get owner email. Now we have to check whether the owner with this email exists, and that we can do that with the help of dot is present function. If the user with this detail exists, then we are going to throw an error exception. And how we can do that? The same way that we did here. So we are going to create a list and throw this exception. But then now what we will do, the error code and error message will be different. So we can say email already exist. That can be an exception error code, and our error message can be the email with which you are trying to register already exist. Alright, so now we have added that error and here we are throwing that error. After throwing, the control will break and it won't come here. But if the user doesn't exist, then it will go via the normal flow. So in the next video, let's go ahead and try to test it out. Welcome. So now that we have completed our logic to throw exception if the user already exists, and we are going to throw this exception, and as we know that we don't have to do anything else. We don't have to have a try catch around this, or we don't have to, when we are throwing this, to have a catch block anywhere else. Automatically this will kick in and it's going to take care of the error handling. So let's start the server. So let's give it a second. So it's almost started. Yeah. So now our server has started. Let's go ahead and try to register the same user again. So here we have the user registration and I'm going to try to register this user again. You can already see it says email already exists and it also gives us the message that we had set. But let's say if I change this email to Peter1, then it will allow us because that's where we have our check was there. So let's check. So it allowed us to create a new user and after successful creation we got this information. But if I try again now, we will get the error because again this email is now registered in the database. So this is how we can block a user to register again and again with the same email address on our website. We can also do it with the phone number. We can also do it with both email and phone number. It's just a matter of writing the query here and query with email and phone and making sure we are throwing exception from our service layer like we did here. So this is how we can handle these kind of situations. Alright, now that we have tested this, it's time to again commit our source code so that we don't lose our changes. So right click on your project, choose the git option, commit directory, and you can give certain message email. We can say implemented error handling using AOP and click on commit and push, commit and push. If you want, you can review the sonar analysis and then fix the sonar things as we discussed earlier. For now, I will just say commit anyway and then push. Done. So this is it for this video. Let's continue in the next one. Thank you. Welcome back. So now we know how to handle these kind of validations where we are having control open upon the logic, like checking in the database whether user exists or not, whether it's a valid login or not, or maybe doing some other business logic checking if the price of the property that he's trying to add is more than some limit or not. All those logic we can apply and throw exceptions and break the flow of the program. But then, and of course this can be done in any service. We did it in the user service, but we can also apply the same logic in our user service as well. Okay. So now we have to also handle another situation. Let's say if we want to have some fields mandatory, email and phone number and password, but the user is not entering that. One option is to do a check, if else check in our service, and check same way for the property also, if user is not entering the property details and trying to submit the information. So one way to handle this is in the service, either here for the user DTO or for the property DTO here, we can here do an if else condition check. If this is, if property name is null, then add an exception like we did here. Uh, And if property DTO, that particular field is null, this is null, that is null. If there are four fields which are null, so we can add four errors to the list and then throw an exception like we did. That's one way. But there's also another cleaner way to do that. What we can do is in the user DTO, let's say we want to make these fields mandatory. And what I want to do is I want to say owner email should never be null, phone number should not be null, name and password. We can leave the name for now. Let's say this should not be null. So we can say not null. And one thing to make sure is that when we do this, we need to have a separate dependency that we need to add to our project. And that dependency will come from again from Hibernate, because Hibernate we are using Hibernate validator. So let's go ahead and first use add that validator dependency, because without adding that dependency we are not going to use the correct dependency, correct annotation. So we first go and add the dependency. So we are going to add the dependency not directly but with the help of Spring Boot, as we have been using that. So I will copy this and paste it here, and this will be, I will change this to Spring validation. So just type validation and it will appear. So this dependency Spring Boot starter validation will internally call the Hibernate dependencies or the JavaX validation dependencies, let's call it that way, because that's the core one that will get invoked. So the JavaX validation constants will be invoked via this. So let's go ahead and try to add this. So now we will see JavaX validation constants. So let's try to add it to here. And now when we say not null, this will, if it is null, it won't allow us to work. So then we can add a message here. What will happen, what message should be shown if there is an error? So I will say owner email is mandatory. Similarly, if we want to have some kind of size constraints, so we can do that. So I can say, let's say size, and then I can say minimum should be 1 and maximum we can give, or let's give maximum also for testing purpose. Maximum can be 50 characters. And if it is not, then we can say message should be owner email should be between 1 to 50 characters in length. Similarly, we can do it for password. Let's say I will say rate not null, message password cannot be null. There could be that user is sending empty field, so maybe we should also check not empty and give the same message. There can be a situation that user is entering empty, just blank, cannot be empty. Similarly, we can add this to here. owner email cannot be empty. Similarly, we can apply these annotations on other fields as well, which we want to make mandatory here and also maybe in the property. But for now, this is good enough for understanding. So once we have done this, now automatically Spring is going to throw validation exception and it with this error code with this error messages. But there has to be a error handler because this is not business exception which Spring will throw. So there has to be a custom handler that will handle this kind of exception. And that is something we are going to build in the next video. Thank you. I will see you in the next video. Welcome. Let's go ahead and add that handler. So I will say public and let's keep it for now void and say handle field validation. Doesn't matter and you can give any name. What matters is what will be the type of exception it will handle. So let's write exception handler and then now we have to make sure the type of exception that gets thrown when an validation fails on the field level is called method argument. And who is going to throw this? This is being thrown by the framework, SpringBoot framework, this dot class. So this is the exception object that will be thrown. So let's hand catch that and say, let's give it a short alias. So MENV, let's say. We took the first letters. And now that let's write the logic. So now again, we are going to get this data. We want to hold this data and so the way we will get this whole all this validation errors is kind of we will get it in the arrays or list format. So first let's try to grab that list. So list of field error. So that's the thing we will get. So field error is again not our class but it is coming from Spring Framework validation. So we'll say field error and that's coming from validation. So we'll say field error list. It's typo. Field error list and this is going to be basically coming from this. So here we will already get all the errors. So we just have to take it out. So we'll say get binding result dot get field errors. So we can get all the errors, right? But now we have to throw an exception with this kind of format. So we need to basically convert it now. So we have to convert one list into another. So let's create our list of, we can even copy it. So let's create this list of error models here and let's run a for loop. So we'll say for and then each field error that we will have, for each field error that we will get field error list, let's convert that to one of the error model. So we'll say error model with a new error model and then we'll say error model dot set. We have this code and then we will say fe dot get field. So what we want is we want to show on which field there is an error. Next is we want to also get the error model dot set message. We want to get the dot get. We will get the get default message. So let this continue in the loop and we will add this to this our error model list. And this loop will continue until the time until there is validation error happening for each field. So this will have that many errors. Alright. After this loop is done, we need to just do one thing. That is, we need to copy this line and paste it here. So let's copy this and paste it here. And instead of this one, we will be now returning this. And let's go ahead and change the return type of this method. So now if there is any error, it's going to come here in this method and this is going to get handled. So let's run it and see if it is working as expected. So let the server start, and what we want to do, we want to go here and try to not give this field anymore. I will get rid of this field and also the password field. So our server has started, almost started. Yeah, it started now. So let's try to run this. So we see there is a problem. Let's go ahead and check what's the issue. So here we get an error. It says null not allowed on the column email SQL statement. This is actually coming from our database, but I was expecting our validation should first kick in, and this validation should have been kicked in first. So there is some problem, looks like there's some problem which we need to first fix why it's not taking this validation that we have put. Instead, it's going to the database level validation. So let's try to fix this in our next video. Thank you. So in order to make sure the validation works, we need to annotate our method on which we are using this validation with an annotation called @valid. So enter @valid. Now what will happen is Spring Framework's validation will kick in, and then it will try to do the validation for the model that we have here, and then it is going to give us this error messages for incorrect request. So let me start the server now. So we missed out on this @valid here. So let's say if I also want to do a validation here, I need to provide the @valid here as well. So let me do that. So while login also, if we don't provide proper credentials, it is going to complain. When I say proper credentials means empty details. So now what will happen is it Spring validation framework will kick in and it will check in the DTO what is violated, and for those many errors will be created, and then argument not valid exception will be thrown, which will lead to this function in our controller advice via the AOP cross-cutting concern. And then we are converting all these errors that we are getting into our model and then returning it as a entity. So our server has started. Let's go ahead and test this out. So now I am here on the register screen. I will try to register. Alright, you can see it worked this time. This time we were able to get the error messages. So as we did not provided the owner email, so we have email cannot be null and cannot be is mandatory because of null and emptiness it's checking. So let's say same for password. Let's say I provide the owner email, but I provide it as blank. Then it won't say it's mandatory. Just it will say cannot be empty. Let's run it. So here we get owner email should be between 1 and 50 characters. That is getting kicked in. So if I say something like this, then that will disappear. Only the password error will come. So this is how there are dynamically error validation is happening. Same for if I try to log in and I try to ignore the password field, now the validation will kick in. So this is how we can do field level validation using Spring Boot and Spring Validation Framework, and we can handle the errors or exceptions using custom exception handler using controller advice of Spring AOP, aspect oriented programming. Thank you for watching this video. I will see you in the next one. Welcome back. It's time to understand about logging. Loging. Why it is important, logging, and what exactly is logging? Let's say now we are doing our development in our local environment, local laptop. Then we will put our source code to develop dev environment on a cloud server. Then it will go to test, then it will go to acceptance, and then it will go to production. On the local environment, I have full control of my laptop. I can go here and check what is happening in the code, what is not happening in the code. But I will not have that liberty to do on the dev server. Maybe on the dev server I have some amount of access, but on test I may not be even allowed to log in. Acceptance I may not be even allowed to log in. I may not be even allowed to log in production. Then let's say if my application something is going wrong, how I can check that in production? That yes, something is going wrong and I need to do this solution for that problem. If I won't be able to know that what is going wrong, how can I able to apply a logic or a fix to that solution and apply it here? So let's say if there's a complaint from a customer who is using our application property management system, and they said whenever they are trying to log in, they are getting 500 some error. So if we don't know what the user is inputting or trying to input and how he is trying to do, and he is getting 500 error, there can be hundreds of reasons to get this error. So there should be a way that our application which is running here is always telling us something about the problem if the problem is happening. And that thing that we write about the problem is called logging. We put log statements that it continuously tells yes whether the application is working as expected, if there is an error, if there is a problem. So we are going to implement logging. As a developer, we should always write log statements wherever we see there can be an error scenario or debug scenario, info scenario. We as a developer should write that log. And now log has different levels. So levels of log. One is debug level. Debug. We say debug log. Then it info. Then warning and then error. So, and there's also a trace. This trace gives lots of information. Debug gives less information than trace. Info gives much less information. Warning gives very less information. Error gives only error log statements. So we can decide to enable different types of log levels in different environment. Let's say debug can be enabled on the dev environment. Dev. Then info log can be enabled on test environment. Warning level can be uh, enabled on the acceptance environment. And error can be enabled on production environment. Because every log statement that will be written here on the file system will take some time and resources. So having too much logs also on our server is not good because it is going to slow down our performance. It's going to slow down our response of our application and bring down the performance. So this different log levels that we have, trace, dev, info, warning, and error, we try to keep the minimum logging in production, which is error. And this is one of the higher level than warning. Then warning is higher than info. So how can we also enable this kind of mechanism with the same code with profile based? We can say on dev enable debug logging, on test enable info logging. We are also going to see that. And the library that we will use for logging is called SLF4J. With SLF4J, here there will be a 4 with log back. There are other libraries also, but we will go with logback. There is also another one called log4j, but we will not use that. Logback is much efficient and we can provide configuration very easily in logback. So we will use SLF4j with logback for enabling logging in our application. And logging is nothing but writing your application state on a file system. There are different levels of logs. Based on each level, there can be the amount of data that will be written on the log file can differ. So on the dev environment, we do debug log. Test environment, we enable info log. Warning, we enable on acceptance, and error level of logging we enable on production. But it's not mandatory. You can also enable warning in production as well or info in production as well. And when we say enable logging, we can have control over the logging of our own application or also logging of the framework. Let's say we want to also log errors or warnings or info coming from Spring framework or Hibernate framework. Those also we can do. But for now, we will keep it simple and we will only enable logging for our own application files. So in the next video, let's go ahead and implement this logging mechanism in our application. Thank you. I will see you in the next video. Welcome back. Now it's time for us to do the configuration so that we could easily check out the different log probabilities that we have. Let's do the configuration. So if we are using our Spring Boot, logback with SLF4J by default comes into picture. We don't have to add any other dependency. What we have to do is we have to go to this file which is in the resources and we have to create a file called logback.xml and we have to paste this information what I have just shared. Let me explain you what it means. We are basically creating a configuration tag. In that we are creating a property which is just a variable and the name of the variable is home log. Value is logs folder and app.log, and then we want to keep a file rolling log. So we have to declare appender. So this is an appender. This is another one. This is, so there can be many appender we can give. And appenders are what they tell you how you have to log. So first appender that I have given is file based. I want a file to be created in this location and there my logs should be written. If we give file based logging appender, then we have to give this path which is coming from here. And then we have to also say in which format it should do. So I've given that it should continue to create an archive folder and then put the files there if they exceed the size of 10 MB. Each file, if they exceed size of 10 MB, it should create new files. And we gave some max and min capacity. So here we have given total size should be 60 GB and maximum it can stay up to 60 days. So this is the configuration for rolling file appender logging. Pattern we have given how it should print the logs. There is another one which is console appender, which we have also given here, which the way the log is getting printed here. So you see this is console logging. So it is printing the timestamp like this in this format up to here. Then it is printing what is the level, then process ID, and then further details and return message. That's what we are seeing here. Okay. So now we have added the appender, and this is how we can control. So we are saying Spring profile. When the profile is local, then you should have a root appender of debug level, and it should be referencing to this appender standard out. When it is info, when the profile is dev environment, then it should take the info as the level log, and it should take the file appender, which means it will create a file to log, do the logging. Same way for the test acceptance and production, we gave warning as the profile. I mean for warning as the log level and file as the file based rolling appender. So if we give file based, then we can go at any time log in onto our server and get these files, log files, and see what was the problem, when was the problem. So now that we understood what this logback is, let's go ahead and put some logging statements. So let's say I want to run my application in the dev mode. For that, we should have our XAMPP running. So let's go to this and say I will change it here to dev. And now I want to go to exception handler, and here I want to also print the log levels. So I will say in the log levels, I am going to print this as logger dot info. We can also give anything. So as soon as try to access the logger, it's not there, which means we have to create an instance of log4j logger. So I will say private final logger, and make sure this logger that you are choosing should come from slf4j. So this is should come from slf4j. slf4j logger equal to logger factory, again slf4j dot get of logger, and we have to give the name of this class. So I will copy this and paste it here and say dot class. Instead of doing this, I can also say this dot get class, which means it is going to take the same class name. So this dot get class. It's exactly same as writing this. Now I have instantiated or declared a variable for logger, so I can say logger dot info, and I can give the message what I want to show. So I will say here inside field validation, and now I want to print these details. So I will say curly braces. Let's say I will say hyphen in between, and then I can basically go ahead and say I want the field dot get field and comma field dot get message. So what will happen now is this get field value will get replaced here inside this bracket, and this value will get replaced here. So now I have given logger.info. I can also give logger.debug. So let me also show you debug. So I can have as many levels as I want. Similarly, I can also put some more log statements in my service layer. Let's say I will go to my service layer, and here when we got this email already exists, here we could also do a log statement. But we can do the exact same log statement here instead of doing it there, because we have the business validation exception happening. So if we do this logging in the centralized place, then we don't have to repeat it everywhere. So here is the business. So I'm not going to say this. This time I will say business exception occurred. So business exception is thrown. I can mention this way, and I can change this to pex.getCode. So this is a list. So we have to iterate through the list. We cannot do like this. So this I can get rid of, and I can say for error model in bx.getErrorModels, and now we can do the logging. I can say I can give as many levels I want. It completely depends upon the severity level, which one I want to call as an error or something. So I can say em.getCode, em.getMessage. Same I will repeat here as well. But I can also debug, press Ctrl D so it duplicate, and I can also say warn, same print same in the warn level, and print same in the error level. So let's say is thrown, I will say level as warn, just to show you. Level is error. Give you a feeling of how this works. Level is info, and here level is debug. Now let's go ahead and start our server. The same we could do here as well. Let's go and start the server and test this flow in our next video. Thank you. Let's go ahead and test our log statements. So we have added logging only in this class, but we can add it anywhere in our service, in our controller, anywhere we can add the log statements. So now what we want is we want to test it out. So what we have done is in our field validation, we have added a logger. So we have added it for the debug and info. So let's check our logback XML. So in the logback XML, we have said for the debug level, the profile should be local. So if you want to see the log in our debug mode, we have to run the application in the profile as local. But we are running the application in the dev profile. So we will get info logs, and that too we will not get it on the console here. Rather we will get on a file. And where will this file get created? This file will get created in the files rolling appender. So let's check. file rolling appender, and it's going to get created here, which means here means here. And where is that? In, so there will be a folder logs created, see, automatically created, and it has put all these log statements for the server startup because we have given info as the log. Now, what we will do is we will try to see, we will try to run this field validation, and we should see that it should also put it here. And the log file should get updated. So if I go to that register flow and try to run this, we will see send. So we got this, but it should also be now printed in our logs. So if I open the logs, it says here error occurred in. Let's try to read and understand how log statements are read. So in this log file, it says error occurred at this time, at this timestamp. In this package, the logging has happened and it has printed inside feed validation email, owner email, and owner email is mandatory, cannot be this and this and this. Okay. So this is what we were expecting as well because that's what we have logged here. Perfect. If I go and now run my same application, and we can do the same test for this as well, by the way. Handle business exception. If we try to, let's say, register the same user, I should get the error. So I will give control Z Z Z. Then it registered it. Now run. Yeah, so we got this error. So now this should be also printed here in our log. See, it says info log also got printed, warn also got printed, error also got printed. All the three got printed because we have, but you see debug did not get printed. So remember, if we have given log level in our file, in our logback XML file, if we have given the log level as info, then it will print info, it will print warn, and it will print error if they have been written. See, info, warn, and error is printed, but debugger got skipped. So that's how the log level works. The one which you have given equal to and greater than that severity, it will print. And that's what it happened here. So this is how we can print the log statements. Let's say now I stop the server and start the application in the different profile. So that will be, let's say, local profile. And now we will see the logs getting printed in our console here itself and not on the file, because this time it's going to take a different appender, because local profile will be debug log only, and on standard out, and standard out is like printing here in the consoles. So if I clear this out, if I now try to go and hit this, it gets this error, but here it will also print the same error. So it says bad request completed. Here you go. It says this. And because it is debug level, so it is going to print debug, info, warn, error, all the levels above it. That's how the log level works. Here we have given all, and minimum level we have given debug. So minimum debug equal to and greater than. So it's printing all of them. So this is how we can enable different types of log levels for different environments and print different log statements in file or in our console using logback XML and SLF4J. So now it's time to commit our source code. Let's commit this code base. Always regularly we should commit the code. So implemented logging with logback and SLF4J. Commit and push. We are ignoring the sonar analysis. We can do that if you want, but we are ignoring it now. We know how to fix it and click on push. So it's going to push all our changes to the dev branch. You could raise a pull request from the dev to the master branch if you want. So this is it for this video. Thank you. I will see you in the next one. Welcome back. So it's always good that you periodically raise pull requests from your branch to the master branch or to the higher branch that you want. We can raise directly to the master branch. So we will raise the from dev to here it says dev to master and we will say please review my code changes related to error handling and logging, and I will create a pull request. So whoever will be the reviewer, here there is no reviewer. If we had added reviewers, they are going to get email and they are going to look at our code. And then if they say that is fine, everything is good, they are going to merge the pull request. Once they merge the pull request, they will confirm it. Then our code will be merged automatically from dev branch to master branch. But while merging, while doing a pull request review, if they see, okay, there was some issues with this, let's say they will see this commit and they will see, okay, there was some problem with this code. They can give us a comment, some comment they can type here. This is not good, that is not good, you need to fix this. Then we have to go ahead and fix this and commit again in the same pull request, in the same branch, in the branch we were working. Automatically, this pull request will get updated and they will again review your change, the reviewers. And reviewers are generally the senior developers in the team, like the tech lead. And once they review it and approve your pull request, then you can merge it to the master branch so that the master branch change can go to the higher environment or in the production. But now our master branch and other branches are out of sync. So what you can do is you can basically rebase your acceptance branch and test branch from the master branch by taking the code. So this is it for this video. Let's continue in the next one. Welcome back. Now let's talk about documentation of our APIs, like the Swagger documentation. So what do we mean by that? So whenever we are creating APIs, we will be having many RESTful endpoints. So we have one property controller which has some endpoints like create property, update property, delete property. We will have user controller which has login, registration. Similarly, we will have many other controllers and they will have different endpoints. So now, if this is my application and this is my team who are working on it, they know everything about which endpoint exists where. But let's say now a mobile team or a website team, they want to consume our APIs. So how will they come to know which is the URL for getting all the properties and what should the parameter I should pass? And how will I get the response? In what format I will get the response? Same way, they will also want to know what is the URL I should use for which API or endpoint or URL, you can call it that way, should I use for login into the application? What will be the format of username password? What is the response I will get successful login? So all this documentation is not present for by default. So we have something called Swagger. Swagger, what it is a library, what it does is it If we add it to our code, this here, then it automatically generates documentation for us for our APIs. What is the API? What is the URL it is? What is the method get, post, put, delete? What are the parameters it takes? What is the response type? All this it will generate for all the API endpoints automatically. And if we modify any code in our controller or API, this next time this documentation will be automatically up to date. So what we will do is we are going to give this mobile team or the website team who are our consumers of our API this Swagger documentation file, and they are going to look at this documentation file and use the details from here to connect to our APIs or services. So let's go ahead and see how we can implement the Swagger documentation in our Spring Boot application for our RESTful web services. Thank you. So in order for us to enable Swagger documentation in our Spring Boot application, we have to add some configurations. So the first configuration that we have to do is we have to of course go to the pom.xml file and get the dependency that we want to add, because out of the box Swagger will not be enabled. So we need to go and grab the dependency related to Swagger and add it to our project. So let's go ahead and do that. So if I go to pom.xml file here, let's go somewhere down and add the dependency for it. So somewhere here, what I'm going to do, I'm just going to copy this piece of dependency, paste it here, and let's change the data or the group ID and artifact ID. So here it will become io dot springfox. We are using Swagger too, so io dot springfox. That's the group ID, and then we can say spring boot starter, and then spring boot instead of this, so it will be spring fox boot starter, and I can get rid of this test. And then we have to give the version as well. So version that we will use is going to be 3.0.0. So Spring Boot io.spring fox, and then Spring Fox Spring Fox boot starter, and then version 3.0.0. Take this, go ahead and refresh this so that it will download all the dependencies that are needed. After we have done this, then we have to go to our main file of our application. So here in this, we have to tell our application to enable Swagger. So we'll say enable Swagger 2. All right. And the last thing that we have to do is we have to create some configuration. So let's create a package called config. So we have to create a configuration so that Swagger knows that this is the configuration that it has to use. And Swagger also needs a Java bean or a class that needs to be instantiated as a singleton bean for Swagger to come into action. And that bean name is called docket. So let me create a configuration file first. Swagger config, and this will be a class, and let's add it to our git, and this should implement web mvc configurer. And let's declare this class as configuration, because inside this we have to declare a bean. So if you remember, we know from our starting class that if we want to declare any bean, then we have to use the annotation with that configuration above that class. So now in this class we can declare as many methods with name annotation as bean, and the Spring will create the singleton bean for them. So we will create only one method that will return the docket bean. That is, docket bean is the one which is needed by our Spring Boot for the Swagger documentation. So here we will annotate this with the @bean. And now we need to return a new bean from it. So we will say docket equal to new docket, and this is going to take certain parameters. So the first parameter it will take, we'll say documentation type dot swagger2. So we have to specify in which version format it should do. Then we can give more configuration, like we can say select all the APIs that are present inside the package. So we can give the package name now. So I can say request handler selectors, request handlers selectors dot base package. I can say when the base package is this, take this. So I can take all the APIs which are present inside the controller package. So I can go here and right click, and I can try to copy the path. Let's see what did it copied. Oof, it did not copy good. So let's just type it out. Or I can also go here and say right click, refactor, rename. So it gives me this path. So what I want is I want to grab all the APIs that are going to be in the controller package. I want documentation, Swagger documentation for them. Next thing that we have to do is we also have to say paths, and here we will say everything, all the classes. So we'll say path selectors. So whatever is present inside this package, start creating endpoint or the documentation for all of them. So we'll say slash dot star. We could say star dot Java also, but it's fine. And now we'll say dot build. That's it. And then we have to return this docket instance from here. So this is the documentation that we wanted to do. So in the next video, we are going to test this application. So let's start it and let's continue in our next video. Thank you. Welcome. So now we will start our application and try to access the Swagger. But if you see here, we are getting a lots of debug statements. So for that, we will go to resources and app, and then we will run our application in the dev mode. So we won't get that much logs, or we can go and change this local. In the local also it should be info. Anything we can do. So let's do that. Control Z, let it run in the local mode and change this one to info log. So in the local also we have asked it to run the info log. So now the application is starting, and what we can do is two things. One is we can go and access this URL, which is localhost 8080 v2 API docs. If I refresh, it's going to load that. I had already loaded it. So let the application start. So now application is starting up. Let it clear up. Let's refresh now. So if you see, this is a JSON file which tells what is the host name, which is the base URL which this client can use, the base URL. Then in that base URL, what are the different API endpoints? So there are different controllers, one, two, three. So if they want to access the API for calculator add method, they should access it this way. And then the method name is add. The method is returning all kinds of data. And the parameter is, first parameter is a name is num1, which is a query param and whose data type is number. Second one is also like this, third one is like this, and the response we will get is 200. Okay. So if we go to, let's say, the properties, so here it's saying to get all properties, we just have to hit this API endpoint which is of type get, and it is going to give us all the it's going to give us 200 OK with all the properties. So how do we know? It's going to return a list of properties. So list of items of type what? Property DTO. If I control copy this, control C, control V and paste it, then it is saying what will be a property DTO object look like. So even the property DTO object has its own field members. So let's check that. So this is what a property object look like. So it has an address field which is of type string, description field of type string, ID of type integer. So by this way, we can the client of our API, the consumer of API can easily understand how it works. Our API, how it works, what parameters it takes, what is the URL it should call, what response it returns. Everything is now easily given to our client. And because this documentation is getting generated out of the code, the the consumer will always get an updated documentation. There's also a UI format of this documentation. This is called like this. If you access via swagger-UI. This documentation is more the UI form, like it says which controller has what methods, what parameters. We will continue exploring this one in our next video. Thank you. Welcome back. So far what we discussed is how can we get our clients or the consumer of our API. So these people are called consumer of our API clients. So there can be mobile apps or website or there can be any other microservice or another Spring Boot which is trying to consume our API. So now they can read this JSON file and get information about us, what kind of API we provide. So we are going to save this JSON file as save as file and give them this URL or give them this file so they can know how to connect to us. But there's also let's save this for future reference. So I'll create a notes file. But there's also another way to connect or test our application. But this way should not be enabled. So this Swagger and this documentation should not be enabled for any environment. It should be only enabled for dev and test environment, not for production environment. So here, what we can do is we did another way to test it out is Swagger UI. So we can say Swagger UI.html or index.html. Anything is fine. If we go to this URL, we get this whole documentation. So here it gives us the URL to go to the default documentation, but also on a high level it gives us all the documentation. So let's say I want to test this get endpoint. So here I can add number. So I have to click on try it out and I have to add number 3, 4, let's say 5. I can execute and I can get the response as 7, let's say. So this way we can try it out many or any number of endpoints we want. Similarly with the user controller also we can get, let's say I want to try to register here and I want to try it out. So execute. So it gives us a response. It has inserted this like as a user. So we got a response. So if we don't want to use Postman for doing our testing of our API, this Swagger documentation UI is going to help us. And here we have different models of our application elaborated. So here we have the property DTO which has these details, other stuff. So we can further extend this API documentation in a much better way by giving more information to our Swagger doc. So that we can do by adding few more annotations to our application. So let's go ahead and try out one example in one of our controller methods. So let's do that in the next video. Thank you. Welcome. Let's say I want to further enhance my API documentation so I can use extra annotation provided by Swagger itself. So if I want to, let's say, extend this documentation, so I can say at the rate API operation, and this will come from Swagger, and here I can say the value. So I can give the name as what is this operation name, which is the method name. So I can say value as this API operation value is this. Then it will I can also give some notes. So I can say This method is is used for user registration. So this will be on the method level. If I want to give on the field level, let's say here also I want to do some API documentation, I can do that. So what I can do is I will just say API parameter param, and again I can go ahead and provide some documentation here. So I can say name. What is the name of the parameter? So it will be user DTO. And what is the data type of this parameter? So uh, I can say type of the parameter is user DTO type. Then you can give what are the some example values for this. So example, what can be the different example values like provide uh, user information. You can give some example values if you want. And is this field required or not? Yeah. So this is a required field. So you can say required true. So it's going to give a star mark that it is mandatory field. And if you want, you can also say what can be the value of it. So user data, that should be the value here you should enter. So all this information will be shown to the user on the documentation. So let's stop the server and try to start again and see if this information is getting adding any value to our API documentation. So let the server start. It's starting up. Let's clear everything. Okay, now if we go to our browser and try to refresh this, the API endpoint where we modified was in the user controller register. We can do the same in any controller, any method. But as we modified it there, we should see the information here. So here we get in the register. So it says now this method is used for registration, and that is coming from this information that we have given notes. And the operation name it says register, and that operation name is coming from here. So here we see it's register. And of course we have different other information like it says user DTO star required now because we gave it as required as true. So name is user DTO and required we gave it as true. So it's showing us there as a parameter sheet is required. And of course we have different fields, so you can see those fields here in this. So these are the extra information we can add to our API endpoint if we want. Here if we did not added anything, so it's not showing any details here. Alright. So this is how we can enrich our Swagger documentation. So thank you for watching this video. I will see you in the next video. Welcome back. One thing that I want to point out here is here we want let's say in any annotations we have directly given as login, but it can be also elaborated. We can say path is equal to login, and then we can say it consumes what does it consumes, what kind of format does it consume. So we can explicitly mention. So we can say application slash JSON is the type it is going to consume, and what is it going to produce. So we can say produces, it will produce again the same application slash JSON. So if we do this, if we don't give it, then by default it assumes that it is going to produce this and consume this. But it's a good practice to provide this information consumes and produces when we are dealing with if it is going to consume text or produce text or PDF image, those kind of information. It's not going to modify anything. So if I run the application, everything should work fine, just that it is now more explicit. And this can be done in any endpoint, post, put, patch. They are going to behave the same way. So it's not going to modify our functionality in any way. So let's clear it out and test this. So the server is starting up. So if I now go to login and try to register, so here I get I have to provide the password. But you saw the request went there and it was working as fine. So I will say secret 123 send, and it worked fine. So now it says what is the type that we are getting. So response is of type JSON. So let me show you the preview, and pretty format is this, so JSON, and request is of type application slash JSON. Response is also of type JSON, and that we made it clear that consumes application JSON, produces application JSON, but it can consume XML as well, produce XML as well, and PDF, anything that we want, we can specify here. So this is how we can modify our API endpoint to look slightly this way. So this is it for this video. Let's continue in the next one. Welcome back. Sometimes it becomes important to check our application metrics when it is running on production. Like what is the health of our application, if the application is running fine or not. So to know those kind of information, we need to add some kind of logic to our application. So Spring Boot has already given us the power with the help of something called a Spring Boot actuator, and that gives us the health information and metrics information of our application in real time. For that, we need to enable this dependency in our application. So let's go ahead and add this dependency as part of our POM. So in the POM XML file, I can go and add this dependency. Once we have added this dependency, make sure to re-import it by clicking here. So once, and let it download the dependency. For some reason, it is, no, we don't have to use dependencies tag because we are already inside dependencies. Just go for dependency, shift tab, and then it's there. So now it's resolving the dependency. Once it has resolved the dependency, so as per the documentation here, we can see that it's very clear that the there are actuator endpoints that lets us monitor and interact with our application, and it includes built-in endpoints. Endpoints mean API endpoints. For example, health. We can start our application and start accessing like actuators less health. Similarly, there are many other endpoints which are available. Audit beans, cache, conditions, props, info. Many informations are available. Metrics shows the metrics of our current application. So what we have to do is, and how do we enable these kind of endpoints? So by default, all the endpoints are enabled except the shutdown. And if we want to configure enabling of one or other endpoint, we have to do like this: management.endpoint and then the ID enabled property. So here, if we want to update enable the shutdown, then we have to say management.endpoint.shutdown enabled true. Similarly, if we want to, here it says if you prefer to enable, if your prefer endpoint enablement will be opt-in, then we can follow this kind of mechanism also, where we can say by default make it false, and only when we want make it true. So we can add this kind of configuration. So these are the endpoints that are by default exposed, but we should not enable all these endpoints in production. So just make sure what you want and we enable that or disable others. So let's add this into our documentation so that we it can be handy later on in the notes. So how to enable and disable endpoints. And the enabling and disabling, we can do it within the property file. So let's try to do one at least. So now that we have added the dependency, we just have to start our application. And once we start our application, this is the location where we can access the dependencies. So we can say localhost 8080 slash actuator. So let the application start. Let's check. So it is still starting up. It has not yet started. Let's clean it up. So it is doing some things. Yeah, now it has started. So let's go ahead and now try to hit this. So you see by default it has now if I go to localhost actuator, it gives me this information. So let me save this for future reference purposes. So now what we want is we want to access the health. So we can say health should be always made available. So health it says it's up. So we can even customize this kind of API endpoints by what different kinds of responses that we want. But for now, it's fine. We will take the default. So health is up. So here, if I go and try to access metrics, let's see what happens. So let's check what the API endpoint the metrics is enabled or not by default. So it says metrics shows the current metrics information of the current applications. So metrics, let's see if we did a typo. It says it's not available. Maybe it's not enabled by default. Let's check. So let's try to enable something. So here it says you can enable or disable each individual endpoint by exposing them or making them remotely held. By default, health is endpoint is mapped to actuators as this. The following technology endpoints are available, it says. So let's try to take this and try to enable one. So we want to enable, let's say metrics. So I will copy this and go to my property file, which is here. So I'm going to do this in this property file, which means it's going to be available for all the profiles. But if you want to have profile based, so make sure in which profile you want to enable what, put those values there. So here I will say ID is metrics, not shutdown. I want metrics to be enabled. Let me stop and start and let's see how we can access it now. So we want to test this. So in the next video, let's try to test this particular situation. Welcome back. So what happens is there are some different versions of the syntax that we have to use in different Spring Boots. So as we are using the latest Spring Boot 2.5 and above, which we can confirm from our POM XML 2.5 and above, that's the version. So we have to basically go and use different settings, and that settings is they will look like this. So if I go to my property file, it should be management.endpoints dot and then web or JMX. JMX is for, let's say, if you want to connect some kind of Kibana dashboard which would continuously stream the application information and show you on the dashboard, go for this. But if we want to see it on the website, on the web with the URL, we can go with management endpoints web exposure include. And then we will give comma separated health we want to see, info we want to see, metrics, environment, and beans we want to see. If you want to see more, we can go and take one of those property and then we can see the information. Let's say if I want to also see audit events. if there are any on or maybe config properties, let's say. If there are any, then it will show me. So let me add that config props, and in the JMX also I can add it, but this is not relevant because we are only going to access via the web. This is when another program wants to connect to your Spring Boot for information related to your Spring Boot health and monitoring information. Then you also have to enable the JMX endpoints. So let's start it now and try to see if we are able to access this health info, environment beans and config props. So it's loading now. Let it load. So it's starting up our server. Now it has started. Now if we go to our application and try to, let's say, metrics. So we'll get all these metrics, like these kind of information is available in metrics. If I say health, it will say up. If I say environment, ENV, that's what we have enabled. So we'll get all the environment properties. What else we enabled? We enabled beans, and we also enabled info, and we enable config props. So let's try to see if we have any config props. So it's giving us these many properties which we have indirectly configured. Hibernate dialect, Hibernate properties. These are coming as config props. Next is beans. So these are the Spring beans that we have, or different kinds of beans that we have in our application at this moment, and their scopes as well. So there are many beans at a single point of time in our application. And then let's say try to access one which we did not configure. Let's say flyway, which is not enabled. If I try to access this, I should get a white page error. Again, if I try to access env, which we have enabled, then we will get this. This is the environment which is running. So in this way, it also shows the profile which is active here, and server port is 8080. So in this way, we can monitor our application health and other information whenever we want with the help of Spring Actuator, and we can enable or disable different properties that we want, or different endpoints that we want to see in our application as a monitoring output. And this is how we do it. So thank you. I will see you in the next video. Welcome. So now let's talk about relationships in JPA. So relationships in JPA. What do I mean by that? So we have two tables now. One is our user table and one is our property table. Now we are creating properties in this table, but similarly many users can register on our website and create properties. But then one thing that we have not thought of is which has created which property we don't know. For that, somehow we need to create a link between this user table and property table, and that in Hibernate or Spring Data JPA we can achieve with the help of some annotations. So 1-to-1 annotation, 1-to-1, which means one user has one property. Similarly, we have one-to-many, one-to-many, which means one user has many properties. So in our example, this is the relationship. One user can have many properties. And there is a third one, many to many. In many to many, we say one user has many properties and one property belong to many users. So that's the situation. But for us, the situation is one to many. One user has many properties, or many properties belong to one user. So this is the relationship that we want to now establish between these two tables, user table and property table, with the help of Spring Data JPA. So let's go to the code and see how we can achieve this functionality. Welcome back. Now, what we decided to do is one to many relationship. So we have to go in our entity package. So in any Spring Boot application, this situation can arise that we have multiple entities and there has to be a relationship between them. So now our relationship is one to many. What it means is one user can have many properties many properties belongs to one user. So one user can have many properties belongs to one user. So what we have to do is we will go to the property table or entity and we will just create another field called private user entity user entity and we have to tell somehow Hibernate or Spring Data JPA that make a relationship between these tables. So I will say many property belong to one user. That's how I will read. Many property belong to one user. So let's do that. Many property belong to one user. And now after doing this, what will happen in the property table? These are the columns that were existing. There will be another column that will get added. And that column will be with a name. And we can define what name it should take. So let's say I will say join column and I will say name is equal to user ID because we know that user ID will be kept as a foreign key and we don't want its value to be false. So its value should not be null. The value of this user ID column in this table should not be null. There has to be always a value. That's what we say by this line. And the new column will be created with this value. And what will the value stored in this column? The value of this primary key. So here the user table primary key is actually getting referenced and becoming as a foreign key here. This is actually a foreign key. In the property table, we will have a new column called user ID and that will hold the value of user entities primary key values. So now what I also want is whenever I am fetching the details of the property, I don't want to fetch the information about the user. If that's my use case that I don't want to fetch the details of the user, then I have to by default say fetch equal to fetch type dot lazy. So what this will do is it will not fetch the user data while fetching property. If we want to also get the user information while property is being fetched, then we have to make it eager and by default it is eager. So this is it. We don't have to do much. And now what we can do is we have to just start our server. Let's see, our application is running in the local profile. So let me start the server. So it's starting up because our server is running in a debug mode. So it's printing so much logs and it is also taking time. So whenever we run the application in debug log mode, it is going to take time because lots of the logs gets printed. So now it started. Let's go to the table. You will observe that in property table, there will be a new column created. So in the property table, if I run, there's a new column created. And now if I go to the user table and run, these many users exist. So 1, 2, 3, 4, 5. So now what we have to do is whenever we will create a new property, we have to also make sure we give a user ID to it. That should be our goal. So let's go ahead in the next video to edit our code in such a way that we will also give a user ID while creating a property. Thank you. Welcome back. Now we have to go ahead and modify our code. But before that, what I'm going to do, I'm going to turn off this debug log. It's taking so much time. So for the local, for the this also I will make info, and for local also I will make info, which means now it is going to only print the info logs for us. So next thing what we have to do is go to the DTO. In the property DTO, we have to create another field which will hold the value of the user ID. So I will say private long user ID. So whenever we will create a new property, we will pass this user ID. And once we pass this user ID in a controller, this is our controller, we will get this here. So when we will save this property, we are now directly saving this property. But now things will change. We will have to first. So now we are here. Let's go to the service layer. So we go to the service layer of property. So here now what we are doing is we are directly saving the information. We are directly saving the information of the property entity. But now what we have to do here is we have to also first get the user from the database for that corresponding user ID and then set that user to this property entity. Only then we should save it. So let's go ahead and do that. So we have to first inject the property repository. So private, not property, repository, user repository at the rate auto add. So now what we are doing is because we also have to first find out because we are getting only the property user ID. With this user ID first we also have to get which is the user. We also know we need the complete user object. So what we will do with the user repository, we will say find by ID and we will pass the property DTO dot get user ID. So now what it will do, it will return us. Let's check what it returns. It's returning an optional of user entity. So let's hold this. So we'll say optional of user entity. So it's optional user entity equal to we will get this information. Now what we will do is we will check if is present if this is not empty because there can be a situation that if the user ID does not exist we don't want to save it. So we will say if this is present then we will do this, else we will throw an exception and we can get the exception code from bottom somewhere where we just created some things to check the user existence. I think we did it in the user service. So let's copy this. So what we will do is we will say user ID not exist. User does not exist. The user which is trying to create this property does not exist. We will say that. But if the user is present, then what we will do, before saving this into the database, we will say p dot set user entity is optional of get user entity dot get. So now we are getting a user entity from here and we are saving that user entity directly here. Which means what will happen internally is in this property object we are now setting the user to which this property would belong. So now if we try to start our server and we will try to save the user, you will see it will save it corresponding to a user ID. So let's do the testing part in our next video. Thank you. Welcome. The application has now started. So let's clear everything. And now we go to our Postman. And here we have the get request. And here we have the post request. Let's check which is the post request. This is the post request to create the property. So here we have to say user ID and we have to set the user ID as 1. How do I know? From the database, we can check that. So I want John Doe to be the logged in user and he should create the property. So when we will have the entry, here we will have 1. So let's go and say user ID 1 send. So we now see we received user as null, user ID as null because we are not returning that in our response. That's fine. So now if we go to our database and run this, we will see one user based the user 1 created one property. Let's say the same user creates another property. I say 4 and run. If we go to the database, we will see run. So same user created two properties. Let's say I want another user also to create a property. So let's say 97 is something. So I will use user ID 97 and let's say apartment 97. I will say 97. 97 send. So what we are seeing here that this is property 1 which belongs to this user, property 2 also belongs to this user and property 3 belongs to another user, which means many property 1 2 can belong to one user, and that's the relationship we have established. We have said many property can belong to one user and that's what our relationship is. So we are good, we are able to now easily get the we are able to save the information. So let's see in the next video how we will able to how we can get all the properties belonging to one user. Let's continue in the next one. Thank you. Welcome. Now if I just go and try to search this, so it's getting all the properties belonging to all the users. That is not good. Of course, we need all the properties belonging to all the users to see on our website so that we can contact the respective property owners. But what we also want is we want to also get the property belonging to one owner so that when the property owner will log in, he or she can see all the properties belonging to him. So for that, we need to go to our code. stop the server, and first thing is go to our controller layer, and we will see now we have this properties which is getting it for all users. We will copy this, duplicate this, and let's convert it to another endpoint. Get all properties for user, for a particular user. Let's call it that way. So then we will have to pass slash users slash user ID. And now I have to use as a path variable. I will say user ID. I'll paste this, and I will say long user ID. Let me get rid of this. So let's create another service, or we can even modify this service if you want, or I can even create another service. So let me create that. So I can say list all properties. I can copy this and say for user, and we will have the long user ID in it. So for a particular user ID, we will get all the properties. So let's add unimplemented methods. So now the code is going to be exactly same. Just that now instead of find all, we will go to properties repository and write a custom query. And here we will say list of return list of property entity properties equal to import this first, not equal to, but let's give a name. So we'll say find by, but we need more than one. So find all by, and by what? Find all by what? Let's go here. So we'll say find all by user entity ID column. Find all by user entity ID column. So we will copy this. Find all by user entities ID column, and then we'll pass long user ID. And now Spring Boot or Spring Data JPA is automatically going to filter in this property entity all the users belonging to this user ID, and it will give us that list. So let's go to our controller. First, let's verify the service. So we have this now. So we'll call find all by user ID, and we'll pass the user ID to it. Done. Other things we will not touch. Let's go to the converter, and here we have to also now set property dot set user ID, set user ID is property entity dot get user entity dot get ID. And of course, we don't have some fields. Which one? Let's check. Never mind. Okay, so we got this. So we have set this value, we have set this. So in the next video, let's try to start the application and test it out. So let me start it and let's continue in the next video. Welcome back. So now it's time to test our application. Before that, let's go ahead and quickly review. So this is the endpoint that we will hit in the controller, and we will have this method get all properties for user, and we will have this path variable. After that, in the service layer, we will call this method get all properties for user, pass that user ID. In the service layer, then we will go here, and in the service layer we will call a method called find all by user entity ID, and it's going to return us the data, and we will return that same data back. It will go to the controller and then response. Let's go ahead and try it out. So this is the endpoint that gives us all the properties. Let's go ahead and call the endpoint which gives property for user ID 1. There you go. So we have two property by user ID 1. If I make it 97, we will have one property. Yeah, but we get this value which is not required. Let's fix this. We can fix this by going into our Pojo or the DTO, and our DTO does not contain these two fields. We have already moved to our entity, so we don't need them here. So now if you see, we when we make calls to these properties, we fetch this information, and if we go here, the in the repository, we see that we have used a query. So we could write query like this, or we could also write query. The same thing can be also done with the help of this. So what we are saying is, and of course we need to grab it here, param in the double quotes, use this as key. So what we are saying, select everything from this table whose alias is this, where this table, so this entity, let's go to that, where this entity, this fields, this field. So inside the property, this field, and inside this this field. So that's what we address with dot operator. So we have this. Let me close some files. So here we are saying from the property entity, get the user entity and go inside the user entity with and compare the ID with the user ID that we will pass from this parameter. What we will receive, we will pass this as a parameter to the function. And if there are more fields, then we can continue saying and or, and then do it like this. Let's say p dot title equal to something, p dot title equal to, let's say, colon title, and then we could have also given it here, copy paste this another parameter, and we could take this title and put it here as a key, and this, so we can have these kind of query also we could create, but for our case we don't need this, so I'm going to just make it undo. I will leave this query and I will get rid of this one, or let's say I will duplicate this line, Control D, and also uncomment comment this one, and we will get rid of this one. That's it. So now nothing changes, everything will work as expected. We have this query, so we can write query either by this or also with @query annotation. So if I run this application and try to access it again, it will be exactly the same thing. So now we did one more thing in our entity. What we did, we kept many to one fetch type lazy. What we did is whenever the data for this property will be fetched, we don't want it to fetch the user data. Whenever we will need the user data, we can fetch it by directly calling it. So that's what we said. If we don't give this fetch type lazy by default it's fetch type eager. So when we will fetch the property entity, it will also fetch all the details of the user entity, which we don't need. So let's go ahead and try to see if that's the case. So if I hit this now, so we get the same result without the information related to other details. And if I go here and change this to eager, let's go ahead and see what will happen. So let's try that out in the next video. Thank you. Welcome back. Now what I want to do is I want to comment this. So by default it will become fetch type eager. And what I want to do is in our service Ampere, I want to put a debugger to show you what will happen now. So this is our property. So here, let me put a debugger because this is where our all properties are fetched for a particular user. So let's run the application in debug mode and try to see what are we getting in terms of user information in the property entity. Till now we are just getting the user ID. But if I now do this, what will change we will see. So let the application start. Starting up, clear it all. It has started. So let's go ahead and hit it. So we have the debugger now. If I hover on this list, there's one item. If I hover this here, you see now we don't get the user ID only. Rather we get the whole user entity information. We get the user entity ID, name, email, phone number, password, everything. So that's the thing about getting it as a fetch eager. By default, it's eagerly fetching the user information also while fetching the entity information. So for many to one type of relationship, whenever there is one, by default fetch type is eager, which means whenever a parent is being fetched, all its child will be fetched. But whenever it's star too many, when there is star too many, from whenever there is star to one, fetch type is eager. Whenever it's star too many, by default fetch type is lazy. So we can change the default behavior, but this is what it is default. So now if I resume this, we will get the same result. And if I change it for, let's say, user ID 1, we will get two items and both of them will have the same repeated user because the user is repeated, remember. So it's such a waste of memory and network bandwidth that we are fetching the same data, user data, again and again. That's why we don't want to do fetch type eager here because we don't want this user data. If we get the ID, that's more than sufficient for us. So if I resume this, this is good. So now let's go ahead and quickly take a note of it. I will stop this and go to the notes. And I can say here for star to one relationship, default is fetch type dot eager star to one. For star to one means many to one to one, anything. For star to many, which is many to many, one to many, fetch type is lazy. Eager means while getting parent data, also get child entity data. And lazy means while getting parent data, do not get the child entity data. So this was about fetch type is eager, fetch type lazy. Thank you. I will see you in the next video. Welcome back. So let's quickly talk about what will be the relationship for one to one. So let's say we had another entity called address. So one user can will have one address. So in that kind of scenario, we would have said it will be a one to one mapping. So if I quickly go and mention this like this, address entity, and I'm going to just say I will just quickly copy things from here for the address entity, and this will be our address table, and this address will have, let's say, private, the, let's copy this primary key thing, then we will have, let's say this address as private street string street, and we could continue to give anything, private string city, private string zip code or postal code, private string country. If we had this kind of relationship, for now this is sufficient, or maybe also house number, private string house number. In this kind of situation, we could have also kept user here, said private user entity, user entity, and we could have said at rate 1 to 1, and here we could say join column name. We could have said name, we would give any name. We would again say user underscore ID, which means whenever the table for the address entity will get created, the foreign key user ID will be created inside that. And of course, we can say this as nullable false. So if I run this now, we will see a new table will get created with address table as name and user ID as another column in it. So that for one user there will be one address. So when user is trying to register, we can take his address information, create an address entity, and save that address entity here. So if I run this application, So it's running now. So if we go and see now, connect, there's an address table. And if I run, in the address table, we got a user ID. So now if we wanted to have a new address saved for a particular user, we could do that. In the next video, let's try to do that. Welcome. So what we want to do now is while saving our user, we want to also save the address information provided by the user. So for that, we need to create the address entity, or we already created address entity. We will create address repository. Address repository. So this should not be a class, it should be an interface. So let's change it as interface. And this, of course, we can copy from here. So there is also a JPA repository. We are using CRUD repository. With JPA repository, you also get advantage of pagination and sorting, which we can also implement with CRUD repository, but in a different way. But if we are using JPA repository, the pagination and sorting comes inbuilt. So let's go to our address repository, and here we say extends, and we will change this to address entity. And now what we have to do is we have to go to our user service, and we have to auto wire the address entity as well. Sorry, address repository. And what we have to do now is in our user DTO, we need to add some fields, and then take those fields, and these fields will be most likely this only what we have added in the entity. So I can grab it from there. So I will copy them and add them here. Now in the not in the property service, but in the user service IMPL, here when we get our user, here we have our user now. So now what we want to do is we want to create an address entity, address entity, address entity equal to new address entity, and we want to set the values of the address. So I will copy this dot set, will say house number as user DTO dot get house number, address entity dot set city as user DTO dot get city, address entity dot set postal code as user DTO dot get postal code, address entity dot set city house number country street, let's say street, user DTO dot get street. Then we have country, address entity dot set country as user DTO dot get country. Once we have created the entity, address entity, what we will do is in this address entity, we will save the, we will also set the here, let's say address entity dot set user entity. And this user entity that we have received from the database, this one, after saving in the database, we will take this and paste it here. So let me cut everything from here and paste it here. That's it's more logical and logical place. And now as we have set this entity, we can call the address repository dot save, and we can save the address entity here. As soon as we save, this address will be linked to that particular user which got just created. So let's go ahead and start our server and try to test this in the next video. Thank you. Welcome back. Now let's go to our save or register user. So let's check which was that. So this is our user registration. So here I will say Jack. Maybe I will say this also Jack. And this time I will also provide house number, and I will say 2223, street as ABC, postal code as something, city as city, some city, doesn't matter what city, country, let's say some country. And now when I try to register the user, it has created the user successfully with the name as Jack Dow. And let's go and check in our database what did we got. So if I run this, so if I connect again, let's go to check the user table first. So here we have our new user with ID 321, user ID 321, Jack Doe. Let's go and check the address. What is his address? So we see the user ID with 321, Jack Doe has this address. So now when we will try to fetch the user, we, while fetching the user, we can also make another call to this particular table, to address table, and get the address of this user with the help of this particular column by writing query like this we have written in the past. So we can write queries like this. We can say select A from address entity A, where A dot user ID this equal to that, the parameter user ID. Or we can write query like this also. So it will return us the address object of that user. So this is how we can fetch that. So this was about one-to-one relationship. Thank you. Welcome. Now, if we go and look at our application in our POM XML file, we will find out that the version of Spring Boot starter parent we are using is 2.x, which is 2.5.9 in this case. But if we go to the Spring initializer, we see that the latest version of Spring Boot is already 3.x. So if we go and see, this is the latest stable release version, which is 3.2.5, which means that we can decide to continue to run our Spring Boot on the older version. But that brings us with some risk. The risk is there can be certain security issues or vulnerabilities in the old Spring Boot. And then there can be also some dependencies which might not be compatible in future with the older version of Spring Boot. Hence, it is very important for us to upgrade the Spring Boot version from time to time. Same goes for any other third-party dependencies that we are using in our application. Why do we do this? We do this to make sure our application is always up to date and free from security vulnerabilities, but also the quality of the application is good because it is compatible with the latest version of other dependent components. So now we know the reason why we should upgrade our application. So in the next video, we are going to follow a step-by-step approach to do the upgrade from Spring Boot 2 to Spring Boot 3. I will see you in the next video. Until then, thank you. Welcome back. The first thing that we have to do for upgrading Spring Boot 2 to version 3 is we must at least have Java 17 installed, and this needs to be pointed in our pom.xml. So what you can do is go to this Eclipse Adoptium website and choose the operating system, let's say in this case Windows, and then 64-bit, and go ahead and take, let's say, you can even take 6, 20, 21, 22, whatever you want, but at least it should be 17 minimum version. And you can download this as MSI or zip, and then if you're downloading it as MSI, install it. It will set the class path also, but if you're downloading it as zip, you have to set it as in your class path and Java home. So this is the minimum requirement for using Spring Boot 3, that the JDK must be 17. On the IntelliJ, you can go and point it via file, project structure, and in here it should be pointing to Java 17. Once this is done, then we need to also modify the version in our pom.xml properties file. So let's go ahead and do that. In here, I can mention 17 as a version, and on here, in here, you see a small Maven icon. If you don't see that, you can click here and you can basically refresh it, reload all Maven modules, and then you can go to lifecycle, do the clean and install. So let me first do a refresh. It should be quick enough. And then we can do a clean and install. Press play. So now it is going to take Java 17 and build our project for us. So let's wait. So it's recompiling all our source code with Java 17, JDK 17. And JDK 17 is the minimum Java requirement that we should have for upgrading to Spring Boot 3. So let's wait for this compilation to be over. Once this build is done, we will see a successful message. So it's now building the jar. So we see that it has built successfully, and this time it took the JDK 17 that we had provided, and we appointed it with the Maven properties java.version in our pom.xml file. So this was it for this video. See you in the next one. Thank you. Welcome back. Now that we have upgraded our application in such a way that it points to Java 17, now it's time for us to follow the next step. In the next step, we need to visit to the Spring Starter website and look for the latest Spring Boot stable version. So here I am on the website. We have different snapshots available with 3.3.0, but we will go with the latest release version, which is 3.2.5. So we can basically click here and click on explore here, but this is giving us the Gradle form. We are using Maven, so choose here Maven and then click on explore. You can also change as Java 17 here. So click on explore. You see that it is now giving us the version 3.2.5. So we need to take this and modify it in our POM. So here's our POM. So we will say 3.2.5. Right now I am using 3.2.5, but when you are doing this and if you see a newer version available, newer stable release version available here, go ahead and use that instead of this, because we should always go for the latest stable release version. So here it's 3.2.5. Once we have done this, then we need to reload all the Maven. So let it reload. So here you can see it's saying resolving dependencies. So what it is doing now is going to the Maven Central website and looking for this particular parent and down trying to download this. So here we see we got an error. It says unknown. So here we have one problem that says MySQL connector Java POM is unknown in this Maven Central. So what we will do, we can have this kind of problem. So we'll go with one by one approach. Like we will comment this dependency for now, and we will try to first upgrade it to 3, Spring Boot 3, and then we will later fix this issue. So now after commenting this, we have reloaded. Let's see if it is downloading all the dependencies. So now we can see it has synced it and we don't have any problem. So what we will do is now we will try to do a Maven build. So click on clean and install and run this. Alright, now we see different compilation error in our project. You see the whole project turns out to be red, at least in this entity package. So if I try to open one of the entity package and go and see the import, we see that it is saying cannot resolve the dot persistence package. So we need to fix this. How we can do that is by changing the JavaX to Jakarta, because in Spring Boot 3.x version the JavaX package has been moved to Jakarta. So as soon as we do this, we see the compilation error gone. So let's go ahead and try to rebuild it again. And if we find more such problems, we should make sure we build the project by modifying the Jakarta property. And we do see there are different other errors in different other packages. So that needs to be also fixed. So you have to go ahead and modify this everywhere. So Jakarta is the package. So here we have it in the address also. Let's go ahead and so in the address it's done. In the property it's we need to fix it. It's done. In the user also it's done. So now let's go ahead and try to do the build again. So here we see that we again get the same problem. So now we fix it by replacing JavaX to Jakarta. You don't have to worry, you just have to click on Maven build. It will tell you automatically where are the errors and you can go ahead and fix them one by one. It's a straightforward process which you can follow. So now it's again doing the build. So here again in one of the controllers we have the issue with the JavaX package. So now we will build it again. Here we were using a direct valid annotation. That was the reason why we got that. So let it build. And if we don't have any JavaX dot packages, then we should get a build success here. So now it's downloading everything. Let's wait. Alright. Now we have some problem with our test. So here it says there is a test failure, but we don't have a compilation error anymore. That is a good thing. So here we see it says there is a test failure because a class not found java dot servlet dot request. So we will fix this in the next video. But for now, our compilation error issue is gone. So I will see you in the next one. Thank you. Welcome back. Now we need to fix this issue that it doesn't find the Java HTTP servlet request. So the reason why this issue happens is because the Swagger dependency that we are using in the Swagger configuration that we are using, it is still being used from the Spring Boot 2 aspect. So first we'll go to the property management and here we'll comment this. We don't need this. So we will get rid of these two. Perfect. Then what we have to do is we need to go and open the Swagger config file. In the Swagger config, we don't need this implement web MVC configure. This needs to go away. And then of course this dependency is not required. Import. We need to go ahead and add a dependency which is supportive of Spring Boot 3. So now we have Spring Fox. We will delete this. This is not required. The two dependencies that we will need is Spring Doc Open API Starter Web MVC UI and Spring Doc Open API Starter Web MVC API. So these are the two dependencies we will need. So let's go ahead and add them. Let's reload, let it download. Okay. Then what we have to do is it has downloaded all the dependencies. Now we need to go to the Swagger config and instead of this bean, we will get rid of this bean. We will define another bean and that bean is grouped open API bean. So let's copy this, paste it here and let's hover on this and import this class and we'll give here the group name as app APIs and it will track everything which is under API and star star. So we'll get rid of all these dependencies. Perfect. Next in our controller, we also need to modify something. So here is our controller. Let's look for the annotations that we had used. So this is an annotation which is coming from Spring Boot 2. So what we will do is we will go for operation. Let's import this. So here we can see we can get rid of these two annotation. Instead, we will have the one from this. So what we'll do is we'll copy this to look for the usage. So go to the browser and enter this, and then we can go and see how to use this. So it says the @ operation. We can give some kind of description here. So what we will do, we'll go here and say get rid of this, and we'll say description. That's it. Similarly, instead of this, we will have something called as parameter. And the parameter will have again certain attributes. So we'll give that here. So these are the different annotations which are coming from the new Swagger related dependency that we have added, which is Spring Doc Web API, Web MVC API, and Web UI. So remember this one. Because of this, we can use now different new annotations. And they are of course coming from a different package, which is ioswagger v3 OAS annotations. So now, after doing this many changes, we should be able to build and run our application without any problem. So let's go ahead and build it. All right. Now we see that it is building the package and we have the build success. Perfect. So now what we'll do is we'll start our application. Let's start the application to see if we are able to access our Swagger documentation without any problem. So it is starting up. So here it is. It has started. So now let's go to the browser, refresh this, and we can see the app-apis group loaded. This is our dependency, all the property controller related endpoints, user controller endpoints, calculator endpoints. So if we want to add something here, let's say we'll say try it out, and then we'll pass 1, 3, 4, execute, and we have the response as 4. And if we want to multiply something, let's try it out. 1, 2, 2, 2. So here's the response 8. Same way we can access any other data. In the user controller also we can see different information. So this is the description that we had added, which is this one. This is the method used for the user registration and the parameter. Let's see. So this is a parameter. So here we can clearly get the information which we are providing here. So now without any error, we have upgraded our Swagger 2 to Swagger 3 using Open API, and everything is working as expected. Thank you. Welcome. Now it's time for us to go ahead and check our database configuration for MySQL and if that works properly or not. So far we have been checking with H2 database and everything seems to be working fine. But it could be a possibility that you are not using MySQL and using another database. So let me show you the way how to find the right fix for your particular database. So my SQL database for me is enabled in the dev profile mode. So what I'm going to do is I'm going to go ahead and go to my properties file, application properties, and change it to dev here. And when I start my application, let's see what happens. So here we get a problem. As soon as I move to the particular mode, like the dev profile mode, what has happened is the dev profile mode has been kicked in and it has triggered also the log back with SLF4J for the dev profile mode. So there we get an exception stating that something has changed in the SLF4J because of which it is not able to recognize the format, the encoding format. If you see here, the log converter pattern format, it is failing because it is expecting something is related to, it's saying fail to pass integer string number format exception. So there's a data type mismatch. So let's first fix that. So this is our logback XML file. In the dev profile mode, we have file as info as the log level, and this is the appender, file rolling appender. If we go to the file rolling appender, we'll see this encoder pattern. And here is the problem. It is giving exception because it's not able to pass this pattern. It can happen because Spring Boot 3 has an SLF 4J version which could have changed its class and passing logic. So I have removed this because in the error it was complaining about like this, the pattern that we just removed, one dot, something like this. And if we see, we are not getting this in our std out format because there is no such pattern. And std out was enabled in local. So local was working fine. If we would have the same pattern in local also, we would got that error. So now let's try to run this. So now it looks things are working as fine. Great. So now our dev profile is enabled and we have a database of MySQL connected So now let's go ahead and try to insert or get some data. Let's say post property. We try to get a insert some data and we got some error. So let's see what's the problem. The application is stopped, so we are not able to connect to it. So I will start the application again and it will start in the dev profile mode, which means it will come here and this database will be picked up with other driver settings and dialect settings. So let's wait. So we are getting the same problem, which means the application is getting its application is stopping. So let's check the logs because now it is the dev mode. So file log will be enabled. So in the logs, file log, and what we see here is it is saying that this particular Hibernate dialect is not found in the MySQL. So we need to now fix this problem. We need to provide Spring Boot 3 with the right version of MySQL so that it has this particular specific dialect or a similar one. So let's go ahead and see how to fix this in the next video. Thank you. Welcome back. So the way we need to approach this problem is go to Google and type Spring Boot 3 with MySQL database. Or you can even take the error code and Google it. But I will show you both the approaches. So here, let's say there's a guide about how to develop application using Spring Boot 3 and MySQL. So here we see in the Spring Boot 3, let's directly jump into the configuration. So here we can clearly see that this is the dependency we should use, which is com.mysql connector j. But what is the dependency we are using now? Let's go and check. In the POM, we are using MySQL and MySQL connector Java. So we will get rid of that and paste this new dependency, this one. So I will get rid of this one. Perfect. Next thing that we have to do is we have to see the properties if they are good or not. So here we see the dialect which we have to use is this. And what we are using now is this, which is MySQL 5 InnoDB dialect. So I will replace the dialect as well. So this is one way to find out the implementation and execute it. The other way is to just go and Google the error. So let's say class not found. This annotation, take and paste it in the internet. If we click here, we will see the reason why. So somebody says that you need to go and use this MySQL dialect. But we have to also write Spring Boot 3 in front of this. If we write this, of course there's a dialect which we are getting, but we also need to replace the dependency. So let's go here. Yeah. So here they are saying that this is an old article. No point in checking that. You should try to see the latest article, which is because the Spring Boot 3 is quite latest. So here everyone says to upgrade the properties. We have already done that. But what about the dependency? We could also go here and click here and type MySQL driver and click on explore, and you see it gives us this dependency to use. So I think this is the best way to do the dependency search, because here it automatically provides us this dependency for Spring Boot 3. Instead of looking on the internet, we can get it directly from here. So now we know that we need to have the dependency which is going to support Spring Boot 3, which is this one, and we also need to update the dialect property. So let's update the dialect property in other places as well. In the acceptance, so that all other profiles will also be stable when they are running on MySQL database. And now let's go ahead and start the application in the dev profile mode. Let's clear everything. Now the application should start properly, and see that there are no errors. Also, let's check the log file. Let's see, the last log was 1448 without any error. And now we will go to Swagger and try to execute this. And we see that it has created a new property. So if we go and try to get all the properties, it should have two. One I was created earlier. So this is the first one, this is the second one. So what we are seeing is it is working as expected without any problem. And everything is working fine. Even the logs are working fine, which means that our database upgrade or the Spring Boot 3 with the MySQL database migration is also looking good now. So thank you for watching this video. I will see you in the next one. Welcome back. So in the last video we saw how to configure Spring Boot 3 with MySQL database. If I go to the tables, we can see the data that was inserted properly. Similarly, you can configure MySQL, your Spring Boot 3 with any other database apart from MySQL as well, like Postgres or MS SQL Server. Just that you have to Google with the Spring Boot 3 with the database name, and you will get the configuration like new dependencies, and maybe some property files needs to be modified. So let's go and now check if our management endpoints are working fine, which is from the actuator. So if we go to the actuator slash health, we see that its status is up. That is working fine. If we take metrics, this is also looking good. No problem with that. And if we take info, because when you upgrade the application, you should make sure everything is working. You should not get any exceptions or errors. Environment, these are different environment properties. They're also working fine. Let's see the beans. So these are different active beans at this moment. And config properties. So these are different key value pair config properties. So our management configuration with actuator is working as expected. So we don't have to modify anything. The upgrade of the Spring parent dependency already took care of this particular functionality. So it means that we don't have to worry about all the functionalities. If only those functionalities which break, we have to fix them. Otherwise, by default, Spring will take care of those functionalities. But in our case, let's say the logger failed, so we fixed it. The database failed, we fixed it. Similarly, we saw other things like the imports we need to do with from JavaX to Jakarta. We had to fix the Swagger. So these kind of things we had to fix. Other like for example the management info with actuator, it was not required a fix. It worked automatically out of the box. So you have to check all functionalities of your application after upgrading the parent of the Spring Boot, and the ones which fails you need to fix them by doing Google like we did, and the ones which are working you don't have to worry, leave them as is. So this was it for this video. Thank you.